Ready to start? Everyone, thank you. So happy to welcome you again after the second edition after pandemic, but overall, counting also the pandemic, is the 12th edition of our Kamailio World. Brand new venue. I know many of you have been in the past. Hopefully now, at least it's a bit more comfortable with the table. That one was smaller in size, and to accommodate the participants, as you can see, we are again fully booked. Only a few seats are gonna be missed. Some people had to cancel as well, but more or less we are like a full house here for this post-pandemic size that we target. And yeah, we had to do it a bit earlier this year, in like mid-April. I think we had it in April in the past, but the main reason this year was this European Football Championship, which is June, July in Germany, including Berlin, and May got crowded than usual, so it was not easy to find a convenient location. But at the end, April proved to be quite good. The weather is not reliable, but still occasion. We need to keep you inside for this interesting presentation. So as usual, I'm gonna have the welcome and present the let's say logistics infrastructures around this new venue for a while. Ramona, my colleague, will join a bit later with another presentation. But first, of course, big thanks to our sponsors that make it possible, especially to accommodate speakers, and we try to squeeze in as many slots as we can. I think I should start with Seedgate because they sponsor out all the editions and everything that we organize for Kamailio along the years. And they also host our development meeting in their office in Düsseldorf. But then we have Andreas and Seafront joining us again. You might know Andreas from former company, the SIP-wise, but now he's having a fresh, much more interesting startup now, helping you to fix your configs, detect the broken calls, and so on. So actually, Andreas has also in the breakout room like a spot where he can do demos. So there you'll find also Snom, another sponsor, and Snom, as usual, they are kind enough to give some nice giveaways, some phones, and they have other merchandising around. Christian from Snom, it's back there, has also a table in the breakout room, which again, you go on this corridor, and on the left third room will be only today available. Then Tulio is returning also with a presentation. I'm grateful that Lucas and Shai are this edition with us. We'll share something about the Steer Shaken. And actually, huge thanks for this edition, but not only, because also for many, many editions, Pascom, they come with this very impressive technology, and this time they accommodated also for the new venue, everything now with audio, video, and streaming. I'll give the link. So Mathias, Thomas, Sebastian, and Jan, huge thanks for taking care of all this streaming, speaker, accommodating the speaker with adapters and so on. It's really impressive what you guys do. Federico, Libon, Philippe are also here. They are coming also to developer meeting, helping with coding and also supporting us. Simon, you might know, like pre-pandemic, he was also like supporting Kamailio World, at least. Seedgate supported also our other events, but Simon is also a very good friend of our community, to say it. Already mentioned SNOM, don't forget Christian asked about the features. I can tell that from my point of view, I use SNOM because of their web interface where I can look at the traces, SIP traces, especially now that everyone is using TLS. It's very convenient, maybe at least for my eye, as familiar with SIP, to look there. It's really convenient, so I do like them. They are also based in Berlin. We know each other, like with the SNOM company from like early 2000s, so when SIP was at the beginning. And then we have Fred, which always supports us with not only the conference, but also on the community side, offering servers for hosting packages, for building, for Matrix channel and other forums. And he approach him at least for API ban. This is very good for security. And if you are not sure why you need an API ban, ask Sandro, which is the author of Friendly Scanner, as you know, and he will make you scared about what can happen on the public internet. Actually, Sandro can also do you some demos for security in that breakout room. And our, let's say, friend, partner conference, ClueCon, we have the SignalWire FreeSwitch guys around. At least some of them are drinking, like Ivan. I see Giacomo is here, and later some other guy will come. So this is going to be in Chicago. FreeSwitch developers organizing it. I'm going every edition because it's good to meet the North American voice community. Many from North America actually came here, some of them speaker, Julien from Canada, and yeah, Fred, Lucas from Twilio coming from USA. So I'm happy to have here a really good coverage of the, let's say, our Earth. We have Richard that's going to present about TLS from Singapore. We have also participants from Australia and Asia, Middle East, Africa. So we pretty much cover the entire Earth. Say. Shortly about the session, there are some flyers if you want to get like a hard copy, but not so many because we printed over the years and then we had to throw them online. You'll find it here. It's just the structure. So drinks we have in the back. They will refill. Coffee outside when you go. Manage yourself with coffee machines. So all the day they are available. The lunch is going to be in the restaurant. It should be like an area reserved for us. I don't know exactly where, but the restaurant is in front of the lobby. So it's 20 meters from here. You go there and will be some signs and we'll be able to guide you. Will be another coffee break in the afternoon. And after today's presentation, we have the social event, cocktail party, which will be on this area again, trying to facilitate people moving around, not to get like people sitting on a table and they get together with 5 other people and so on. You'll have non-alcoholic drinks plus beer and wine as usual. If someone wants something else, I think there is a bar for, I don't know, other spirits and so on. But this should be covered. From here will be like 2 hours around, which it's a good balance between, not getting very tired and be fit for the next day. For the demo and showcases, I said SIPFront and SNOM have some spots there, and then others like Sandro or maybe Fred or Ramona eventually, if you want to see some devices related to 5G. Yesterday it was an event and we could do demos there. I think a couple of you were there where we demonstrated the voice over new radio using Kamailio, stock Kamailio. So it's working for 5G. What we had from like 2008 in Kamailio, thanks to Dragos, which is back there, who wrote first the IMS extension for Kamailio. Now he went for a while to other layers like EPC data layer for mobile networks. So it's quite a lot of knowledge in this room besides the speakers, and actually some of them you might know, like Nick versus networking, which is coming from Australia, and we should plug him somehow for this trip. I'm trying to find a solution for you. He's also author of PyHSS for those that work in mobile network. Yesterday at the Technical University, he presented shortly. Here we don't have the 5G license testbed that it's available at the Technical University where Ramona is also coordinating some research. But yesterday in that location, we could see some demos, not only from us with Kamailio IMS, but from other projects like SRS Run and so on, using local private 5G networks. Then the interactive sessions today, again, repeating with this showcases room, breakout room. We'll have a panel, so I'm gonna get some people around and shoot them with some questions. Tomorrow morning, I will start with some Chemie updates, and then we switch to Ask Me Anything. This edition is also shorter, so we used to have this kind of workshops, the pre-conference half day in the past, because this one was quite popular and people can ask anything, and we have many developers here. I can probably count like 10. So we have Julien, we have Federico, even Andreas there, even is doing testing. He's a developer, myself, Henning is around as well. Sorry if I miss someone, but I think I'm counting like 10 developers that can ask your questions about Kamailio and also voice over IP, why not? And then we have the popular kind of short presentation session from the SIP Gate team. I think Jonas and Andreas will be the coordinators for today. So I'll pick up some of you if you don't go alone. And then we'll fill this one till tomorrow. You don't have to speak necessarily about Kamailio. If you do something interesting in VoIP space, real-time communication, and you want to get 5 minutes here, please do it. Because again, I know, because I met you before, most of you, that it's a lot of knowledge beyond the speakers. It's really much more knowledge if you put all together than what the number of the speakers here. So come to the SIP Gate. They have t-shirts, or you can spot them. If not, tell me and I will point you to the right person. And this would be for the interactive social networking. For the Wi-Fi, he's the hotel Wi-Fi. We haven't put any infrastructure by ourselves. It looked working pretty decent, better than expected with hotels so far. In case of emergency, we could try to use the streaming link, but we rather, which is dedicated, we rather leave it alone for recording and so on. Some references to LinkedIn or Twitter if you are on that group. And then Matrix is a chat room run by Fred here. It's one for Kamailio World as an event, but if you are in the community, there is one for the users group, and it's quite active lately. I'm not much into chatting myself, real-time chatting, but I'm there sometimes answering. And for live streaming, You can go to the Kamailio World channel on YouTube and should be probably live if everything is working right now. The exact link, you'll find it there. I don't have it right now. So again, thanks to Pascom for live streaming, but also recording and taking care of all the audio video that we needed. I'm refreshing about this VAT. So part of the registration fee, 19% is the VAT. If you are in Germany, it's easy to take it if you are a company with VAT. Within European Union should be also some easy process if you want to get this 19%. So we paid it, so it's not for us. It doesn't cover the cost for the event. It doesn't stay with us as a community or as a company. It's your right to claim it back. And don't forget about this notice that you should take care of your belongings, especially wallet, passport, IDs. These are very important. Usually we didn't have any incidents on site, but I noticed it's another event around, and it's a hotel, it's public kind of venue. So have good care of your important stuff because we cannot take any liability. Once again, thanks to all the speakers, and not to get very late, let's go over what we've been doing during the last year. I'm skipping my presentation. Most of you know, if not, catch me on I'm here all the time. Also for the new people in the community, a brief evolution of the project by name, like SCR, OpenSSL, Kamailio, and also putting here quite a lot of releases. We are now like 5.8 already released like 1 year ago. So we started as a research project at Fraunhofer, focused here in Berlin, and over the years with some forking, renaming, we ended up with Kamailio as a name. So now, from the last year and the current year, I think I covered last year because we had it in June, version 5.7, like a release series. I just put here to refresh about it. 4 new modules, very useful, at least from my point of view, was this alternative to TLS with Wolf TLS library from Richard, which will have a presentation later about OpenSSL and Kamailio TLS, some extension for Ruby and Python, and some mathematical function. And if you haven't noticed, this is one of the feature I really like from the previous major version of Kamailio, where you have this condition, pre-processor condition with expressions that allows you to do condition in the version, in the modules, and comparing with strings, greater or less. So I do like it. Of course, I develop it. It's my baby, so to say it. And now what we released like 1 month ago, I mean, there is a lot of work to existing modules because there are no new specs that we need to really catch up as a project. It's a well-established SIP server, Kamailio. We try sometimes some alternatives, some improvements like file out, Xenophon, it's here and already here. It's back there. Standing up, for example, and I added an alternative for cryptographic connector for Influx DB, and a module for HTTP server behavior. We had our embedded XHTTP, but it's only HTTP 1011. If someone needs more, should use this as a replacement to execute like RPC or get states from Kamailio. And then also quite a lot of work in existing modules. And here I'll chat again about this huge effort that Richard did it for TLS, digging in the libSSL, discovering some, let's say, internal architecture for the threads and make it safer in Kamailio. There was a little bit intrusive at some point, but otherwise there were kind of random crashes on TLS, so was a little bit fluid at some point, but I think it solved it. Then quite a lot of options now for TCP to detect this kind of stale connection or someone connecting and not sending anything. Of course, it adds some penalty to check all this, so you can also disable at some if you don't need it, if you have like trusted environment, but for public internet that could be good. And then also IMS extension 5G, it's kind of a buzzword these days, so there are many enhancements that allowed us to have the live demo yesterday at the Technical University event. SIP overload control was another area that you could identify, not as a module, but some components got extension to work more flexible with the via parameter and check those via parameter related to overload control. And many other. This is just a summary. The main point is to go to that link and read there. And even if it's only 1 month since we have the major release, already the Well version has 2 new modules. Again, towards this 5G integration for HTTP direct connection. Pseudo variables templates, this is actually quite nice because if even for other like API interaction, if you need to build like a JSON in config file and it can get ugly with plus or whatever expression you use there, with this one you can have a file where you put this kind of JSON, but inside it you can put Kamailio variables. And then in config file there is a function evaluate the template. Before that you have to set the variables that you have in the template file, and then you get it in another variable, which then you can push it via HTTP or whatever. So this simplifies the config file. It's not like you couldn't do something like kind of feature before, but with this one you have the config file simpler and easier to understand. And also quite some work related to SDP, to access SDP, and it's work in progress, this one. I want to do like an SDP path kind of. Yeah, Tori?
Just a question. You mentioned that the HTTP to support an HTTP client. Can I also assume that it's also been added to the async client?
Async client, not yet, but probably will be added. So we need it mainly for the 5G to do the QoS, and it was the easiest one to go. Actually, Ramona did the patch for HTTP client, but should not be that complex to do it because it's using curl behind. It's just internal Kamailio, but we didn't have time to look into it, and maybe Federico has more time to see. So that's actually from Kamailio point of view. We did have the Kamailio developers meeting in at SIPGate office in Düsseldorf, and we plan to do it again this autumn. Usually it ended up like November. Sometimes we try to do it in October, but it would be like this time frame, October, November. So that's free event to come. The SIPGate, it's very nice. They give us Frühstück or breakfast and lunch for free, and they have also like a pub for the evening. They order food, pizza or whatever, and playing sort of bowling. I forgot the German name. It's really nice atmosphere. Of course, free to attend, but you still need to pay your like traveling, and you don't have to be like a developer to join it. You can help also with documentation. There are discussions about what to do in Kamailio. Sometimes you see a flooding of commits and sometimes breaking because it's not much discussion. I think it was this not with code, but with the workflow from Victor, closing a lot of like issues at once because it added this kind of timeout for no activity. Okay, to cut it short, I have the slides for the related projects like ChemCLI. If you haven't played with it, really look, it evolves and has nice features. Then for Stir Shaken, we have a tool, so it's a Kamailio module as well based on this library, but if you need to play from command line, look at this project, which is also open source. I'll be giving a few SIP routing with Kamailio books It's kind of old, but maybe good to start with. I plan to update it for a long time, but it's always something in the way. And short summary of the resources. That would be, sorry for taking 5 minutes from Fred, but I know he's fast always. So if anyone has a quick question until Fred sets himself here. Otherwise, I'm here all the time, you know. I might be busy with some admin task, but this evening, tomorrow, should be easy. So far, everything works so smooth. Hopefully, the Wi-Fi is decent enough for everyone. If not, let me know. So, question, anyone? No? Okay. Thank you, then. Okay, so knowing that some people are jet lagged, I put Fred in early in the morning. Hopefully it's in good shape to start the day after a long trip from, let's say, ugly Florida, right? He enjoys now Berlin weather, a bit of freezing. I'm not sure if they get to this kind of temperature. I mean, it's not bad, like 10, 12 degrees Celsius. But anyhow, Fred comes today to show us some experiences that he had with HTABLE, which we both love. I wrote, and Ramona wrote, and he loves it as well. And REDIS, which is amazing fast. And I said he's also managing and developing API ban for the security. Approach him during the breaks and maybe take him to do you some demos around. You don't have to use that room. There are also some chairs on here on the hall lobby. It's not far. So as I said, try to squeeze from all the other people here their knowledge because it's very valuable. Sorry to take another minute from you, Fred. Please go. And thank you for coming again to our event and supporting us as a community and event.
Thank you. Thank you, everyone. It's great to look out and see. I love being part of this community. I love being here, so this is great. HTABLE versus REDIS. I've been using REDIS a lot more in other projects, and so I had to incorporate it in Kamailio, and I was actually kind of blown away with how well it performed. So I wanted to see, well, is there a significant benefit to using, let's say, REDIS over HTABLE, or is there a significant difference the other way around? So is there a performance benefit? And as Daniel said, I'm built for speed, so the quick answer is yes. Thank you. See you guys next year. All right. Yeah. Quick agenda, and I'm going to try to go quick through here. So we'll start off with an introduction, brief introduction about what HTABLE is for those that there should be, everybody here should know HTABLE because it's great. Brief introduction about Redis, talk about the test and the testing aspects that I use, and then the results, and any questions if there is. So I'm Fred, that's me and my daughter. Love her, miss her. I'm a consultant based out of Gainesville, Florida. My favorite job right now is just being her dad. Based in the US, if you need to contact me, qxork.com, and I absolutely love Kamailio. About 3 to 4 years ago, I launched API ban. It was started because of conversations that we have in breaks here where everybody's like, hey, I constantly get hit from friendly scanner or from probes. A lot of times now, it seems to be invalid SIP that's hitting me, maybe DNS or something like that. But I'm constantly having hit. There should be a way for us to share this information so we can block these IPs and that is what API ban is. It's a free service thanks to sponsors, some of them in this room. We're very grateful. So it's free. You can go to apiban.org and get a key and launch it immediately. It's integrated into CAM-CLI. There's a Go client that automatically blocks in IP tables for your system, as well as fail to ban. We just put a Go client for that one. And we also have IP tables API, which allows you to use any of the information that you might have, let's say in HTABLE. If you see that one comes in there, you can block it into IP tables yourself, and there's examples, and enjoy it. So HTABLE, moving right along. Daniel has one of my favorite quotes that I bring out every year. If you're not using HTABLE, you're doing something wrong. Well, let's see if that's the case. So HTABLE is Kamailio's custom caching system. You can replicate it to all your nodes via DMQ. It's stored in shared memory. It supports auto expire, manual expiration, and you also get some built-in event routes when you run HTABLE, so you can do something on the start of Kamailio, run in the mod init, and you can, but remember, you only have access to any of the modules that have been loaded before HTABLE, which we all learned the hard way. And then you also get a route when an entry expires, where you get access to everything in it. And you can also integrate it with a database for long-term storage. If you need to read up on it, it's part of the Kamailio modules, so you could just go to stable/htable. There's no other modules that are required, no other libraries. So it's a really easy module to load right out of the gate. You do need DMQ if you're going to run DMQ, but hopefully that makes sense to everybody now. And remember, DMQ has to be loaded first. Size limits are pretty much determined by your memory. Okay, so the more memory you have, the more you can store. It's really that simple. You can use the power of 2, so you can hold slots, and the more slots you have, the less collisions, and you can have about 2 billion slots. How does this compare to REDIS? REDIS is an open source project. I know that they've had some drama now with the licensing, but everybody's got to do what they got to do, right? Didn't MongoDB do that? And it really hasn't changed anything, has it? All right, so it's an in-memory data store with high CPS availability. I assume if there's going to be a problem with the licenses later on, there'll be a fork and we'll be on OpenRedis or something. It's used by millions of people. It supports high availability through Cluster and their Sentinel program. You can have 1 million keys with, let's say, 5 values, and that's only going to use about 160 megs of memory. So it's pretty efficient. Same as with HTABLE, or similarly, you can have 2 to the 32nd power of keys, and then each hash list or element can have 2 to the 32nd power of elements. And Redis, if you didn't know, stands for Remote Dictionary Server. I didn't know that. The way you integrate it into Kamailio is through the NDB Redis module, which is different than the DB Redis module. There's an N in front of it. It's the non-DB. So the DB Redis module is if you're using Redis as your backend for, instead of MySQL or Postgres or whatever the new kids are playing with. But NDB is when you just need to access Redis on the fly. Think of it as the difference between, let's say, like DB MySQL and SQL Ops or something. Okay. You don't need any other modules loaded first. You do need HiRedis as a library installed on your system to load NDB Redis. It supports multiple Redis instances, such as Cluster, dynamic nodes, Sentinel, and the results are stored in containers. This is an example of how you set it up. I'm going to fly through this, but it shows an example of a Unix socket through Sentinel for a slave, through Sentinel for a master. They still use slave and master terminology. This is all in the module, so you could grab it there. And then loading it is, and using it is really easy. It's just basically if, let's say, for example, I can increment a count, or if I'm going to set this, if it works, great. I can pipe commands and run them all at the same time. And then at the end, I should free my results. Let's talk about the testing. All right, so I used Kamailio 5.8.1 because that's what was current at the time. I used a Redis Sentinel platform with 3 nodes, SIP-P. All systems were on the same LAN. I used bare metal, in this case, Pis. No, but so I used a Raspberry Pi 4 with 2 gigs of RAM for each of the servers. So each of the 3 Redis nodes was a Raspberry Pi with 2 gigs, Kamailio, and SIP-P. They were all separate instances, and then Kamailio was running with 1024 memory and with 4 children. All right, so the scenario 1 was just a test to see off the bat, was there any difference? It should have been nothing because I wasn't really running anything great. An invite would come in, I would run either a Redis or an HTABLE command, and then 404 it, okay? So, or 500 if there was an error. I had 0 500s, there's absolutely nothing to report here, but it validated, okay, let me start coming up with some good scenarios. So for scenario 2, I did an invite, an ACK, and a buy. All right, because again, these are easy to do in SIP-P. And SIP-P, as everybody knows, can be just a black hole of time. So I was using just a simple get or set on each method in Redis, and then the same kind of thing in HTABLE. Ooh, had a mental breakdown there. All right, scenario 3 is where it starts getting fun. On this one, let's do an invite, an ACK, and a buy, but let's start doing a little bit of modification of data. So, okay, I'm gonna set it on an invite. When I ACK, I'm gonna get something and then set something, and then I'm gonna do a buy. And my goal here was to mimic something that might actually be done. So in this case, my mimic is, let's say, a CDR. If I'm gonna do some storage of CDRs in memory or in Redis, especially good if I'm using multiple platforms, right? But so on an ACK, I'm gonna go get what my current CDR is and then update it, and I'm gonna do that with JSON. So, there's a JSON element of the CDR in this case, and then on the buy and everything, and go from there. All right, so let's look at the tests. It really only got interesting in scenario 2, so I'm gonna jump out to that. I started off with 50,000 calls at 2,000 per second. With Redis, no failed calls. There was 18,000 retransmissions, which I thought was interesting, but again, I can't really campaign. My call rate ended up being very close to 2,000. In HTABLE, it was slightly better. Really nothing significant except for the retransmissions. As you can see, is significantly lower. 1,800 versus 16. Whoops, I went back. Went the wrong one. 1,800 versus, look at my technology fail. All right, so 1,800 versus 16. There we go. So then I upped it up to 500,000 calls, and I got really close. And in HTABLE, I saved a second. So clear cut, it's better. No, I mean, this is nothing, right? So after 500,000 calls at 2,000 CPS, I'm looking at very minimal differences. And so that's where scenario 3 came in. Okay, so scenario 2, again, was just, very little information being changed. Scenario 3 was, I'm gonna take information, set it, get it back from memory, update it, set it again, update it, set it again. So that I figured this was mimicking what we might do in the real world. So in Redis, 500,000 calls at 2,000 CPS. It took 5 minutes. I only got 1,500 calls per second. So I'm sending 2,000. My end result was 1,500. I had 50 failed calls, and I had 421,000 retransmissions. And that's where it really starts to get difference, because if I look at that with HTABLE, 0 failed calls, 0 retransmissions. It took up almost, a significantly fewer time. I got very, very close to 2,000 calls per second. And again, these are on Pis, right? And so to me, I said, all right, that's really interesting. So let me now increase my children to 16 because I have 4 CPU, I guess, technically. So I did that, and then when I did that, I had a significant reduction of retransmissions. Basically went from 400,000 to 125,000 with Redis, and I got much, much closer to the 2,000, right? So at just 4 children, I was at 1,500 calls per second, just increasing the children now to 16. I got closer to 2,000. In HTABLE, 0 retransmissions, and again, just it's a second faster than it was before. So then I said, well, let's try 5 million, right? And so in Redis, it was a total fail, just killed Redis. Absolutely killed Redis. We'll talk about that. I mean, that's pretty much because I'm running on Pies. But you know, it stopped after an hour. The call rate when I stopped it at 4 million calls was only about 1,000 calls per second. I had 600,000 plus of failed calls and over 1 million retransmissions. And one of my Redis nodes was really mad at me for a few hours. And that took I think she still doesn't like me. All right, but when I got everything back up and I tried it in HTABLE with the same 5 million calls at 3,000 calls per second, because now I'm mad because of the last one. So I even upped it 1,000 calls per second just to see what would happen. 0 failed calls, only 4,400 retransmissions. And this is at 3,000 calls per second. And I almost got it. I mean, that's pretty darn close to 3,000, right? I got 2,996, right? 27 minutes, it was great. I'm blaming the Redis failure on me. Okay, I'm running on Raspberry Pis with 2 gigs of RAM, running 5 million values in memory on Sentinel, which is a clustered agent, and on a Pi. It was not happy. So I think don't count that failure would happen in real life if you were running on a really optimized system for Redis. You could handle it, but of concern is the extra addition, right? So those retransmissions, right? That's something you're gonna have to fine tune and play with that. So don't use Pis for that kind of call load. With simple tasks and limited operations, both are very, very good. But HTABLE, without having to go out and use any kind of TCP connection to pull data and everything like that, it's just gonna be much more performant. And HTABLE, though, cannot cross-platform, right? So that might be a deal breaker for us all. If you have to use, let's say, something in where you have Asterisk or FreeSwitch update Redis, Redis is your way to go. Okay, it's gonna be performing, you're gonna have to do some tuning things. Ideally, though, I would try to do it in HTABLE. Now, I have an asterisk there because even though it can't cross-platform, since with JSON RPC, you could always, kind of use an API to update HTABLE, but then you're trying to make HTABLE Redis, and why don't you just use Redis? So some of the considerations, DMQ. All right, I wasn't doing DMQ on HTABLE. If I did that, I'm doubling, or tripling, or quadrupling my SIP transmissions. So that might increase my retransmissions, right? So think about that. So if I am gonna do DMQ, how many nodes should I do on it? Because at 2,000, I mean, we can all do the math, right? If I have 2,000 calls per second, but I'm using DMQ, I've now made it 4,000 calls per second. So you have to look at your call rate and load. Memory is the huge thing here. Okay, so you need a ton of memory if you're gonna store a ton of information. It should be something that we kind of think of, but we have so many balls that we're juggling that sometimes we forget. But if I'm gonna use a lot of entries in HTABLE, I need to increase my memory significantly and allocate that memory to Kamailio. My network is also extremely important because of the retransmissions and everything like that. I can easily jump up in packets per second. So you have to have a good local network. Does the data need to be shared? And that's your big issue here, right? So if I have this where this data needs to be accessed real time, that might be a push to Redis, because then I could have someone query that Redis server instead of bothering my Kamailio. How long do you need to retain the data is also really important. But the big consideration I had from comparing and contrasting is, have you considered the fact that some things that are different are sometimes better together, right? And so I came up with scenario 4, and this combines Redis and HTABLE, right? So I'm gonna set something in the JSON, I'm gonna send it over to Redis. when I do my update, I'm just going to update it from, I'm just going to send a set. So I'm not going to pull a get or nothing. I'm going to get my information from HTABLE and just update Redis. So I'm only doing a set instead of a get, then a set. And then the same thing on the buy. I'm going to update my JSON from my HTABLE memory, and I'm going to send a set. So Redis is going to be updated on each step, but I'm not pulling from Redis. I'm just pushing to Redis. Okay, so I did this at 5 million calls at 2,000 calls per second. It took 41 minutes. I got almost to 2,000. I had 0 failed calls, and even doing Redis, I had only 540 retransmissions. That's still running the 16 children. So if I can limit how much actions I'm doing per leg on Redis and combine the two, I can get something extremely performant. And, I mean, this was phenomenal for me. My final thoughts was, you gotta consider your overall business need, right? High performance tuning is gonna be your key if you're gonna run this kind of call load. If you're gonna be less than this kind of call load, honestly, I think you're fine with either one. DMQ is gonna get into a factor as well. RAM is your most important part with either one of these. And then you need to look at your total number, your total design. You gotta look at everything. You know, what needs to access the data? Is there a number of nodes, networks, regions? And then I put, you know, there's also other ways to share this kind of data with, you know, the later popular one of NATS with the full integration that has in Kamailio. Something else that you could do. So I could use HTABLE and then just kind of send that out via NATS and have some other process worry about it later on. Tried to be quick, so thank you. I'm open to questions about any of the testing, as well as anything else, API ban, whatever. I want to thank you for everything that everyone here does for the community. It's just such a joy to be part of this room. So thank you so much.
Thank you, Fred. And as usual, questions. I'm with the mic. If you are, we have one here. Okay. Sorry. Probably next time we should.
Hi there.
With some
Hi.
more.
Is there something like auto expire feature in the Redis? Because this HTABLE auto expire is awesome. I love it. And every time I'm using it in a Kamailio, this is the main reason why I'm actually using it.
Right. I didn't properly explain this, I guess. Thank you for finding the weakness. There's no auto expiration in Redis that I found, but when I was setting the data, I used an expire. So you can send, so although there's no auto expire in Redis, when you're setting it at the same time and within one command, you can set the expire. So I was setting the expire to the same auto expire that I had in HTABLE. So the data was expiring, I think, after 90 seconds. That was a great question. If we still had the bakery, I'd give you a cookie.
Thanks, Fred. Quick one. So we saw that when we were reading back from Redis, that's when the retransmission spiked. I assume that means when we do a put, we don't wait to get the confirmation back from Redis before Kamailio keeps processing. Is that right? So when we write to Redis, we don't wait for a response, but obviously reading, we need to wait for the response. Is that right?
Not in my scenario. In my scenario, I did the if the command failed, because if the command failed, I was sending back a 500.
Okay, so we were getting a response on the puts,
even
but
on
it was just the writes that we were just waiting for that delay. Is that
right?
Sorry, the reads.
Even on the set, I was waiting for a confirmation that the set was correct because I wanted to respond with an error if that didn't work, which I thought also was giving HTABLE an unfair advantage, but too bad, that's just how it works. I don't know 100% if that was the reason for the retransmissions or if it was just because, you know, hey, listen, if I'm sending 2,000 calls per second, then I'm also going to Redis at 2,000 calls per second, except on when I'm doing a set and a get, I'm now doing 4,000, right? Because I'm doing multiple calls to Redis for that same thing. So I'm doing a set and a get. I wasn't using a pipe command because I wanted to get the value after I set it. I didn't think that made sense. So I was doing 2 separate checks and then freeing them.
Thanks. One extra quick question, which was just, if you run this locally rather than with Sentinel for the Redis, like obviously HTABLE's local in memory, but with, with Redis Sentinel, we've now got to go across the network. Any idea how much latency that added?
No, I didn't, because I did think about, should I put it on the same box and just do it that way? I would assume that the connection would be better, but at that point, I couldn't justify using Redis over HTABLE if it's on the same box. So I wanted to try to make something where a scenario is, I have Redis for a reason, and other platforms needed to cross, and I'm not going to put that on the same box as Kamailio.
Thanks.
I also didn't want to have Kamailio and Redis fighting for memory.
Okay.
Thank you, Fred. I'm on the same track of this question. And have you tried some scenarios where DMQ is involved? Since in the Redis scenario, one of the limitations is the network interaction.
Yeah, I have in real life, which is why that brought me here with some of the DMQ and trying to limit the DMQ, because at high rates with, in my case there, I think there was 6 nodes that had to do DMQ. It's just an incredible amount of packets at that point being sent. I didn't notice a performance factor in Kamailio, but I noticed a performance factor in the network. So at that point, the network optimization, just handling that many packets per second, became a real significant issue. Kamailio, of course, it was optimized, and it was like, come on. It wasn't even sweating. I sweat a lot more than Kamailio, right? But the goal here was to see if Redis would help me in the scenario of reducing that type of packet count significantly. And if I can optimize anything, it does. So I think on the nodes, when you have a lot of DMQ, it does. What I've seen, and Daniel's helped with some aspects on this on DMQ. The problem is when you do have some, let's say, network hiccups, at that point I have, let's say, 6 nodes, but maybe 2 of them are a little bit different in terms of what they have in HTABLE, and that's bad, right? And so having that kind of, now having to do some overhead as to not only am I checking on DMQ, I'm also now checking to see if my HTables are synced correctly, and no real good way to sync them back.
Okay.
Thank you.
Okay, thank you, Fred. Yeah,
Thank you.
we added kind of flash and resync. We spoke at one or 2 events, but sometimes, usually when you need like interaction with other external application, Redis has library, has other tools that could make it easier. Okay, Fred.
Thank you.
He'll be here. He can also show some demos with API bands or other tools that he does. We have Andreas, I guess, if I remember correctly. Sorry, I haven't checked the schedule. Okay. One of the Redis modules for Kamailio, among others. He became famous with OpenSCR config wizard back in mid-2000, right? When we were all young. For those that remember that one, now tries to help us with, detecting problems in our infrastructure. I'll let Andreas to introduce what he's doing these days and also how he can help everyone here. Andreas, thank you, and of course, thank you for Seafront supporting us here. Floor is yours.
Thank you very much, Daniel. All right, good morning. We have heard quite a bit about testing in our previous talk with Fred. We're going to push that a little bit further. in my current presentation. So we're going to cover today how to automate your Kamailio test cores. So it's me, Andreas. You probably know me from times back at Zipwise, where we were implementing RTP engine. I've done this DP REDIS module that Fred was mentioning before, among others. So over like 20, 25 years, I've been working on zip, SER, and so on, mostly on the server side, like creating soft switches in the past. But 4 years ago, I switched sides. And nowadays, with ZipFront, we do the testing of your servers that you guys build, right? And we're going to look a little bit of how we actually approach that and how you could do that as well. All right, let's build our own test framework, said probably every zip engineer in this room at some point, right? I said it like 4 times. I implemented my own test frameworks 4 times, 3 times back at Zipwise, and now 1 time at ZipFront, again trying to make it right this time. Because it sounds pretty simple, right? You have all the tools, ZipP and everything. But when you look at the nitty-gritty details, it starts to get complex pretty fast. So now the question is, why does everyone say, hey, let's build our own test framework? Because we have, an intrinsic need, obviously, for testing. Why? For me, it was always to protect me and my teams from our own mistakes, obviously, right? So back at Zipwise, we had like Kamailio configs that were 20,000 lines of code. And every time you started to touch something, implement something that was a bit more than just trivial, we knew we were going to break something else, right? And that's where we said, okay, we need to have some automated test cores covering all of that. And the other thing is, you also have to protect yourself from mistakes of others, because that just happens, right? And either or usually it's like unintentional, but with this XZ saga some time ago that everybody heard of, there are some malicious people doing bad things with code that you depend on, and you really want to make sure that that doesn't happen, right? So how that does, or did that actually get detected? Pretty simple, right? So there was a guy at Microsoft doing like tests, and figured that with the new software version, logins started to take like 500 milliseconds longer than usual, right? Do you recognize this from a day-to-day basis? Probably not, right? So how do you recognize it? You need to test, you need to benchmark. And the thing is, mistakes, issues, they happen just to anyone and everyone, right? It doesn't matter, it happens in Kamailio. So just recently, like a month ago, with our testing, we uncovered a Kamailio bug that was there for 18 years. So it came back from the old SER times, somewhere in some DB driver, right? And it just never got uncovered. It wasn't probably important enough, but still, right? The other thing is like their project's RTP engine. I really love it. And we took a new feature, an experimental feature of RTP engine for a test spin some time ago, and figured that after running like 5,000 concurrent cores, more than 10 minutes, it started to lock up your machines, right? And usually, I mean, who of you does like 5,000 concurrent test cores for your media regularly? I don't know, probably not that much people, right? And the thing is, if you rely on that and you take this feature live and you put it in production on a Wednesday night's maintenance window, you're going to spend your Thursday noon with your post-mortem outage reports after rolling back your changes the whole morning after you hit busy hours, right? The other thing is there are like very weird issues that you hit when you just test enough. Why? Like there's some people in the room that know this issue. We were doing some testing for a customer where we had one-way audio, but only on IPv6 and only if the zip signaling was via TLS. Yeah? So if you implement your new features in your Kamailio config, and just pick your phones, you try to do your cores, there are so many variations that might occur that you just cannot possibly manually test, right? So the thing is, how much can you actually test, right? So if you're trying to achieve something that is a little bit better than, yeah, kind of works, right? Then you just need to test more. That's a fact. And the problem is you just can't clone yourself, right? And do more of these test calls, so you need to automate them, obviously, right? And you can literally clone a test, right? You just create another one, change it slightly, and then just run it, and that's about it, right? And when you do this, then you can actually start comparing, okay, what actually happens when I put a new Kamailio version in place? Do my post-style delays change? What happens if I, switch like REDIS with HTABLE? Does the performance change? Can I do more cores? What happens if I switch from, I don't know, AWS to some bare metal OVH infrastructure? Does my core quality drop? Is it better? No idea if you're not testing, right? So, how would that actually look like in practice? So we did a bit of a philosophical thing. Now let's really dive into the technical details. So what I'm going to do is I'm going to show you quickly how test automation might look in practice. And then we're going to look into how you could actually implement that. So what I did before my talk was just happily rushing in a new pull request, doing some changes to some projects, right? So implementing a fancy new DTMF feature. Sending off a pull request. Now what happens actually when you send off a pull request? Somebody needs to review it. And what you really want to do is, so when I click here, as a developer, what I want to know is, does my change actually work for all of the cases? For me as a developer. And the other thing is, do my changes that I, for reviewers, do my changes that other developers just did, do they work? So if I need to review my changes of a colleague, then usually the problem is that I usually have no idea, okay, is all of the scenarios, are they really covered or not, right? So what you actually want is you want some integration of this kind of tests in your CI/CD platform. And the thing is, what you can actually do is, when you create this kind of pull requests, let's look at one. So my internet sucks, but anyways. So what we actually do is in this GitHub project is when you create a pull request, we trigger a list of tests, right? And there, what we say is, beside like the code linting and formatting and whatever you do on a static analysis point of view, we also just run a bunch of core tests, right? And they can be like 2 or 3 or 50 or 100 tests. You can just parallelize it. And once everything is good, you know, hey, my change, from my point of view, is fine. So what happens here? Beside like all the usual tests, what we also do is we just trigger via CI/CD, via an API call, a bunch of core tests. And it's not some magic. It's just like a list of tests that we have, for instance, at ZipFront, where you see, hey, actually, just do a basic call A to B, and then also validate the DTMF, right? Now, what happens here is the calls, they just work, they run in the background. And when you look at the details, what's actually happening is, here we already see the first results. We see, hey, okay, we set up the job, you know, we check out our code, we build whatever we need to build in order to deploy our change, and then we do a basic call, that still worked, and then we say, hey, actually check if DTMF is still working, right? And there it says clearly, no, it doesn't. So you immediately get feedback, I broke something with my code, right? And everybody who's reviewing that knows the code is not going to be merged. And you as a developer know, hey, I need to touch something. And this is not this is without picking up a phone, starting to push in DTMF buttons. And the thing is, how does this actually look like in practice, right? So we run a test, and then we run automatically a core, and then we see, okay, the core is being established, DTMF is being sent, and so on and so forth. But on the very top, it says here, DTMF 0 expected but not seen on Corley side. So we automatically can verify with this kind of tests, okay, did we receive what we are supposed to receive? Did we receive all the zip headers? Did we receive all the DTMF events? Does the media actually work, right? So how was the call in terms of media handling? And you see immediately, okay, worked or did not work, right? So back to the presentation, how does this actually work in practice, or how would you implement something like that by yourself? In our case, as we said, how hard can it be to create a zip testing environment? Well, for us, it started to get a little bit complex pretty soon. So when you want to do this kind of thing seriously, the way it works is you have GitHub, or it could be Jenkins, could be CodeFresh, or any kind of CI/CD platform that you have, right? And then we have our ZipFront app in that case, right, which provides you the web interface I just showed you, where you can press a run button to run a test, where you can, schedule your tests to run every 5 minutes or nightly or whatever, or provide an API for GitHub and your GitHub actions to really go in and start this kind of tests and provide the results back to your CI/CD, right? What we do is, obviously, you need to do a core, so you need to have a zip client, and we use, among others, BearZip, for instance. We just need a client that we can actually remote control, right, in order to register, create a core, hold the core, send the DMF, and so on and so forth. In front of that, we have Kamailio. And we also have RTP engine. And I'm going to show you in a later stage why we are going to have this setup, because usually you might not even need that, right? But the thing is, these two components, they can provide a lot of feedback. They can provide events, how cores go, right? They can provide media statistics. And we just feed that back into like a function where we store events in Postgres, we store metrics in TimeStream, and then we have another function that actually analyzes that and says, okay, once the call is done, did we really get like all the media we have? Was the MOS value really at the value that you wanted? Were the DTMF events that I'm sending really being received, right? And did the right person really hang up the core at the right time, or did my system in between end the core for whatever reason, right? So that's basically how it works. Now, when you create these kind of things, there are a lot of open source tools that you can actually use. We use plenty of them, like ZipP, like BearZip, like CodeZap, in order to drive real device farms on AWS and on BrowserStack to test mobile apps, to test WebRTC applications in browsers. We use Kamailio and RTP engine as a combo for the signaling in the media, and we use our own agent implementation, because you actually need to orchestrate your testing efforts, and you need to aggregate all your results. Why? Because ZipP, when you do load tests, it's great at signaling, but it really sucks at media, right? Now, what doesn't suck at media is RTP engine. So you can actually use RTP engine to generate the media, but still you can only go so far, right? If you do you can with this kind of combo generate 10,000 media cores concurrently on one decent old machine, an 8-core Intel Xeon, no problem. It's like half the wire speed, 500 megabit per second. But still you start to run out of sockets at some point, and you start running out of CPU. And your system just can't process more than 500, 600, 700,000 packets per second, right? So you need to start scaling these kind of things. So you need to have more of these agents, and you need to tell them, 10 of these agents are gonna, start their cores, and they appear like one big client, and then they can send 100,000 concurrent cores with media, right? And you obviously need to orchestrate these kind of things. So how could that look like? In our case, it looks really simple, high level, right? So there's the ZipFront agent, which is actually just a Perl application, starting, stopping, and configuring Kamailio and RTP engine. And then also it starts BearZip, and it controls it via TCP, for instance, right? So when you say, hey, I need to register, then our agent gets this information from a backend, says to BearZip, register your zip clients, like your zip accounts. And then it starts and runs zip cores over Kamailio and RTP engine. And Kamailio and RTP engine, they act here as an SBC, actually. Why? Because we use BearZip in the back for zip over UDP, IPv4, but where Kamailio and RTP engine really excel is they can just easily convert that to TCP, to TLS, to IPv6, to whatever, to WebSocket, right? And RTP engine can convert all of this media from plain RTP into RTP, like SRTP, SDES, DTLS, again, IPv4, IPv6, and you don't want to deal with all these kind of things in your SIP client in PeerSIP, for instance, and even less so in SIP-B, right? So I said you can actually create your own SPC out of that, and we actually use that, right? So we use it on the client side, so we use SIP-B and PeerSIP on the northbound side, and then we just send calls to the southbound side to basically your system under test. And if you look at how we create that, there are some modules in place that might be a bit surprising. So TLS and RTP engine, obviously not so much, right? Everybody of you is probably using that. Where it gets a little bit more tricky is with topos, and topos is there for, you know, hiding the topology, right? So you don't want to expose your local host stuff of PeerSIP to your system. You want to act as a real client, and clients don't do record routing and so on and so forth, right? The problem is Topos needs a database behind that, and we were talking a little bit about REDIS and HTABLE and stuff. It doesn't work for Topos. It needs to have a real database, and SQLite is great at that, right? It is getting pretty on vogue lately, also on the server side. It kind of sucks with the default settings, but there are like 5 or 6 settings that you just set in order to really get the performance up for SQLite, and it's great. It's also great when you do your mocking, right? When you start testing your systems and you have your Kamailio, and usually you rely on, I don't know, MySQL or Postgres or whatever, you need to fill data in there in order to do the testing. But you can just easily just swap that out with SQLite, like a drop-in replacement. It's just a file. You can pre-fill it, right, with all your accounts, with all your data that you need, and you just put it into your system and use that instead of your MySQL backend, for instance. And the other thing that we use, zip-trace, probably you know that if you use Homer, right, and you funnel off your data to Homer for later analysis. But it's great in combination with zip-dump, which is really an underestimated module, right? We only use it there because it can do a bit more, but we just use it because it provides an event route where when you receive traffic, for instance, via TLS, right? You get the message exactly as it is without any modifications, but already decrypted. And the more interesting part, when you send traffic out, it's the last event that's being hit before the draft or before your request is being sent or reply is being sent, and all the modifications have already been in place. So you know exactly how your message will look on the wire, right, before it's being sent out. For RTP engine, we're using, usually you can run it in user space. It does very well. It just got recently some extremely great performance improvements. But you can obviously also use XD RTP engine, like the kernel module, right? Also in Docker, if you just run your Docker in privileged mode, you can run, I don't know, 10 Docker containers and just share the same RTP engine kernel module on your servers. Why do we do that? Because of player cache. And player cache is some rarely used feature in RTP engine, but it's really great if you do announcements at scale, right? Because when we do our test cores, like hundreds, thousands of them, we always play the same messages, right? So this is a test core, yada, yada, yada. Now, you don't want to take a buff and encode it and send it out for each of these 100,000 test cores, obviously, right? And that's what player cache does. It takes the file, and on the first time it does it, you know, it knows the codecs that have been negotiated. It takes the WAF, it packetizes it, right? And then it sends it out, and it uses this buffer again and again and again for each of the other cores. So if you do a lot of announcements, you can actually use that. And it also works. It's in some experimental branch, also in kernel space. And the other thing is MQTT, right? So we use MQTT to funnel off all the RTP engine statistics in order to graph them then fancily in the interface that you say, okay, I want to do a test call at scale. So I don't know, how many packets per second do I actually send? If I do, I don't know, 10,000 concurrent calls with Opus, and I start tweaking my, I don't know, my Opus settings in my clients, how does that actually influence the bandwidth that I'm using, right, for resource planning? And when we look at the load setup performance tests, it looks exactly the same as the previous one with functional tests. The only thing is we put CP instead of PeerSIP there. Now, it looks exactly the same, and as I said, CP is great at signaling, but it sucks at media. And this is where Kamailio and RTP engine really shine, because in Kamailio for the outbound call, you can say once the call is established, Kamailio just tells RTP engine, start playing media. And then you can send announcements at scale, hundreds of thousands of them, right? And the thing is, if you are at that point already, and you can actually orchestrate ZipP and Kamailio and RTP engine and whatnot, you can easily also start to orchestrate like iPerf for a bandwidth test. And just check, okay, how is your actually raw network connectivity going? You can actually start to do and orchestrate a free diameter to start test your IMS provisioning and billing flows. And like we do with Browser Stack and AWS Device Farms, you can start orchestrate code shares, right? It's kind of like Selenium, but a little bit simpler. And it can drive via Appium and whatever, like all kind of mobile apps. So you can start testing your mobile apps with that, right? And then when you orchestrate that, you can have on one hand, you can have your normal functional test setup with PSZip and Kamailio and RTP engine. On the other side, you have your mobile application, which runs, I don't know, some self-made application based on BJZip, for instance. And then you have, again, automated calls from your app to your zip clients. Now, the problem when you build all these kind of things and they start to get pretty complex pretty quickly is reliability of your tests, right? So the most important thing when you do this testing is make sure you don't get false alarms, right? And this is what we focus on at ZipFront a lot. We do, I don't know, hundreds of thousands of test calls per day, right? And we look at all of the failed calls to just make sure, is it our fault or is it really a failed call? Why? Because you know, it goes so quickly that you lose trust in your own test solution, right? So once or twice you get a false alarm saying, yeah, it was the test that actually failed, but it was really the test setup that failed and not my system that I tested, right? And the third time the alarm goes on, I'm like, nah, it's probably again the same issue, but it's not, right? And already you have an outage that you just overlook, for instance. And the other thing is keeping the notifications at the minimum, right? It's in the beginning, it's very, very interesting to see all of the alarms and all of the reports coming in saying, hey, I just did, I don't know, 50 test calls and all worked and I have them all in Slack, right? But if you get day in, day out, like a Slack channel just spammed, you're just not gonna look into the results anymore, and then you just overlook the issues that are really happening. So key takeaways and learnings that we had, like over this kind of, it was like 4 years that we were working on that. First thing, obviously, is test early and often, right? Because early in terms of early in your development cycle, right? So put your tests as early as possible, like in your pull requests. You can set up in GitHub and you can set up in Jenkins and all your CI pipelines, hooks where you say, as soon as I commit something, or at least as soon as I create a pull request, or as soon as I merge it in some kind of pre-development or pre-deployment branch, run your tests and run them automatically and run them often, right? And the other thing is about test coverage, keep the usage barrier low. And that's the main, or one of the main issues that we hear from our customers about ZipP, right? It's great, but you have to know Zip really well in order to manage that. The other thing is ZipP has like 150 command line options, right? It's really a beast if you're not working day to day with that, right? And a lot of times QA teams are not that deep in Zip, right? They love to create and work with the tests, but if you don't enable them to do it properly, they cannot just contribute. Yeah. So, and the other thing is that I already mentioned, make it reliable, probably the most important thing about false alarms and the trust. And also sometimes it was more than once where customers contacted us and said, hey, we see some red checks on our tests and they seem to fail, but actually it looks like our system is just fine, right? And we were like, nah. We're going to look at that, and half an hour later, we got an update in the ticket saying, oh, it was really us. And that happens. So really make it reliable and make people trust your tests. And that's it from my side. So we are out there in the other breakout room. If you want to see a demo of how actually it works in practice, come by, grab your t-shirts, we have some with us, and ask your questions, and I would be happy to discuss with you guys also your testing approaches and your challenges and potential ideas that you might have in terms of testing.
Actually, I have also to thank a bit to Andreas. Because by this kind of design, he actually stress tests Kamailio a lot with topos and the other components that I was wondering sometimes how much they can do, and happy to see that they suit to your needs. But again, like the side benefit, it's also for Kamailio, not only for your deployment. Okay, so time for questions before the, thank you, before the break.
Yeah, hello. Thanks. I have actually two questions. First of, how do you control return media? For example, so I assume, for example, you're making a test call. So imagine there is an echo on the other side, and you want to control that you got exactly what you got. So how do you control this? And the second part, which of this product is actually open source? Some configs that we can look and just to, so.
All right, so first question is, how do you kind of analyze the media and check if there are echoes or whatever? So there are two ways to measure MOS, essentially, right, call quality. One that we do is the normal ones based on packet loss, jitter, and so on. But what PSIP also can do, and that we leverage, is it can record your cores. So when you have a reference file that you send in, right, and you record it on the other side, we capture both ends. We upload them, and then we use a library from Google called Viscore, right? It's basically something like Bask Polka, but without the patterns and everything. And then you can just put them over each other, and it will tell you, okay, how well does it really compare? And then you see, like, okay, if you have like echoes and some dampening in the frequencies, then you get immediately like lower results. And that is what Google is also using for Google Meet to analyze their results. So that is open source, which we're using. The other one is, okay, what is our open source from our contributions? We have an open source version of CP in our GitHub repo that has quite some patches in there. It supports MQTT. And it also supports, finally, regex expressions to match your replies, right? So that you can say, okay, no matter if it's a 180 or 183 or whatever, you just don't have to put like all these replies into your XMLs. You can just put a regex there, for instance. And the other thing is that obviously we use RTP engine and Kamailio a lot. We sponsor changes that we need, right? With Daniel, for instance. And we implement a lot of features. We fix tests that we find in Kamailio in our own setup, like with SQLite, with topos, right? And that's what we contribute to the project.
So actually, yeah, it's a service running in the cloud, like based on open source, as you could see. And they have a nice web interface for viewing, which helps non-technical people. Sandra?
You had a slide about crying wolf. So I guess the answer to that is, you have to test your tests, right? How do you do that?
We run our own tests, and thousands of them per day, just to make sure that what we provide basically works. And when we deploy something on our staging systems, there are a couple of tests. What we, for instance, use is we have this web interface where you can control all these kind of tests and create ones and trigger ones. So what we do there is we use Selenium just to interact as a user, log in, press run buttons, check, do I really get the right results back, and so on and so forth. And then we also schedule them and see, okay, every minute we have like a bunch of, I think, 10 different tests that are running in all different scenarios, and then we just report them back to our umbrella system, and similar to what you would do. Actually, what we actually use as our reference implementation is Zipwise Community Edition Soft Switch, where we run all of our tests against, right?
Okay, one more question. If it is otherwise here in front, then they are
I have
in the
two
breakout
questions.
room.
So first one is, how do you test WebSocket?
Sorry, say again?
WebSockets.
WebSocket.
Yeah.
Well, Kamailio on the receiving end as a system under test supports SIP over WebSocket, and we use Kamailio on the client side, to do that, and also use BSIP, use our tools that we can just create HTTP connections, upgrade them, and then use RDP engine in order to simulate the media on one hand. And on the other hand, if you go a little bit more into detail of like how you would create or how you would test a whole WebRTC application, as I said, we use a browser stack for that. So real browsers, some are in the cloud, and we use Concept in our agents in order to drive them, and then they act as real users, right? You can say, okay, go to a particular URL, click on the login button, then push some buttons into my dial pad on the web, create the course, and then what we have is there some SDK to funnel off all the WebRTC statistics, right, on one end. And on the other hand, we just have a SIP client, and that's what I think in 2 weeks a colleague of mine is presenting at JanusConf in Italy. How do you actually automate your WebRTC tests, right? How do you automate a WebRTC application being tested for web to SIP cores and vice versa?
One more, how do you run the load test using the BRC?
We run it via CP, actually. So, but just the signaling part. And as I said here, what we actually do is we start triggering the media on a Kamailio side. So we do the core. There's some custom headers from CP going to Kamailio saying, hey, also engage with media. And once the core is up, then when you receive back the 200 OK, Kamailio tells RTP engine, and now to the external side, start streaming files.
Okay, thank you, Andreas. And again, they are all day long in the breakout room for questions, demos for you. Before, we have now the coffee break, but before that, I want to invite Christian from SNOM to give the first device from this bowl. He can extract the lucky one of you for SNOM phone D65. 865. A nice one. So thank you for your time. Okay.
Thank you. So
there are a few more, so don't.
So we are just outside in the breakout room, but now we will have the first one that you could win. So we will do now the stuff, the magic moment. So only one.
Okay, we have one.
So
we have Henning Westerholt. Sorry? It's a call outside. Okay. It's his colleague, so okay, we can.
Okay, we can know it.
Because we know him. Otherwise, not being here would have given to someone another chance. Okay. In absence, yeah. But we know it's here. We saw it in the morning.
Perfect.
Yeah. Okay. So, Christian, it's also all day today. If you want to ask more about the SNOM devices, and it might direct you to some technical guy for advanced SIP, but yeah, ask him because he can guide you around the SNOM products. Thank you.
Thank you.
Christian, again. And now it's the coffee break. There's another smaller area in the other room, but the entire area can be used by you. So if you see some cookies on that way, you can take. So the entire area can be used by us. Even if you see some other people, they will refill it. So you can use the entire lobby. Coffee is kind of self-service, but should be also something faster to use. But I'm sure you will manage. So probably a bit less than half an hour, we'll see each other again here. Have a refreshment. Hey, thank you for coming back, and I have Mathias from Pasquay, so all that impressive stuff for audio video, it's from them, and the technical knowledge and the arrangement here, and that we have nice audio and good streaming, it's coming from their team from the past, I don't know, like 10 years almost. I think one or first or second edition, the first and second were not covered by them. And of course, they do real-time communication, so they have their own platform, PBX, cloud PBX systems, and WebRTC support. And they've done a lot of technical presentations, so this time actually he wants to go also a bit into like social benefits of maybe working as an engineer and seeing, as he's the CTO and the founder and CEO right now, actually, from the both sides, some of these, let's say, benefits in terms of working in IT. So, Mathias, once again, first, thanks for arranging everything on technical side here, and then also for sharing with us your experience in the past on technical side, and I'm looking forward to your presentation now.
Okay, thank you for your introduction. I asked Daniel if I can do something completely different, and he agreed. So now we have the mess, you have to listen to me. I'm just here for your entertainment, and I will waste your time a lot. So half an hour of your life is now wasted, but maybe it was entertaining at the end of the day. So first, I want to start with a little survey. For the survey, because you're IT guys, you're always sitting like this in front of the monitors. For the survey, we have to warm up. So first, sit straight, rotate your shoulders back. You don't have to follow me if you don't like, but I see. Very good. Stop. Now the opposite direction. Does it feel good? It feels good. And now try if you can move your joints correctly, like so. Perfectly. Perfectly. Now we are warmed up for my survey. Yeah, really. So, first thing, so I want to get an overview, and I'm always curious about things. So, who is working more than 40 hours regularly? More than 40 hours. Everybody. Okay. Who is working already only 4 days a week and around 32 hours? Okay. So some of you are experienced already. Who is self-employed? All the ones with the 50+ hours are self-employed. Okay?
Business owners as well?
Yeah? Business owner, you just own it and you don't work at all. No? Yes? No, I work. Oh, you work. Okay, then you can say okay. Who is responsible for other employees? Is there somebody responsible for employees? Okay, some of you. That's good. He is also responsible. That's true. I can confirm that he is responsible for some employees, the nerdy ones. Okay, so this was our little survey. Thank you that you helped me out. The question is, or what I want to achieve now, is to find out we are happy or not with the 4-day week. We introduce them for everybody, and I want to first inform you how was the situation, what have we done, and how did we implement it, and what did happen, and was it a good idea or not. First, about me. I'm happy by default, so for me, we don't have to change it at all. I'm the CEO of this company. We are around 40 people, so a smaller company, and we do VoIP sometimes. Most of the time, we do barbecue. We are experts in barbecue. You can see this is our expert in grilling, right? And the others are the experts in eating. We have other experts, so we have software testers, but they are also happy. You can see how happy he is. He is well in shape. We have cake testers, a lot of them. They also have a happy life already before the 4-day week. So no problem there at all. We have happy DevOps. You can see one here live in person. Smile now. He is smiling. You can see he was happy before, now he's happy still. We have happy customers. This is in German, but they seem to be, sorry?
We see smiley faces.
Smiley faces, you can only have smileys, but less smileys and more smileys, because we want to be every customer happy-faced, so it's okay. But they liked us somehow, so this is a copy of our productive system. So why change anything? This is the question. The company works. Everybody seems to work there and enjoy it somehow. Sure, there are some days where you say, why don't I do something completely different? But in general, they like working here. It works, we earn money, somehow we're doing the right thing. So why should we change anything? And I want to share the honest problems we had. The truth. No, don't get me wrong. What's the truth, or what did we see? We have very stressed employees, especially in the rush hour of life phase, and most of our employees are in this phase. Who knows this phase? We train so we can try it. Who knows? What is this? You know it? I know it, Sandro, that you know it. 2 children? Yeah, okay. So the rush hour of life is where everything at once happens. So you work, and you work very hard because maybe you're working on your career or whatever. You have maybe a family, you have maybe children, you have maybe hobbies, you have maybe a partner who wants this and that and whatnot from you. So everything. Yeah, sounds familiar. So who knows this situation? Yes, many. No, you don't know it. You have employees for that? Oh, okay. So there is stress. And you can take away stress from your colleagues. You can do this in the company, for sure. But there is a limit, because working is not the only factor for the stress. There is a lot of other factors, and you cannot remove it as an employee. You can try it. You cannot remove it as a company. There is no chance, because how would you do it? Then there is something we encounter a lot. This is headhunters try to steal our colleagues. So they know, this is a company, it's a small company, they have good people, maybe they're underpaid, let's try it. So this happens every day and every day and every day. And don't get me wrong, this is nothing criminal. But because we have a shortage of workers, this is more and more and more and more. If you have a LinkedIn account, who has a LinkedIn account? Many people. Then you get job offers what's the ratio? Every hour, every 2 hours, every day. Let's say every week somebody tries to hire you. That's normal, and that's a fighting about good employees. And that's also what is a problem for us, because maybe the first time you get asked, you say no, the second time, the third time, but after 2 years, maybe when you say, okay, I'll give it a try. So a problem for us as a smaller company. And it was hard for us to get job applications at all. So not only getting new employees and new workers, even getting an application at all that they think, okay, it is worth asking a small customer, a small company like Pascom to work for them, was already a problem. And then if we talk to somebody, if we tell him, now here is Pascom, it's a family business, it's cool, work for us, then they said, do you know the benefits from BMW? There is blah, 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 and you? And then I said, you can go to the Kamailio World, do you want to? And they said, no. Yeah, and then they were, when can I start? So for a smaller company, it's, in my opinion, harder to have really a lot of benefits. For sure, there are people that say, I want to work for a big company, you will never convince them. And there are some, yeah, I like the family business type where somebody where I am somebody, where they listen to me. So I search for a smaller company. But even then, it's hard to have cool benefits to actually start to work for you. And this is my honest opinion about how it will work. So if you have stressed employees, and if you don't get new talents, you will die. That sounds hard, but at the end of the day, it is like so. So you can have some years, and still it would work, and everybody's happy, and you're happy, and then this one leaves, that one leaves, and no new employees will show up. So at the end, nobody will do the work. And I think this is one of the main problems of our near future, or even it started already, that there is no question about the price of your product. For sure, they will not pay everything for your product. But the question is, do you have the manpower to maintain and develop your product? I think this is one of the main questions we face in the near future, until the AI does everything. We wait for it. So what is the possible solution? There is always one possible solution which every CEO knows, and this is throw more money on it. If somebody says it does not work, I say throw more money on it and it will work. For sure it will work. But what's the problem with this in this particular case? Just pay more salaries, just do this and that, benefit, pay something. It works, and don't get me wrong, good money for good work, no question. But does this help in this stress situation? Does it make your employee happy with his private life? Does he have more time for his children, for his hobbies, for whatever? No. He is still stressed. He has more money plus stress. Maybe he's then de-stressed because his wife is more happy, his husband is more happy, her husband, sorry, is more happy, you don't know. But I think you don't solve this stress problem at all. And then you can try, if you're brave enough, to compete with the money of the big tech companies. I wish you good luck. We have around the corner BMW, I mentioned them already, and I don't think that we can say, and we give you more money and more, and then BMW says, okay, what? Who is Pasquay? Here is the money, work for us. So you can try it, but I think it's not the benefit you can really achieve as a small company. Let's see what the 4-day week could potentially bring or make better. And here I read out the disclaimer for the next slide. I read it. The same applies to all cohabiting couples, regardless of gender, sex, or sexual orientation, but the following rhyme only makes sense this way, and everybody immediately understands what I want to say. I would like to apologize for this in advance. So what's the next slide? Happy wife, happy life. Do you know this? It's the other way around for sure, the same. But this is something a 4-day week can do. And you can exchange wife with whatever you want. Huh? No. Don't get me wrong. Don't get me wrong. Your partner, your children, your hobbies, everything. So you can invest a day or time into what you love, what you like, what you want to do, and then your life overall can get better. We have employees, they say, yeah, I am young, I have no family, almost no obligations. I spent this one day in consulting for another company, because then I earn more money and I can see something else, I can see a complete different view, a complete different angle. So even this is possible. So you can do whatever you want to make your life better, and they have really more time to do something else. And this is, I think, a crucial point when you're talking about the 4-day week. What's important is not having 5 days and 6 hours or something like this. So really 1 day off is key here, because then you don't have to put your brain into this for 6 hours, and then you're not relaxed anymore because you have seen all the bugs again. And really a day off makes the key. And then, what's good, the 4-day week is easy to understand. It sounds weird, but it's easy to understand, and it's easy to understand as a benefit. I look at the time, yes, I have enough time for a short story. A really short story out of my life about understanding things easily. My wife said a few years ago, we are wasting too much energy. Do something. I said, for sure I will do something. I will install Home Assistant, I will install some displays, I will waste even more energy to save energy. You will see, this works. And she said, it will never work, that's just you playing around with some tech stuff again, and it will never work. And she did not trust the system and every new chart, and she started liking it somehow very, very slowly, and said, yeah, it will never change something, it will never save energy. And I don't know if it's in every country the same, but in our case, you pay in advance every month, and at the end of the year, you get one invoice from your electricity provider, and then you get money back because you paid too much, or you pay more money. And she was still skeptical with everything in our household, and then one day I came back home, and she smiled. She really, not never before, but really smiled, and she said, we have the electricity bill, and we got money back. Everybody had to pay more money, and we got money back. You must be a very good IT engineer. What you can do with IT is great. This was the first time in my life that she said that. Really, the first time. Man as I am, I made immediately a mistake, and I said something like, we are doing a very hard work in our company. We are trying to provide a very good software. We have the best engineers in place to deliver a great software, and we earn millions each year with this software. Compared to your electricity bill, this is nuts. And then she said, I expect this from a business. You are a businessman. And then she smiled again and said, we got something back from our electricity bill. So she's smart. She's smarter than me. So that's not the point. But what I want to tell you, or what in this example I want to show you, is that if you can easily understand it and compare to others, it's very important and it's very, very good for people. Why? Let's go back to the 4-day week. You can say, I work only 4 days. I get the same amount of money as the others for less work. And that's it. You can understand it, you can communicate it, and that is easy, really easy, and easy to understand. And this is a really good benefit, and we get a lot of feedback about this. And it does not matter how much you earn, how much you worked before. It's just like the same with the electricity bill. It's just the fact. Other people are working more, you work less, you get the same. That's everything. So easy to understand. And we use this heavily. So this is from our Instagram marketing. I can tell you Instagram, everybody's looking into it. That's very good, and you can make good advertising. I will translate it. It says, you will get more free time, spare time for free. Does this mean? And they click on it, they apply, and gotcha, that's good. Then a benefit for smaller companies is it's easier to implement. Let's think about a really big company. They want to implement a 4-day week. They have a lot of different workers in their company. They have a lot of different divisions maybe in their company. So it's very, very hard for them to say tomorrow, hey, now we work 4 days an hour, everything is okay. For a big company, I think it's not so easy. For a smaller, it's easier. And then the question, does it work for everybody? I think no. And I'm relatively specific here, does it work for everybody? In my opinion, here the barbershop, if you sell something which is counted in time, if it's stupid or not, but if it's counted in time and you get paid for time you spend on something, then it works, but you will get 20% less revenue. Easy. If you're a consultant, and if you consult less, you can charge less for your consulting hours. So I think it's very, very important or crucial to really be honest to yourself if it would work. In our case, we deliver a software, we develop a software, and we maintain it. So there is no we pay for time for what you do. There is only we pay for the product. So here, in our scenario, it's easy, and I think doing it everywhere is not so easy, to be honest. The implementation, what did we do? We implemented a time tracking first. This might seem very weird, but concerns were, okay, we then only have 4 days, but we work 10 hours a day. That's the end of the game, because then we just stay there until it works, as every time. And this was a big concern. So first, we implemented a time tracking, and we really wanted to achieve that everybody really only works 32 hours. You can have a few more hours or less hours, but at the end of the day or at the end of the month or a few months, you should always have this in average. So without this time tracking, I don't think it works, because you have a bad feeling always about this. And it is now also by law in Germany that you have to track time, so this was a good situation. Then choose your day off wisely. We tried to do this. So there are many possibilities. You can say everybody stays at home on Friday. And then you have a network support. Then you have customer support. Do you think they like it? Who thinks they like it? Yeah, no, they don't. They don't like it, so what we did was implement a shift. So you can choose between Monday and Friday, or even Thursday for your day off. Makes sense? And then Tuesday, sorry. I don't like this idea, so I did not know why. I will explain you in a moment. Choose this wisely. If I can redo it, I would have chosen only Monday and Friday, and not more days. Because the more days are flexible, the harder it is to plan a meeting. Because this guy is not there today, he's not there, here, and if you want to plan a meeting with an external guy, plus your employees, which are never ever there, then it's hard. So choose the day wisely and how you can do this for your company. Then it's very important to work in a disciplined manner, as I wrote down, and use your IT. Why is this so much more important than before? It is important before to have tickets. This is important before to use your IT. But if you work like this, and some colleagues have the day off and some not, it's really, really important to stress your IT infrastructure and automate and document as much as you can. Because then it's just easier for you to work when your colleague is not there, and the handover between the colleagues is easier. What happened at the end? So we implemented it like this. Was it a bad idea? Was it a good idea? We really needed more discipline. And this was, I think, the hardest part for us, to always ask ourselves, how can we do this? How can we manage it? How can we make it more efficient, that we really can only work 32 hours a week? And this was the most thing we struggled with, but we made it somehow. Because then this kicked in. I did never expect that, but this, we can do it. It was something. I had a lot of talks with our employees during this phase when we implemented it. And from, what we are doing here, and maybe we can fail, to, hey, we can do it, and hey, we can achieve it, and hey, we work together, and it works for us, and we can do it. And that's really, really an effect I did not expect. It happened, and it made us really way more productive than before. Job applications, it works really, really good. So here's the main improvement we had with hiring new people. We have, I think 10 times more, 20 times more. It's not yeah, you cannot measure it easily because then you talk to a lot of people and then they say, it's not what I want, but it improved massively. And for sure, we got a lot of positive feedbacks from our own employees, and they really like it. And for sure, you like it when you have to work less, but at the other hand, there is something you fear that it could go potentially wrong, and you like to work there, and you lose this if they do a bullshit. So it works, and the feedback was very positive for our employees. Then about the production revenue and so on and so forth. You can read a lot of studies about that. So our productivity and things like this are hard to measure. So revenue is easy for sure, but we are a subscription-based company. So measuring the revenue is easy, and effects of the 4-day week, it could take years until we find out. But on the other hand, the production, we can measure how many features can we put out, how productive is our deployment, and so on and so forth, things we can measure. It did not decrease. It did not increase. There are studies that say if they only work 4 hours, then 4 days a week, then it increases even. I think that's not true, but you can keep the level you have with having more discipline in your work. And this is already a great achievement. So 20% less work, achieve the same. Then we asked our customers and customer feedback. They still complain, but not about the 4-day week. So we had the fear that the reaction time goes down, or the reachability of our support team goes down, or something like that, that we have bad feedback from our customers, but not a single one. So are we happier than before? I think, and that's all of me, and thank you for your patience.
Okay, questions? Anyone? I see here first.
Questions? Okay.
Thank you. Have you also considered reducing the amount of hours per day instead of the days per week?
Yeah, this was also a discussion, but I think this is not the same effect, because if you are there 5 days again, then you start in the morning, you feel relaxed, then you see your tickets, then you see your bug reports, then you see your customers shouting, and then you're not relaxed anymore. And then it does not matter if you are 6 hours or 8 hours here, then it's just, again, the same situation. So we even had talks with employees, or not with employees, with job applications. They said, we want to work 6 hours, and we rejected them because we said the effect is not the same. And in our own, we are all doing it. So even I, as the CEO, do it with the day off. And it's really refreshing to have that whole day off. That makes your mind free, and that really helps.
Makes sense. Okay, Sandro, and then it's one there.
You mentioned that you saw a huge increase in job applications.
Yes.
Did you also notice an increase in people who apply, who expect to work less, who are not so driven?
Mm-hmm. That's a good question. This was also a concern which we discussed internally, that we say, now we get the lazy people because they don't want to work. It's the other way around. We could employ 3 new people. That's for 40 people. That's a lot in 2 months or something like that. And they are, I would say, better than what we had from applications before. And they are sometimes, or not sometimes, they are really high performers, because they say, now I can really work focused on what I love and have family and everything around me still, and my wife will not leave me, my husband will not leave me. In most cases, it's still my husband, my wife will not leave me, because we are in tech, and for sure, most of our employees are men still.
Okay, one question here, and I guess it's one there, but it's too far. And I guess you can approach them not to get too delayed.
Sure. Do you generally work from home or in the office or a hybrid model?
Yes, it's a hybrid model. It's 50-50, so 2 days in the office, 2 days from home. We have 100% remote experience, but for developers, we stopped employing people 100% remote because it's just, for us, for our special case, it does not work. We have this family type of company and they never feel like a part of it if they're 100% remote. And then it's like on off and then it does not work for us very good.
And it's easy to divide half-half, right?
Yes, that's easy. You can understand it. 4 days, 2 at home, 2 in the company.
Okay, sorry, you can talk with the Pascom guys, they are around here, not to get too much delay. Really good feedback from this, your experience, and probably will change the minds for some of us self-employed or companies here. Thank you, Mathias, once again. So now we move to Still Shaken with the team from Tullio. We'll have Sai, and Lucas. Lucas was also last edition, and this time Sai will present how they manage this Still Shaken implementation, which we know is mandatory now.
So that one may be okay.
Mandatory in US, I think UK, France, it's starting soon, right? Or if not yet started. I heard also like Sweden maybe, so it's getting closer and closer to Berlin at the time. I implemented also some stuff, but so far I haven't need to deploy it in Europe yet. So Lucas, as I said, he was last year presenting about how they route the traffic together with Andreas. Now his colleague Sai is on the team, coming at the Kamailio World first. Again, many thanks again for coming back as a sponsor for Kamailio World, and also taking the time to travel from California and Atlanta to our event. I know it takes time more than maybe other resources for such long trip. I think now both of you are set up with the microphone, so the floor is yours. Thank you.
Absolutely. Thanks for the introduction. I'll go and kick it off. Okay, the mic works. Perfect. Hi, everyone. I'm Lucas Christian. I'm a principal software engineer at Twilio, and I work on the voice connectivity team. Like I said, some of you may have seen me here last year. We were talking about DDoS attacks. And so today we come with another pleasant subject, robocalls. So yeah, I'll let Sai introduce himself quick.
Hey everyone, I'm Sai. I'm also an engineer on the voice connectivity team. And yeah, happy to be presenting here.
All right. So today we're talking about Stir Shaken, and the title of the slide is The Battle Against Caller ID Spoofing. So I'll do a quick introduction to what is Twilio. So for those of you that are not familiar, we're a communications platform as a service. And essentially what that means is we provide APIs to other developers that want to connect their applications to the telecom networks. So this lets customers that are maybe not telecom savvy, maybe they're not familiar with SIP, they would probably not be at this conference. It lets them still hook up and take advantage of all of these API-driven connectivity features. So routing calls, doing conferences, IVRs, so on and so forth. So Twilio is a lot of different products. It's voice, messaging, email. We also have gone upstack, where we have a complete call center solution, and as well as customer data applications. So you can figure out what communications to send and when. But voice was Twilio's original product. We're still, it's a big part of the company. And we both obviously put a lot of hours into working on it and making sure it's great for our customers. So a few other neat things about our scales. We have a global SIP network with 8 different regions. We're mostly deployed on Amazon Web Services. We definitely use Kamailio. We use it as our load balancers at our various edges where carrier partners connect into the Twilio network, or customers that bring their own SIP applications. And it's worked quite well for us for a number of years, so we're happy to be here. So going back to the subject of this talk, robocalls. How many of you, just show of hands, if you got a call right now from an unknown number, a number you don't recognize, so is that saying you've gotten a call like while you've been here? My other question is, would you actually pick it up? How many of you would pick up the phone if you got a call right now from an unknown number? I'm seeing a few takers, okay, a few masochists in the audience. I will admit, I used to believe that I should always answer the phone. It was like the professional thing to do, but I've been burned way too many times on that. And this is a problem of robocalls. So we've seen them really overrun the industry. And basically anyone can drop a call into the network and claim to be any caller ID. So they can make this look like it's coming from your grandmother, and then you pick it up and you're really disappointed when it's another sale for something you don't want to buy. And it really degrades the value of the channel. And so the second issue of these is that they're hard to trace. So obviously governments want to crack down on these, but the telecom network is wide and diverse, and there's a lot of intermediaries in play. And so it's really hard to say like, oh, I got this one spam call, let me figure out who actually was the source of this getting into the network. So STIR/SHAKEN is what we're going to talk about today, is a solution that was built to solve many of these problems. But before we get there, we'll actually look at, in the United States, how some of the carriers tried to solve this problem themselves. So many of them contracted with these call analytics vendors that basically said, hey, we'll ingest all of your traffic, all of your call detail records, and we'll look at these and we'll sort of analyze over them and see, like, is this a traffic pattern that looks like it might be spam? Is this a traffic pattern customers file spam complaints about? And then they'll tag certain calls as spam and certain calls as legitimate. And it's not a bad solution, but it's not great because spam calls still get through. And if you're a legitimate business, you might discover your calls suddenly one day are being tagged as spam by Verizon or AT&T or one of these other big telecoms in the US. And you have no idea why, and when you try to call their vendor to figure out, they're not going to give you many other answers. They might say, hey, you could sign up for our verified service, and then you won't be tagged as spam. But that starts to feel a little bit like a protection racket. All right, so now I'll pass it over to Sai to talk about the STIR/SHAKEN protocol and how it will solve some of these problems.
Thanks, Lucas. Just with a quick show of hands, how many people actually know what STIR/SHAKEN does? Okay, wow.
That's
nice.
actually bigger than I expected, yeah.
So as Lucas talked about before, caller ID spoofing is a big issue in the ecosystem, and it's getting even worse. So basically, STIR/SHAKEN is kind of designed as a framework to stop this. It's mandated in the US, so it's an industry-led effort with public and private partnerships, and it's mandated by the FCC, which is the Federal Communications Commission. STIR/SHAKEN also leverages like the same web PKI that's used in the internet today, so it kind of provides an identity to every call that pretty much originates. So how does this all work? So what is the crux of STIR/SHAKEN, right? So the crux of STIR/SHAKEN is something called as a passport. This is a signature added to every call, as in the SIP invite. And the passport is a personal assertion token, and it builds right upon the JWT token spec, but it adds like its own telephony flavor to it. As I said before, it heavily relies on the PKI infrastructure that's set up. And it's combined of three parts: the header, payload, and the signature. So I'll go briefly into each one of those pieces. So the header consists of what the passport actually is. So it defines the type of passport, the public certificate URL that's used by the originating service provider, and the algorithm that's used to sign it. And these are all base 64 encoded. And that's just the JSON representation after decoding it. And then you have the payload. So this is where most of the claims that the call originates from resides. So I'll go briefly into each one of them. So origination, probably know it. It's just the caller's number, and then the destination is the callee. And then IAT is the issuance time. This is like when the call was placed. This is used in a couple of places to make sure that the passport is not too stale, or in replay attacks as well. And then you have another claim called the attestation, which provides a stamp of approval on the network as to who the caller is. So you have 3 levels, A, B, and C. A is when, at least in Twilio's purview, A is when a customer is known and we have, and they have proven ownership of a certain caller ID. And then B is partial attestation, which means we know the customer, but we really don't know what the caller ID that they're using is. And then C is for any other, like any other scenarios. We sign C because in the US, if you don't sign a call and the call gets, complained by customers, they can go to the FCC and we receive a traceback request, and that causes a lot of penalties if you don't have calls signed. So it's very important to sign calls so it can be traced back to the originating service provider. And then you have the origination ID, which is just a UUID. This is usually used in the traceback request, and it's used by the provider to easily locate what customer actually originated these fraud calls. And then the last part is the signature. So this is the cryptographically generated signature. It uses the header and the payload, and you basically generate a cryptographically signed signature that can be verified later. And just to highlight, the most widely used algorithm right now in the ecosystem is ES256. So this is how it actually looks like if you combine all 3. You'll probably notice towards the end there are a bunch of tags. It just lists out the type of algorithm and the passport that's being transmitted through the network as well. So the SIP identity header is the one that hosts the passport. It's defined in RFC 8224. There's a link there if later you want to check it out. We've seen a couple of solutions in the US to kind of transmit these passports. One is the in-band, where you just provide the identity header in the SIP invite. Or we have the out-of-band, where there's a CPS service that hosts the passport during the call setup, and then the TSP can dip into this common service to actually get and verify the passport. And all numbers in the passport should be E164 or prefer to be E164. And I'll go roughly upon some of the components in the ecosystem. This is how it roughly translates into the Twilio infrastructure as well. As you can see the box above, there are a few players in the ecosystem that are out of scope during a call, but you have service provider A and B that were calling each other, right? So what happens before is you need a certificate to actually be able to sign your calls. And the only way you can get a certificate in the US or any other country now is if you're a service provider. So you would go to the PA and say that, hey, I'm Twilio and I need a certificate. They would probably vet you as a business, make sure you're legit, and issue you a token. And then the CA will give you a certificate. And basically, you as a service provider now have a certificate in your SKS, which is the secure key store, with your private key. And when you originate a call, you have this STIAS, it's called the authentication service, that creates the passport that I talked about before and puts that in the SIP invite, and the outgoing invite just goes on the PSTN. Another thing to note is that we've seen some statistics in the US that only 30 to 40% of passports actually end up going to the terminating service provider. This is because of routes maybe dropping headers because payload is too large or something like that. And then on the other side of the spectrum, you have the service provider B who's receiving the invite, and they check through their service that the certificate is first valid, and then they use the public key from the certificate to actually verify the signature and make sure it's legit. And I'll hand it off to Lucas to talk through our journey of StirShaken and Twilio.
Yeah, so now that we've sort of done an overview of what the specification is, I'll talk a little bit about what it looked like to actually implement StirShaken at Twilio. So we started working on StirShaken several years ago. It was originally sort of born after Congress mandated the FCC, which is the Federal Communications Commission. That's the US telecom regulator. They passed a bill called the TRACED Act back in 2019. As you can see, Congress in the US, if you're not familiar with them, they like their acronyms. So we have quite a few in this slide deck. And so yeah, that sort of started this whole process off with the development of that specification. And they started out sort of initially designing this really to be telecom carriers to telecom carriers. And so the only players that were allowed to actually acquire a certificate were other interconnected VoIP providers or full carriers that basically own phone numbers and basically go all the way up and down the telecom stack. And this has since been expanded a little bit, so it now allows CPaaS providers like Twilio to get these certificates, as well as individual enterprises. So there was a realization that we need kind of end-to-end stir, shake, and signatures. We can't just rely on those providers that actually are plugged into the network and have legacy hardware deployments. So what does it actually look like for Twilio to build this out? Well, so first off, we have to have the technical capability to sign the calls. So this is building all those components that Sai talked about in the previous slides. In addition to having that technical capability, there's quite a few business requirements that get imposed upon us. So one of these is we have to actually know whether or not we should sign the call. So this requires us to have a know your customer, or we call it KYC. And this just means we have detailed information on all of our customers, and we've done some effort to ensure that they're a legitimate business. There's also a feature in STIR/SHAKEN called traceback requests. And this basically means that a carrier can come and say, hey, we got a complaint about this particular caller sending spam. And the government or other carriers will work to figure out who originated those calls and how they got into the network. So we have to have a process in place to handle those requests, to go search our logs, be able to look up those calls and help figure out where these bad actors are coming from. So essentially, as we were building this out, everyone in the industry was building out the spec at the same time. So it started out with some defined specifications, but no one had implemented this. And so it was definitely a work in progress. We've seen this in the United States. I'll talk about France a little bit as well. They're sort of going through the same process right now. So at least in the US, what does it actually look like to implement STIR/SHAKEN? Well, first off, you have to get the certificate to sign your calls. And the way this works in the US is there's something called the PA, or Policy Administrator. And in the US, that's delegated out to a company called iConnective. And essentially, they're in charge of sort of being the gatekeeper of the whole ecosystem. And you'll go as a provider to iConnective and basically verify your credentials, at which point they'll give you this SPC token. And you can now take the SPC token to any certificate authority. And we have a few logos of different certificate authorities that operate in the United States. They're essentially all the same, so you could take that SPC token to the vendor of your choice and get a signed certificate. This is similar to, like, if you're familiar with HTTP, you've probably acquired an SSL certificate before. It's essentially the same idea, just in the telecom ecosystem. So once we have the certificate, you can actually use it to sign your calls, and then that signature will get passed along in the signaling to the terminating providers. And those terminating providers will use your public key to verify that certificate. They'll make sure it was issued from one of these trusted CAs. And if all that checks out, it should result in the call showing up to customers with this verified check mark. So if you've gotten a call on iPhones today, I think it still doesn't show verified on the call screen, but it'll show it in your call log with a little green check mark. And on Android and other handsets, you'll actually see that verified mark. So the Know Your Customer I mentioned was a big part of this. And essentially what this meant is we had to build out a new system within Twilio to collect all this information. So we created a solution called Trust Hub, which was sort of a section of our console. It's also an API. And it allows customers to upload necessary documentation, for example, maybe proof of company registration, so on and so forth. And they can submit all those documents to us for us to review and then approve their profile. And of course, this also required an ops team to review all of those profiles. And so that required some additional work on that side. And another unique thing for Twilio is we do a lot of sales to what we call ISVs, or independent system vendors. And these are firms that resell Twilio as other solutions. So for example, maybe we have ISVs that sell a call center or customer service solution. And so many of those ISVs will white label our product. So now they have to go to their customers and collect this KYC information from those customers. And so as part of the Trust Hub product, we also built APIs for these ISVs to input KYC information to Twilio. And lastly, every call that we sign has to have some attestation level. It doesn't have to be A. So we don't have to, at least in the US, necessarily collect full KYC from everybody. We do have to sign every call. So if we have some customers that haven't gone through this onboarding process yet and given us this extended KYC information, we can still sign the call as level C, and that at least provides for a traceback, but it doesn't necessarily provide any indication of trust to the carriers. So those customers that don't complete that process will still be likely to be marked as spam. And so they really are incentivized to go through and give us that information so we can give them that full A-level attestation. So France is the second major country we've seen adopt the stir-shaken technology. And it's essentially the same protocol, they just have a different ecosystem that's a little more centralized. And so in this case, they have one regulatory agency that runs all of these different pieces. So instead of this potpourri of private businesses that we get in the United States, you have RCEP, the telecom regulator. They also have a little bit stricter rules. So France is saying when they actually start mandating this technology, they're going to require carriers to drop any calls that are not signed. So essentially they're saying you need to be in full compliance or your calls will literally not even get through to handsets. And another smart thing they've done is they have a portal where you can report a call that's broken. So as I mentioned, in the United States, we've seen some calls are not getting through of the signatures to the destination. And in France, there's sort of a centralized flow where carriers can report if they're receiving calls of invalid signatures or unsigned calls, and they can go really troubleshoot these. So France actually started this back in 2023. Their goal now is to have it fully deployed in October of this year, which their original goal was like June of last year. So it's obviously taken them a little bit more time than it was expected, but it is rolling along and they do still have a deadline set. So this is the ecosystem in France. Again, instead of going to these different providers, you go to RCEP, which gives you the certificate. So they're the CA and the PA. You don't have to do any additional hops there. All right, so now I'll talk through just a few implementation challenges we've seen. So the first one is that the protocol in the spec is very strict about what can be signed as A attestation. And we have some use cases within Twilio that don't currently fall under this category. So one of these is a call forwarding use case. And what that looks like is we have customers that will use Twilio to host, say, a business phone number. And when they get calls into that business number, they want to redirect the call to maybe an employee's mobile phone. So maybe you have employees on the ground and you just want to forward in incoming calls like a customer service number to their phones. And when you forward these calls, you ideally want the caller ID to show the customer's number so they know who is actually calling them. It's not just the same number every single time. But you can't sign that as A because we as Twilio, we don't own that phone number that was originally calling us, and the customer doesn't own it either. And so there's really no category today where they can sign. There's no entity in that case that could sign that number as A attestation unless it was the original person placing that call to the business. And so the solution that's been offered in the spec is to do something called a div passport. So some of you may be familiar with the SIP diversion header that lets you indicate a call is forwarded. And the idea is we will just have to add a diversion header in any case we do call forwarding. And then there's an additional property in the passport where we will actually sign over that diversion header. So you'll have the original signature plus a div passport, and those will combine to say this is still a verified call. So the other case is we have some providers that use Twilio to originate calls, but we don't actually own the numbers. So they may terminate those with a different carrier. And in those cases, we don't own the number. We do know they're trusted, but the spec only allows us to sign A for numbers that we own. So there's some proposals about allowing us to sort of become a CA for those customers and actually delegate out certs to them. And then they can use those certs to sign the numbers that they own with another provider. All right, so I'll talk a little bit just about some SIP level challenges that come up with this identity header. So the first one, in the top left, is it becomes quite large when you are adding these signatures. So the stir-shaken signature is often 950 to 1,000 bytes. And if you're familiar with the Ethernet MTU, that's 1,500 bytes. And so chances are your SIP signaling is already 500 or 600 bytes. And when you throw this in, you're going to be over that limit. So what this means is you're going to run into UDP fragmentation. And there's no mechanism in SIP to split messages within the protocol at layer 7. So you're going to produce IP fragments if you're on IPv4. If you're on IPv6, it's just not going to work because IPv6 doesn't allow fragmentation. And so what this means is you're going to see a lot of that today. You may discover some interesting network challenges from fragmentation. So if you haven't brushed up on path MTU discovery in a while, it's worth checking in on that spec. Make sure your OS is configured correctly. If you're using Kamailio, the default is actually, I believe, to use strict path MTU discovery, which can cause the packets to get dropped if you don't have the right MTU in your kernel. So check that setting. You may need to turn that off so that the OS allows packets to be fragmented out. If you do allow them to be fragmented, though, you also have the challenge that some router along the way may decide the MTU is actually less, and then they'll split those packets into more packets. And we've discovered some of our carriers have really strict firewalls that do not like when they see fragments of different sizes. So if you get a big fragment, then you get a small fragment, then you get another big one, then another small one, they look at that and think, hey, we're maybe under a DDoS attack, and we'll actually block all that flows. So the key is you really need to know when you send the packet what the MTU of that path is, so that you send multiple equal-sized packets and then one small packet at the end. So the last one I'll mention is just all this fragmentation stuff usually causes a burden on firewalls. So we found some vendors will publish a certain packets per second limit that they can handle. And it turns out if you use IP fragments, they don't mention this, but that actually halves or lowers the limit even more than that. So it's just worth actually performance testing all these things. Last thing I'll call out is that the identity header is passed over SIP interconnects. And there are still a lot of players in the telecom ecosystem that are not using SIP. So you see this especially of like the legacy incumbent carriers that are going to have some actual like analog interconnects, TDM, and none of these really have a mechanism today to pass the stir-shaken passport. So what we're seeing, this is forcing a lot of those carriers to modernize. There are other ways around it, like doing out-of-band, but I think the reality is this is sort of proving to be a forcing function both in the US and France for these carriers to modernize their infrastructure. All right, so now I'll pass it to Sai to just talk a little bit about what we're expecting in the future out of stir-shaken.
Yep. So right now, as I told you, the US is G8 with stir-shaken. Twilio signs all outbound calls that originate from us. But we've also been working tirelessly on complying with regulation in France. So that's going to be rolled out sometime this year, end of this year. And we're also seeing other countries in the pipeline. We're seeing UK, we're seeing Brazil and India specifically also trying to adopt this framework because they're facing the same challenges as the US. Some other new stuff that's been going on is, so how do you now, when you call from like the US to, I don't know, Germany, right? Like how do you make sure that call is actually legit? So right now there is no incentive for carriers to like implement anything because most of this has been local regulation. But the idea is to kind of have a globally federated CA where you have gateways at each of the borders that re-sign these SIP invites with the CA that's trusted across the world. So that's something that's coming up in the future. But right now in the US at least, if you receive an incoming call, the gateway that's receiving the call is supposed to sign C, so at least the call can be traced back to the provider who routed the call into the US network. So. And something more exciting that's being brewed up in the stir-shaken ecosystem is RCD. Specifically branded calling in the US, a lot of companies want to reach customers and like improve their call answer rates. And right now, I guess just showing a verified check mark also doesn't make people want to like answer their phones. So the idea is to like deliver a more personalized approach with like the company's name, like why they're calling, and a logo as well. So right now, the ecosystem is very like vendor driven, where you have to partner with somebody and they will brand you on a specific, carrier. But there are specs being developed called RCD that extends on the stir-shaken passport, but it also adds a bunch of claims that I mentioned before, like the caller name, reason, and a logo. So this is all done as part of the signaling. So when the handset receives the invite, they're able to just show the logo there. So, any questions?
Thank you. First. I do have to make that remark with the IP fragmentation, UDP fragmentation and the firewall. I was kind of never thinking about it, and sometimes I was, why it's dropping, these firewalls are still under the limit. So good point, feedback that you shared with us. Questions from, we have Fred. Okay, Mathias he works for.
Thank you so much, and I know you guys didn't make the spec or require it be implemented. And it seems like Twilio invested a good amount of money into the known acronym that you put up there. I've seen a lot of the frustration of it being deployed as an end user as well as an implementer. I haven't seen any benefit from it yet, and I'm wondering if you guys have seen any benefit in the reduction of robocalls to users.
I mean, I can't talk for like all of PSTN, but I mean, I would say like probably our call answer rates have improved like outbound from Twilio's perspective, because I guess everyone has to do it for it to be a trusted thing, right? I mean, you can't have one company do it and 5 others not do it and still flood the network with just robocalls every day. So.
I guess one of the challenges we mentioned is it seems like in some ways, like obviously we've been through a few years of struggling with actually getting the implementation out, and it's still not, it in some ways doesn't seem completely pervasive yet. Like I think in the US we still see calls coming in that are not signed, and it seems like when there are two, like if you have 2 actors that have fully implemented the specs talking to each other, they still often end up not having that signature pass through. And I think the biggest challenge, like on Twilio's perspective, for example, is we used to rely heavily on aggregators for carrier connectivity. So we would basically use other companies that would bundle together a lot of different routes to route calls to the US, for example. And what we have found is to really get this to pass reliably to especially the major wireless carriers, we have to go to direct interconnects with them. And there's a lot of other advantages to do that as well as someone at our scale. But one of them is exactly the quality of that route and making sure that we don't have a bunch of intermediaries in the middle, that some of them have well-configured SIP servers that actually propagate this correctly. But we're seeing especially a lot of smaller ones still don't have that capability. And I don't know what is going to force them to sort of get on board. I think one part of it might be if carriers start basically wholesale labeling unsigned calls as spam. And at the moment, it's different between the US and France, where France is being quite aggressive about saying that's going to happen, whereas the US has not really hit that level yet.
Okay, thank you. When you behind you, let's have one more question. Try to speak closer and a bit louder, because for the people in the back to hear better.
Yeah, thanks for the presentation. I have a question because we started to test stir-shaken in emergency communication. And I'm just wondering what would happen to an emergency call that is not signed. So would that be shown as spam in a control room? And the other question is, if a control room calls back and does not sign, so would that ever reach the client on the other side?
We'll get back to you on that offline. There's like, for emergency calling stuff, right now there's no like mandate in the US. So like calls can go unsigned for emergency calls. Like specifically in the US, there's no like call blocking. So the call will end up at the, you know, the nearest PSAP, right? So yeah, but it's still evolving. So I guess in the future, I know France has specs defined around emergency calling, but still like it's in the works. So there's no clear mandate on that yet.
Yeah, I'll say the other thing I'll call out is at least calls to the emergency PSAP generally are using special routes anyway in the US. So I think those are unlikely to be affected, but I do think the case of the emergency dispatcher calling back is an important one. Like if we start seeing sort of wholesale blocking, they'll need to really make sure that those calls are passing through correctly, because that's obviously of paramount importance.
Okay, thank you once again for very useful. And, sorry to rush it a bit, but I don't want to get delayed that much for the lunch break.
I'll take that.
And again, the Twilio guys will be here all these 2 days, and please approach them for further questions. And now we prepare for the next presentation. We have Richard from Singapore. As I mentioned early in my first presentation, he's the developer that actually put a lot of effort in digging in libSSL to find the internal design and make it match properly Kamailio design, because in the latest version there was some unpredictable, quite random and rare nasty behavior, but was not easy to catch because it's TLS, it's an external library. But I'm really, really happy, and I want to thank again to Richard taking time to do it and contributing to Kamailio quite a lot in the past several months. And of course, our thanks for taking the resources to travel from Singapore to Berlin and share his experiences and giving us probably some suggestion for the future. He's also the author of the alternative TLS implementation in Kamailio, the TLS_Wolf TLS. So I think he's set up. Richard, yes. Again, thank you, and the floor is yours.
Thanks, Daniel, for the introduction. So although Kamailio at this point can't solve the stir and shaken problem, at least we can be with 5.8 Twilio's edge TLS proxy of choice. So I'm going to talk about a bug that does not have the 13-year heritage that Andreas mentioned earlier on, but a 5-year bug. So there's a bit of Kamailio history involved here. So in 2019, OpenSSL 1, and when I say OpenSSL 1, I mean 1.1.1, was integrated into Kamailio. And over the years, folklore has developed that you can use TLS, but you shouldn't use too much TLS, right? So if you start to be greedy and want to use TLS to your database or dispatcher or the HTTP clients, then you might run into various gremlins. So that's what I heard on the Berlin U-Bahn, right? Don't fall into the gap between the train and the platform. So from this perspective, it adds a cognitive load to the Kamailio engineer. So if you are a TLS scarred engineer, you would know what to do or what not to do. But if you are a new Kamailio engineer, there will be no reason not to apply TLS everywhere you could, and then you would run into this bug. So the good thing about OpenSSL 3 is at least it made the shared memory corruption much more obvious. So instead of folklore, it is now a hard reality. Okay. So a bit of OpenSSL 1 history. This blog article describes the OpenSSL 1 integration, and it applies to the SIP proxies, the two daughters of SIR. Both Kamailio and the sister use the same three techniques to integrate OpenSSL 1. The first one, due to multi-process load balancing, Kamailio makes the thread locks in pthreads library visible across all processes rather than just restricted to within one process. The second bullet is of particular relevance for us today. It's a rather peculiar thing. Why do you change the random number generator in the OpenSSL library? And we'll take a look at why. And then finally, we have something peculiar, another peculiarity that differed from the 1.0 days. So I will now attempt to do a live demonstration. Okay. So before I do a live demonstration, I do a dead demonstration. This is the sort of error message, shared memory corruption you will get with TLS with OpenSSL 3. Now, don't be deceived. Actually, the bug is also visible in OpenSSL 1, but much harder to trigger. So now I will attempt to do a live demonstration. Okay, let's see. I'm first going to try to show you what is, okay, if I can get to this window. Oh, I can't seem to activate this window. Okay, I'm trying to show you what is, okay. I can't seem to get to my other window, but in any case, this configuration is the Kamailio default configuration that is used in the examples and tutorials. What it does is it enables the TLS as an edge proxy, and it goes crazy with TLS. It will enable TLS to MySQL. It will load the HTTP clients. The Kamailio HTTP clients load libcurl, which themselves then load libSSL. And then finally, in the configuration, I've also enabled the dispatcher module with a SIPs URI. So it's trying to load TLS everywhere, and you'll encounter this. So now I'm going to try to do a live demonstration. Let's see whether that works. And I'll try to run this proxy. Yes, so you can see sort of a successful negative demonstration of the shared memory corruption you see in Kamailio. So there was some urgency towards the end of last year to solve this problem, partly because Debian 12, we started to accumulate bugs in the issue reporter due to the more widespread use of Debian 12 and OpenSSL 3. And we know early in each year we have a new release of Kamailio. So it would be nice to synchronize everything. So the revised integration with 5.8 applies to both OpenSSL 3 and OpenSSL 1. We attempt to fix all these shared memory corruption bugs and to allow you to have the goal, TLS-rich configs. And so the Kamailio engineer no longer has to have the cognitive load of what can I do and what I shouldn't do. In addition, from historical interest, we have retrospective clarity on all those strange code choices back in 2019. Now I'm going to go back to this proxy and attempt to start it up correctly. So, Just ignore, it's always DNS. Now I'm going to, so the difference is just one change in the config, which I'll explain later. And you can see that the proxy at least has started up without the alert messages. I've started my SIP, my test TLS, and generated 600 connections. So now I'm going to try to go down to this window. So I want to show you that now we have 601 TLS connections without any crash. These 601 connections comprise the 600 inbound connections from my test framework and one outbound connection, which is the SIP's URI in dispatcher. Then finally, to show you that the MySQL is working, we should have 600 user location records in the user location database, which means that the user location records have been successfully persisted from memory to the database. So this is what I would call a TLS-rich configuration, and you do not now have to be scared of, how much TLS can I put into my Kamailio config. This configuration just depends on one change in your Kamailio configuration. TLS threads mode is a new global configuration variable available in 5.8, and you set it to 1 or 2. And I will explain to you what is the difference between 1 and 2 and why you might want to use either one of them. So what was the cause of all these shared memory corruption issues since 2019? The root cause is OpenSSL's use of thread local variables, which is just a programming device and implementation detail. This is a black box to the public API of OpenSSL, so you should not know or need to know or care that they used thread local variables. It impacts Kamailio. So let me quickly describe the three thread local variables that impacted Kamailio. There is the thread local and 2 strangely named variables which are related to random number generation. The way OpenSSL uses these variables is each thread gets its own workspace. When a new thread is created, these variables are automatically set to null, and OpenSSL does late binding. So when I need to use the variable, if it is null, I'll assign new memory for it. But if the value is not null, I would assume that it was used earlier on in the thread, and so I don't need to allocate new memory. So this is the way that OpenSSL internally implements thread local variables. And this is where Kamailio ran into this problem of thread local variables. When we do libSSL initialization in thread 1, and then we fork to the worker processes, all the variables are inherited by the workers. And fork is not the same as pthread create with respect to such variables. In other words, you don't get these variables conveniently set to null for you. They retain their existing value. And as a result, when you make libSSL calls, they won't allocate new memory because the value is seen to be non-null, and OpenSSL will not bother to malloc or give you new memory. Now, if your processes had different address spaces, as you would normally expect, this wouldn't be a problem. The issue is that Kamailio uses shared memory to do load balancing, SSL load balancing. And as a result, these pointers that you see, albeit in different process address spaces, actually point to the same physical memory location in shared memory. So This is the takeaway slide from this talk. This is the root cause of all your TLS scars over the last 5 years. Simply thread local variables. OpenSSL does not bother to reinitialize them, and they're pointing to the same physical memory location in shared memory. So why does OpenSSL 1 kind of work, as one of the earlier speakers mentioned? When you do your testing, why does it kind of work? The reason is that early on in the TLS module initialization, they got rid of the random number generator subsystem completely by replacing it. So this got rid of 2 of your 3 problem children, got rid of these 2 variables. Now the third variable was left behind, and it is precisely the existence of this thread local variable that is shared that caused the TLS folklore with in our OpenSSL 1 days. Fortunately or unfortunately, this is a low impact variable. Its effect is much more amplified in OpenSSL 3, and the reason is a change in the library implementation. In OpenSSL 1, this uses far more static arrays. So although the workers are clobbering each other, they sort of do it in an oblivious manner. They don't malloc and free each other's memory, so it kind of works. So that's why OpenSSL 1 seemed to work well. And of course, now OpenSSL 3 blew up because this thread local variable now uses a lot of dynamic memory allocation, a lot of malloc free. And that's why, excuse me, it's much easier to replicate these shared memory corruption errors with OpenSSL 3. So what do the 2 values of this global variable do? The first one is a bit tedious, but I'll explain the value later on. What this does is it meant going through all the existing Kamailio modules and seeing which ones are likely to initialize libSSL. Then for every such function, instead of letting it run in the main thread, it was just executed in a temporary helper thread. So when it runs in the helper thread, you'll see it will leave behind some thread local variable, but when that thread exits, you're back to the main thread, and so the value is still null. Then when we fork into the child processes, at least they will inherit a clean thread local environment. So this is how to ensure that each process will then get a whole set of variables, but they will all be null, and that OpenSSL will allocate new memory for them, so they won't clobber each other's workspace. Now, you can immediately see that this is a bit fragile. If you were to introduce a new module into the Kamailio base, or take an existing module and shift or add functions around that initialize libSSL, it may not be caught by what we have today. So we came up with a more, what I call a blunderbuss method, a larger hammer. What this does is it doesn't change the Kamailio code at all. It lets it run as usual, and we will see that obviously it's going to initialize thread local variables and contaminate your main environment. But just before fork, we could have actually written this code directly in the post-fork handler, the child init handler, or we can use an add fork handler. So at the moment, we just add an add fork handler to the TLS module, and we forcibly set all the thread local variables to null. And you'll ask why 16? 16 is a heuristic. Looking through various Kamailio configurations, it never seemed to use more than 10 thread local variables, or at least the key of the thread local variable never went much beyond 6, 7, 8, 9. So this value 16 is entirely a hard-coded heuristic that we have today. So the observation is the main thread will have thread local variables created. When you fork the process, let's set them all to null so that the child process will see null values, and therefore the libSSL will then allocate new memory to handle these thread local variables. So what are the recommendations? You almost certainly want to use thread mode equals 2 in production. This will definitely ensure that your worker processes have a clean thread local environment. Then when would you use TLS threads mode equals 1? I would recommend you use it for development. And by adding a breakpoint in thread 1, you'll be able to discover which of your functions initializes libSSL. So it might be a courtesy to the rest of us to document that, oh, my function will initialize libSSL. So if you're not careful and you don't manage it, then you might get memory corruption. And you could also use thread executors to wrap these kind of functions that will initialize libSSL. So throughout the code base, in some of the database modules, in the outbound module, we have examples of functions which will initialize libSSL, but they have been wrapped in thread helpers or thread executors so as to not contaminate the main process. Okay. Okay, that's about all I have for solving thread local problems. Now, the last one is just an Easter egg, which is the third bullet point. One of the curious things from this blog article is that in the 1.0 days, we use a single global SSL context to generate SSL objects to handle all the TLS connections. What was discovered in 2019 or thereabouts was that this technique no longer worked. So as an Easter egg, we look into, oh, what changed? So this is more for historical curiosity and sort of code archaeology. What changed was that from the OpenSSL 1.1 days, they used a single RSA key, which is multi-threaded safe. That means this key can be safely used by multiple threads of workers, but in order to disambiguate the workers, so that they are assigned the correct workspace, they require that the workers report their ID through pthread self, and each thread in a process will always report a different pthread self value. So you can disambiguate all the people, all the workers that are using this key. But pthread self is not guaranteed to be unique across processes. So what precisely happened in 2019 is that we are all sharing an RSA key. After fork, we report the same pthread self ID. So all the Kamailio workers are effectively performing identity theft amongst themselves. They report the same pthread self ID, so they are allocated the same workspace, and so, of course, they clobber each other. Okay? So this is just an Easter egg and a bit for historical curiosity, but more or less that describes the new. It's not really new. It's just a revision of our existing SSL integration to help with. And it applies to both OpenSSL 1 and 3. And so you should be able to confidently do TLS-rich configs 5.8 and remove all the cognitive load that you used to have in the past. Thank you. Any questions?
Thank you. Thank you so much. Again, one of the amazing contributions coming from the community in open source. So, question, I see. Then it's Henning for story.
Yes, I'm just having a quick look at the 5.8 docs, and I see that the thread mode is default 0, which means don't do any of the protections you mentioned.
Yes.
Is there a reason why you would want to have mode 0?
It's just inertia so as not to change people's expectations. Yes, so TLS threads mode defaults to 0, which is none of these protections, but it's so that it doesn't come as a jarring shock to you. If you were to run TLS threads mode 1 under a debugger, of course you will see all the temporary threads being used, so that might come as a surprise to your engineers. Then you slowly try mode 1 or mode 2 when you use a lot of TLS. Yes.
Yeah, probably we should switch it on by detecting the version, but yeah, as it was recent contribution, we wanted first to get some feedback, good reports, which means no reports so far of crashing. So yeah, we should test it, but then I wanted to add some still run older version like Debian 9, maybe 8 even, and they still have libSSL 1.1. So I have to review it a bit better and decide how to make default the best option. Anything quickly?
So just to say, when you use TLS thread mode equals 0, it's exactly the same Debian 9, 10, 11. It doesn't change anything. So it's a path of least surprise.
Okay, yeah, thank you, Richard, for the great contribution. Really appreciate it. Regarding the mode 1, just ask because we got now some production system using actually mode 1 because we didn't know that 2 was recommended. Is there like a danger like in production, or it would break if you extend it actually, right?
Okay. TLS threads mode 1 should be used in CI/CD. So when you have new configurations, a bit like what Andreas was saying, maybe you should go into the test system. When you add new modules or you change the code in an existing module, then you want to trap all functions in thread 1. So you have situational awareness of what in your Kamailio config is initializing libSSL. And it does make a lot of difference, the order of the modules, as we all know, because once one module has initialized libSSL, the other modules that call libSSL initialization functions will be no ops. So you can't say that because I have one configuration, I'm safe. Because if for some reason you decided to alter the order of your module loading, then suddenly one module could write to the thread local variables. But I would certainly recommend using TLS threads mode 1 in CI/CD and check that you don't have spurious initializations of libSSL in thread, the main thread.
Okay, so my understanding is that if you load the module that somehow through the dependency chain can link to libSSL and it's loaded first, then you might hit the issues. But if you are having right now a known list of modules and the dependency is known, and then it's safe mode 1 still. It's just maybe in the future, let's say if libMySQL, just to get an example, because it's already using libSSL, but in the future if you don't upgrade to the system and one of the module links to a library that now links to...
Or Kenny.
Yeah, okay. So actually we are late and the lunch should be ready. Quickly before I ask Christian from Snom to give like a Bluetooth speaker for your phones. Choose another next one, and then the lunch should be across the lobby. It's the restaurant should be an area reserved for us.
So it's Lucas.
Lucas Christian, the one that presented before. So let's get slowly back to the places. It's, as I said, first time at this venue, but I got very good feedback on the lunch, so I hope everyone found some option there to their choice of food, from vegan, vegetarian to more meat-oriented. How's called this? Like I miss the word in English. Diet, meat-based diet. For me, was good. So we start the afternoon session. It's gonna be like 4 presentation in a row, then another coffee break, and evening session before the cocktail party, which I said is gonna be in the area here. The first presentation in this group, it's coming from Ramona Modroiu. You may know her from the early days of the project, contributing some of Kamailio modules, Xlog, the diameters that are not much used now. In VoIP, they are used a lot in, or diameter is used in mobile networks. So that might have been a sign, because Ramona kind of resurfaced it lately more into the 5G space. And some of you were yesterday at Technical University. There was an open source 5G related event with presentation not only related to Kamailio, but like 5G core and RAN access based on open source. And there were quite some nice demos there because Technical University campus is covered by the test license. And I think Ramona might even show here like a recording of such demo, because here we can't do any private 5G because we don't have the permission, no license for testing here. Anyhow, I see that people are getting slow in here, so not to start with much delay here. Ramona, let's see what you're doing now these days.
Beepa booba.
That one works.
Take this while I fix that.
Yeah.
Now we are connected somehow.
Yeah, that's good, because in 5G you'll see connectivity is very important.
I'll help you with that.
Thank you. Yeah, now it's working. Now I can feel it. Okay, so I'm Ramona Modroiu, co-founder of Kamailio, but today I'm gonna talk to you about 5G mobile networks and the cross-pathing with Kamailio, because we are at Kamailio conference. I'm gonna talk to you, of course, about open source. I wouldn't dare to talk about something different. And what a solid ground do we have today to build 5G private networks only with open source. I am a research engineer at Technical University of Berlin, chair led by Professor Thomas Magedans, Next Generation Networks. Professor Magedans is also leading the department called Software Defined Networks at the Focus Fraunhofer Institute. He will also have a talk tomorrow at Kamailio World. And As a research engineer at Technical University Berlin, I am involved, and our chair is partner in a big project called OpenSSL Hub. It's a consortium of about 17 partners, only institutes, research institutes in Germany and universities in Germany. We are funded by Bundesministerium für Bildung und Forschung, so this is the Ministry of Research and Education. And as the name says, OpenSSL Hub, our focus there is a lot on openness, open labs, open source, open standards. The most important out of this project will be to advance the research towards 6G, to build specialists, to build students with these skills necessary for understanding, deploying, and advancing research towards 6G, because Germany needs to have a voice in this domain. And this is what we can do. We want to have an important role in education of the next generation specialists. Our lab at Technical University Berlin has to deploy testbeds for students to give them hands-on experience with deploying these mobile network technologies. But of course, probably many of you already know, these technologies are complex and expensive, and to have them deployed just as toys for learning purposes, it's not that easy, or it was not that easy, better said. Also, telecommunication specialists are missing, so students and young specialists need today a very good background in telecom, in cloud services. They have to have very good programming skills. This is hard to find in one person at the moment. So our issues identified, we asked how to reduce the cost for such a testbed and how to reduce the complexity for the students, how to make it more appealing for students to get in touch with this domain, to want to study these mobile network technologies. And we were thinking if open source would be an answer today for building end-to-end 5G testbeds, and we start to search the open source space and to evaluate this project, to play with them on all sides to see what they can offer. And the outcome was very encouraging. There are stable open source projects out there for all the components of a mobile network. And this was possible in the last years, last decade, let's say, or maybe last 5 to 7 years, due to network function virtualization and software-defined networks technologies that did open the path for open source. We identified several projects, and I just put them on this slide. From the user equipment, so that rectangles there, nice colored, are the main components of a mobile network. We have the user equipment, which, for example, it could be our smartphone. The radio access network, this is the antennas interconnected, and then the core network controlling the antenna, and then we have the application functions, which could be IMS, could be something different. And for each of these components, we have some projects, some of them overlap. They have implementation also for radio access networks, for the G node B, or also for the core network. And I'm gonna show you now a bit more details about each of these projects that I have identified. For example, a very nice simulator of UE and RAN. As the name says, it's hidden in that UE RAN SIM, radio access network. It's GPL version 3, supports basic operation of a UE and G node B. You can have the config files already for the most popular 5G core networks by default in their file structure, so you have access immediately of interconnecting this URAN SIM with a 5G core network. It's very good for academia and developers. It's used for testing and understanding, but for testing, it's very sweet. Then another project that it's a simulator. It's called 5G Lina, and if you already use maybe a NS3 network simulator, this 5G Lina is a module of NS3, and it's implementing the new radio, which is actually 5G. So we have here some pictures that show where they are active with the simulator. Pictures are taken from the project's website. They have at the moment support only for non-standalone, which means a 5G network where you have the antennas of 5G type, but you have the core network 4G. It's also very well suited for research, but for industry too, and we had a presentation from this project yesterday at Technical University of Berlin, the event that we organized yesterday before Kamailio World conference. And I was impressed to learn directly from their developers. They are doing strong cooperations with big names, Meta, so Facebook, but not only, I don't remember the others, but they had, it seems there is interest because it's easy to use a simulator for a complex test bed with thousands of UEs or thousands of antennas, which otherwise in a real environment, real testbed over the air setup would be very complicated. So the next one that I would like to bring to your attention is open air interface radio access network. So this is G node B, it's called, the software that controls the radio unit of an antenna. Yeah? We see the type of the license they are using, so it's defined by them. If you want to find out the details, they are available. What's good with this G node B implementation, they come also with a simulator at level 1 and level 2, and that makes easy for testing with a large number of UEs, for example. I don't know if you are very familiar with these 5G technologies, but it's a trend right now to split the components. So what before was monolithic, now to split it in more components. And here that means this compliant with 3GPP and O-RAN alliance specification, central unit and distributed unit, they are then connected via open interfaces, and that should enable small companies to enter the market, and then for operators to be able to have more flexibility in acquiring their components. So you could have a CU from a company, a DU from another company. Theoretically, in practice, we will see what this will bring, but this is what they want to achieve to get more flexibility on this market and allow smaller companies to enter also the market. And of course, they have a good documentation website. Then, of course, if we want a 5G network, we need SIM cards. SIM cards need to be programmed, customized for our network. We have an open source tool, it's called PySIM. People that are behind this project are also here in Berlin. It's a very practical tool to use. More details you find on their website. Then another GNOD, SRS RAN. This is also in a very good shape, stable. It's good also for commercial solutions, but for proof of concept on research and development, it's very good. I have here an architecture, so how it could be deployed in a network. We see the GNOD is the central part, then is the 5G core network on the right side, upper side. In the basic implementation, I would not interest. It's just about management and adding a bit of AI in these X apps, but not only AI. It's controlling the antenna, the GNOD. And SRS UE is also implemented by SRS RAN, and as the name says, is a UE, so a user equipment. And you have then everything in software. They are connected over the 0MQ, and it's very good also for testing without the need of spectrum that needs to be licensed, and with the commodity of having everything in software. Then we go to 5G core networks. Here a very stable, a very good project is Open5GS. That is an architecture of the 5G core. It sounds complex, but and it is complex. We have two in one there. We have a 4G and a 5G. The 5G is only the pinky part. What is in green is 4G. Yeah, so if anybody wants more details about this, they can contact us via email or, of course, directly to Open5GS on their website. But it's a project that it's reliable and we could use very well in our deployments. Then another 5G core that is open source is Free5GC. I have here a picture with their roadmap. They have an ambitious roadmap there. Sounds good. What they want to have ready for this year. It's also stable and ready to be deployed in experimental beds, but also commercial solutions. Then we have Kamailio if we want to add thousands of calls per second. It's feature-rich and scalable and flexible. And newly we have support for voice over new radio and SMS over new radio. IMS extensions are there, I think, 10 years now. So voice over LTE was doable already, but what's new, and I'm going to show you even offline demo with voice over new radio. Before going into a quick demonstrator, I would like to bring to your attention more about our research at Technical University Berlin. We call it Open6G Net. It's an initiative, an umbrella where we try to promote open source for 5G and 6G networks, for future mobile networks, better said. Therefore, we built a test bed based on SDRs that we found available on the market and are very good for teaching purposes. USRP devices are called these. We use only open source tools. We use cloud services because they are today very cheap and available. And what makes us a bit different, we have as a university a private 5G test license available, and in Germany these are 100 megahertz from 3.7 to 3.8 gigahertz are reserved only for private 5G networks, and our university has this as test license available and is covering the entire campus. The blueprints that we have currently in our experimental test bed go from minimal private 5G standalone network to 5G standalone network with voice services. Then nomadic networks, this means we are mobile, we can bring our network everywhere where we have, let's say, at least an internet connection, so that we get connection to the outside world. At Focus Fraunhofer Institute, they use these nomadic nodes for firefighters here in Brandenburg. So they put it on a small truck and fire it up in the middle of nowhere, let's say, and they give mobile network to the firefighters. Another blueprint is reliable backhauls over third-party networks. This means the connection between the antenna, the G node Bs, and the core network is the backhaul, and these are usually expensive if you want to have fiber directly to you. So, but better way is to try to do it over third-party networks, which will be internet, for example, and try to work on the reliability from another point of view. For example, having a VPN application that is able to handle multiple links in parallel. So if you have multiple network cards attached to the machine where the G node B is running, and then you have to see how you dispatch reliable, intelligent traffic between the links. Here we do a lot of research or momentarily. And then we have another working area, automatic deployments using Kubernetes and cloud services. Here, some pictures. This is how a mini private 5G standalone network could look like. It's a laptop connected to the USRP B210, that's software-defined radio. Then, of course, we need the SIM cards, and in a matter of 1-2 days, you can have this set up without, okay, with some background on 5G, not to say without any background. It's not that easy, but it's also not that difficult. And from hardware point of view, you don't need too much resources, but okay, it's for education purposes, not for selling to customers. This is how the architecture would look like for the private 5G network that has voice over new radio and SMS over new radio enabled. So we need at least 2 UEs, the smartphones, we need the SIM cards, we have an antenna realized with the radio unit that you see there with the antennas, and the G Node B is in this case implemented with the SRS RAN, open source software. On the core network side, we have Open5GS, and on the application side, we have Kamailio and Python HSS. And for 5G, very important is that this communication between the core network and the application function, which in this case is IMS, happen over N5 interfaces specified by 3GPP. For LTE and 4G, this communication was done over RX interface, which was diameter protocol, and 5 interface is HTTP to its web services, and specified via an open API. So this is a picture taken when I've done the demo of SMS over new radio. But the next slide will be a video that will show a call over voice over new radio and SMS over new radio. So here we capture the traffic with S in grep, and after un-airplaning the phones, we place a call. And this is the invite, is ringing. And but it don't have sound.
You don't have the sound to HDMI, so probably it's...
No problem, it's only 3 minutes.
I'm not sure if your laptop sends it to HDMI, so...
Don't fall over it.
No. So let's go again. Starting. Yeah, let's see if we have sound, but anyway, at the beginning probably there's no sound anyway. No sound. Hmm? Yeah, I tried, but it's... Huh? No.
If you give it one more try, then you have to do a voiceover. This is...
FNF, yeah.
I think you can choose different outputs and you have to use the microphone output for it, but I don't know on this laptop how you do it.
It's fine because
so
she can show it if you want.
I can show it, yeah, in the room
and
after the...
we can even give you the name who filmed it, this one. It's in the room, so we have witness. And yesterday at the TUB event, we did a live demo as well. Fred was there, and Nick, Dragos. There were like at least 10 people from here there seeing, but yeah, here we can't do the demo. We don't have the Spectrum test bed. permission.
Yeah, so I can only show this offline demo here. I can't fire on all this SDR because this area is not covered by 5G test license that we have at the university. But okay, let's go through the demo to the end. We are now at the messaging part. So that it's already the second SMS that is sent as response to the first one. Yeah, and the smile is on the other side. So that was the offline demo. Further working area for us is, of course, identifying the issues because not everything works like a charm from the very beginning. We have to do a lot of reverse engineering, a lot of 3GPP specs reading, and they are complicated, so therefore we run into issues, and Wireshark have to be there and help us navigate to solve the problems. Our main research areas at the moment within two big projects, OpenSSL Hub and Campus OS, both funded by the Ministry of Research and Education in Germany. So this, what we are interested in dependable backhaul, so how to make this affordable, because for private 5G networks, this will have a very huge importance. And voice services over 5G and non-real-time rig, which is about intelligently controlling the antennas and try to optimize for performances, and also automatic customization using Dockers, and Kubernetes is another working area that my colleagues are looking at. So this was a short introduction about 5G. What I wanted to emphasize was actually the cross point with Kamailio and how Kamailio can enable these voice services over 5G. With open source, this is a first prototype that we made available. There are no other solutions. Yeah, because 5G is so new and it's cutting edge technology. Anyway, we are looking towards 6G already, but 5G still needs to be deployed. It's slowly getting deployed and not completely. It's deployed in a non-standalone architecture first, but we are talking here about standalone, which means both antennas and cores have to be 5G compliant. And this is our team at TU Berlin. If you want to get in touch with us and you think you may want to experiment with 5G private networks and you need to do these experiments, you can approach us because we can offer you, okay, in a limited way, the options to come and see what this means in our labs. Yeah, otherwise it's difficult to get this private 5G license for individual persons. It's not difficult to get it in Germany because it's a well-defined procedure, but okay, you need to apply for a 5G private license, you need to explain why you need, and so and so. So the easiest way, just for a first impression, if you want, you can contact us. We are open for collaborations. Okay, that's it from me.
Okay, so we are already a bit over the time. So 1-2 quick questions, and Ramona will be around for a while today and will return, and then tomorrow as well. Anyone here?
Just a small question. You mentioned that we need to flash the SIM. Can we use eSIM in this case for testing?
We haven't tested them because actually eSIM, it seems easy. Yeah, it's easy for the user, but it's difficult to get it administrated. And for private 5G networks where we have very few users, 100 or 200 users, it doesn't pay off because these eSIMs have to be administrated over third parties. So it's not an option for now for us. For testbeds, we just use PySIM and write SIMs that actually the real hard SIMs are 10 euros per piece.
Okay. Anyone else with question? If not, thank you, Ramona, for.
Ramona, you mentioned that your work group works on 6G. What is the most major difference with 5G? What else?
Well, 6G it's now actually about gathering proposals, what use cases, scenarios. So it's not specified, it's not defined. We don't have any open source implementation because we have no specification. It's in a very early research phase. We are trying to see how should 6G look like, and probably next year should start with specifying it. So it's a bit early, but we use towards 6G a lot at virtual reality and artificial intelligence embedding. So.
Okay.
Fancy things that at the moment.
So it's your time to raise your voice and say, I want 5G to be like this. Put pressure on decision makers. Okay, thank you, Ramona. Once.
Well done.
And we have Ivan.
Thank you.
With last minute editing. Can okay. So yeah, Ivan giving us update about FreeSwitch and SignalWire, which is the company behind FreeSwitch. And I've been last year at ClueCon in Chicago. It was a lot about artificial intelligence and answering and having these nice voices generated, answering your support question, solving your problems in Kamailio config file. And things like that. So I expect to be
yeah, on the first side, of course.
Something in that direction, but I'm sure everyone knows FreeSwitch, and everyone is aware of this ChatGPT and artificial intelligence answering of calls and ordering your pizza or what your holiday getting.
Is it still F5?
Is it F5 still?
Yeah, maybe.
Nope,
shift.
none of mine.
No, maybe.
Here we go.
Yeah. Oops. It worked.
Uh-huh.
It worked. So
Looks like. Yep.
Thank you.
So we are in 2024. I see AI.
These line shows all the time, but I
it's
constantly forget the key command to start it.
Somewhere in your pocket.
Yeah, you got it.
Not next to your mobile.
I'm just going to take my mobile out.
And yeah.
There we go.
Ivan is the CTO of SignalWire and has been in the mobile world for quite a long time as well, before with an operator. I'll let you introduce, but probably you know him from other events and special dangerous demos, usually ClueCon, AstiCon, crashing stuff. He's a specialist of that.
Yeah.
Thank you for coming. A long way also for you.
Thank you for throwing this as always. You know, I've actually, it's sad to say this is my first time at Kamailio World. It has just, turns out direct flights to Berlin, getting out of LA, it just has never really worked out. So I'm thrilled to be here, and thank you, Daniel, for running it, and everybody who puts this together and sponsors it for doing this for so long. Thrilled to be here, happy to talk to you guys. Hopefully you've seen what SignalWire is and who we are. I'll go through that a little bit, but really I wanted to talk about our relationship to FreeSwitch, how that works, and then really kind of what we're thinking about these days when it comes to the future of both the technology sphere and like how the sphere of what we're working in, how we're addressing some of these problems. A lot of it's AI based, so we're gonna cover that a lot. That's pretty much my expertise. Yeah, as you'll see here coming up, I'll just kind of get going. So for FreeSwitch, right, it's been about a fun 16 years so far, right, Anthony? One day the story goes that he was dealing with asterisk problems, couldn't really deal with some problems he was having. He got frustrated one night and had some bourbon downstairs, opened an Emacs editor, and started coding FreeSwitch in his basement. And about a year later, he released the first one. And he really wanted to base it on sort of an Apache model where there were modules plugged into it. And as you've all seen when you're compiling it, that's exactly how it works, right? FreeSwitch is the core engine, and then it has some stuff built in, but then it has all the modules that provide additional functionality. And that was what Tony really, really wanted to get across. And that was 16 years ago. SignalWire itself was founded in 2017, really to basically take it to the next evolution where he had reached the point where he'd really been maxing out individual boxes, but the missing pieces, all of the stuff you need to actually create production grade gear that can go work for multi-million person companies or situations really needed to be out there. And my background was in wireless MVNOs, so hyperscaler deployments of FreeSwitch and containerization, and all the way from right when Docker was first invented and it was really not that stable, all the way to the modern stuff. So he found me, we'd been friends from KlueCon and sort of conferences, and another guy named Sean Heine, and we all started SignalWire to solve the problem of how do you take FreeSwitch and make it into a cloud service that anybody can use with APIs that are easy to access, and you're not just editing XML dial plan the entire time. Which we can all, if we dealt with FreeSwitch, you can know is a lot of fun. Anyway, the quick recent history of what we're up to and how this is working. When we started SignalWire in 2017, the FreeSwitch release cycle was a bit chaotic. They didn't really know when things were coming out. It sort of would mean to have like 5 releases 1 year and then no releases for a year. They've been promising FreeSwitch 2.0 for a certain amount of time. So part of it was just cleaning up all of that. There also was, and you will probably not be surprised to hear this if you know the founding team at all, that there was an intense amount of rapid iteration of features and not a lot of test coverage that actually made FreeSwitch more stable. So things would crash. It was really the community that stepped up and would be like, hey, this is breaking, this is crashing, whatever else. And those guys would jump in and fix it as fast as they possibly could. But that's not really a sustainable model in the long run because it relies on too much interaction from people donating time. Effectively, at the end of the day, someone needs to get paid to maintain these services and keep them running, and that was why we started SignalWire, was to help also keep FreeSwitch alive and provide a stable company behind it that could then make sure that the software stayed reliable. And so that's what a lot of this is. We migrated to GitHub off of their previous Atlassian gear, did a bunch of unit testing, a lot of that kind of stuff, more milestones, more things releasing, over 2,500 commits over the past a couple of years, so really a lot of work that goes in there. It might not be sexy, might not be like necessarily new features, but they are adding new features, little things that keep it running in the background so that all of the applications that use it and all the platforms stay stable. And here we go. Some of the things that I added last year were little things. Like Debian 12 support, packages changed, all that stuff changes, all that has to be updated, it's work. FFmpeg 5. A lot of covariety scanning for security stuff. So the FreeSwitch of today is the most stable, most performant it's ever been, and it will continue to be so for the foreseeable future. So if you're using it, feel confident that it is rock solid. And there are, of course, enterprise options you can come get from SignalWire if you need additional support, but the open source one is still these 3 guys, you got to give it up to them. They put their heart and soul into it for a long time. And this was the original problem. This was written by Tony. He said, the reason they started this was they couldn't find a stable, scalable solution. That's why he wanted to do it. And the solution was they built FreeSwitch, 3 of those guys, over all that time. But at the end of the day, what is it? The current problem is that everything is still too hard, right? FreeSwitch itself, as you know, if you've compiled it or downloaded the containers, whatever you've done, it's still a very complicated, hard product to use. You've got to have a very deep knowledge of both how FreeSwitch itself was designed, XML, SIP, all of the interoperating points. And it also doesn't do everything, right? It's a B2B UA, it's a media transcoding engine at its core, but you still need Kamailio, you need so many other pieces around it to make a functional product suite, or really anything. And so one of the things that we're dealing with a lot right now, and it's very hot right now, is a lot of the AI stuff, right? So let's look at some of the super duper duper very common use cases used by everyone everywhere. The bread and butter of the industry, right? IVRs, contact centers, smart routing, outbound, let's just say like outbound dialing or anything with voice, right? These are all voice use cases. You can also generalize these to SMS use cases for the same exact AI stuff we're about to talk about, but we'll concentrate on voice on this one for now. So yes, the great stuff, right? Traditionally, everybody's rocking things like this, right? Big IVR menus. You have lots of builders for them. Everybody does it. It's out there all the time. People are generally hard coding in DTMF labels, right? You have press 1, 2, 3. Maybe if you're super sophisticated, you'll still have the, say sales for sales, or, say where you want to go. And you'll be like, I need whatever, and it will not be able to respond properly. It's frustrating, even with that advances in ASR and things like that, and the text-to-speech. And so the promise of the AI interfaces nowadays is I can just say something to it like, I'm having a problem with my bill. And it's like, oh, great, here's billing, and get you straight to it. I know in the US this is used heavily now. They're really, some of the bigger companies are working with places like AAA, the automotive assistance people, or airlines when you call them and you're like, my flight to Houston is canceled, or Cyprus sank into the sea and I need to divert somewhere else. You can call them and say that, and they will get you to the agent right away rather than having to have it force you down a tree. So it minimizes time for you. It actually maximizes the time the agents can spend on the phone with somebody solving problems. And a lot of the times you can actually do document-based answers on their own data. And we'll get to that in a minute. But that's the future of where this is all going, right? It's much more natural language interfaces for everything. And voices were the most common used interface that people are going to want to interact, aside from trying to text and do it asynchronously. But if they need something, they're going to call. And what they want, this is what they want. And does everybody know this, or am I super old? Has everyone seen, who here has actually seen, this movie, right? Star Trek, when they go back in time and they save whales. If you haven't seen it, it's great, they save whales. Everybody loves whales. Well, Scotty at this point is basically, he sits down and he says to this guy's like, use my computer to type something up. And so he picks up the mouse and he just goes, hello, computer. And that guy behind him, kind of staring at him blankly, because this is, I think, like the 90s or the 80s, he says, just use the keyboard. And Scotty says, the keyboard, how quaint, right? He expects a voice interface, and he's from the 22nd century, I think, so, clearly a little bit ahead, but this is how people think these days. They're like, I have to type a DTMF in, whatever. They don't want that. They really desperately want to be able to talk to it. Usually, in some of the scenarios we all deal with, people are frustrated, or if they're not frustrated, they want to get something and keep moving. So making everything voice-enabled in the quickest and slickest way possible is the name of the game these days. And all it takes is a little AI. So what are we going to do here? So here's like a sample use case for like an AI workflow, right? So a customer calls in, there's a virtual AI agent that takes that call. You need to have a customer data retrieval at that point. So in this flow, what you're going to want to do is have a way to ingest customer data. You're then going to have, the initial troubleshooting where it kind of does its little magic, and then eventually a user agent actually pops up. A real human is generally behind there somewhere to help the scenes if they can't figure it out. But then you want to make sure that all of that data from the first one flows back in. You can use the AI then for sentiment analysis and all kinds of things to make sure the person is happy or sad or gets resolution or whatever they need to do. There's many different ways to cut and slice this user journey. But a lot of these steps can utilize some of the newer LLM tools and the AI generative audio tools. So what I want to focus on for a second is the actual customer data retrieval section. So I've given other talks, that I won't rehash them here, about how the artificial voices are generated, right? There are a lot of tools out there nowadays for cloning voices. You can actually have your own voice cloned. You can generate purely synthetic voices. So that allows for a much more organic experience with somebody. You can identify them by name. So if they're like, hey, Evan, what do you need? Or I see you called blank. But a lot of that, again, goes back to the fact you got to hook it up to some sort of document or some sort of information on the person, whether it's a database or an API you got to call. So that stage is the most critical stage with all of the AI gear, right? You're going to use services probably like OpenAI or Anthropic or someone like that as an LLM, or you're going to run your own, like a Mixtel thing in the background if you really want to be masochistic about it and just kind of have fun. But you are going to have to wire in your customers' data. And remember, the customers, what do they want? They just want to shout, hello, computer. They do not care about any of this. They want to be able to call and have it identify them by name, know who they are, the last time they called, maybe even the context of the previous conversation or the context of every conversation they've ever had with that business, right? How do you do that? How do you bring into a single call quickly the idea that they have had 5 calls in the past 3 years about, one was about billing, one was about, customer service, one was about, whatever. You want to have those all available. And so how do you do that? Well, who here knows much about like retrieval augmented generation? Who knows what RAG is from an acronym? Cool. All right. So not many people. That's great. So this won't be insanely boring. So this is the idea of how do you take the current AI systems and actually make them useful for these kind of use cases. And what it is effectively taking in the information from someone else's data store. It can be any kind of document, right? It can be a PDF, it can be a FAQ, it can be entire websites, whatever you want to do. You take them all in, you generate embedding vectors about them, so you actually take that data and turn it into numbers, and then you feed that into a vector database, which is basically just a specialized database that can do sort of like nearest neighbor matching on these things. You then have the prompt. The prompt, here I'll show you in a second, is going to be the voice. I can't decide which screen to go to. The prompt is going to be the voice interface, right? So the prompt is going to come in from the voice, the person talking, whatever else, comes into the prompt with the context, goes down through here. So the person says something, the AI agent knows how it's supposed to respond. Maybe it's supposed to respond like Scotty from Star Trek. So it goes like, I kind of do it, and gets to the LLM, and then it goes over to get an output. So when we do that, we're going to take a little tangent for a second. And that was good. So I wasn't entirely sure if everybody knew what the embedding stage was. And this is kind of a critical part of it that is glossed over a lot of the time, is what is the embedding, why is that important, and what does it actually do? All the embedding really is the idea of turning a document into a long vector of numbers, right? If anybody here has done matrix math, it's just like a column of numbers, right? That's how it all works. This is the classic example. This is a 2-dimensional version of this. So a good example on this one, I'll go over to this screen now. A good example on this one is that, let's say we have the idea of what king and queen are and man and woman. So we have assigned numbers to those. And they're kind of, king and queen are kind of close together because that's what they are, or you can generate them this way. I'll actually start the other way. So let's say you have man and woman, right? Those have like a dimensionality to them. We've added there. Royalty also has a vector dimensionality to it. And if those of you who know vector math, when you add vectors together, it's not just adding like 4 plus 4, you also have to add the direction. So if you see the direction here, man plus royal goes to king. Woman plus royal goes to queen, and that is literally how it's represented in the map. So that would be like 1 0.5 plus 0. And it just goes, and you can basically look up what's at 1 1, and you'll find queen right there. You can also do king minus man plus woman gets queen. So the way that those words are turned into the numbers, you can literally just do math on them, and then you get the appropriate answer. This is a 2D version. This is very simple, but this is what Word2Vec uses. This is one of the big updates like 5 or 6 years ago. They invented this, and maybe longer than that, but it was a big thing. And so then, of course, you can have, you go up more dimensions. So let's say you need to capture more information about something. Here's a 3-dimensional one where you get studying sort of up there, where academic studies, reading. It's kind of up there near understanding, but whatever else you want. So 3-dimensional. The OpenAI ADA 2 embeddings, the ones that everyone uses, they're very cheap to use if you ever want to use them. That's a 1,500 plus dimensional embedding. So rather than 2D, you're talking about 1,500 dimensions of single documents. So what's great is instead of just a word, you can pump in anything. You can just throw in a whole PDF in there. You can clean it up, get rid of like the formatting and whatever else. But you strip that all down, or FAQ, whatever you want, jam it all in there. What it gives you back is a string of 1,536 numbers that you can then use to compare against other vectors. So let's say you do this for trying to find answers to something, right? You're trying to do this for some sort of like low dimensionality semantic searching. So you're trying to find maybe not like an exact phrase, but you want to know what other documents talk about this thing that this person's talking about. So let's say I ask a question. I'm asking a question. Actually, a guy named Ernest Jessup just won a prize from the US Navy Reserve, where he took the entire Navy handbook that they give to new sailors and put that into one system like this. And the point was, new sailors show up, and there's all kinds of acronyms and things their commanders are talking to them about, and they have no idea what's happening. And they want to say, you know, what does this one word mean, right? What does deployment mean? And it goes great, and it goes and it knows from having done the entire document, the sections that talk about that one thing, and it finds them and brings up all the relevant information. And then those vectors can then point to where the text is. It'll then spit the text back out because it knows all of this stuff. And that he won an internal award for that one because, you know, it's a very helpful thing for people who don't understand even what they're looking for. So anyway, that is kind of what we were talking about when it comes to the embeddings. So here's a more FreeSwitch-oriented version of that last diagram, where again, you have your documents, you have your customer's data, generate the embeddings, you stick into a vector database, which is basically can be Postgres with pgvector or Pinecone. They're specialized ones that accelerate the searching function of the nearest neighbor. But you go into here in FreeSwitch, right? You go to CAM, customer comes in, call comes in. You run it up through FreeSwitch. Again, you have to have the prompt stuff in there. Other people are giving talks about exactly how to build this, so I'm not going to get into the details of what you would need to do. There are people giving entire presentations on that exact topic. So make sure you watch those and look at them, and they'll teach you how to build things like this. And then you go through the whole LLM and the TTS phases. And the name of the game here is speed, right? So we're doing on time, Daniel. Great. Okay. The name of the game here is speed. Both, and I know I talk very quickly, so both my name is also Speed. I just realized that not everyone here English is your primary language, so I apologize, I should have slowed down. But the name of this game here is also Speed. So speed of that process. When you get the voice in, it's about getting the responses from the LLMs, from the models, getting it into a TTS engine and getting it back again. And that is a hard process to optimize. You take a lot of time streaming things across, right? You have to wait for the generation. Even if you stream that in real time, getting it into the voice, reducing the latency of that is currently one of the biggest challenges and is something that SignalWire has spent a lot of time optimizing, but that people in FreeSwitch are also working on doing. And that will get better over time. All these systems are getting faster and more performant as the years goes on. We're still early in this, but it is going to be, I think, extremely important that these respond quickly. Again, if you watch movies where people talk to computers and the computers sound like people, they respond very, 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 very fast. It needs to be almost real time in order to really fool people and have them not get frustrated at the process. You also need to do, you know, right now if we've all used, who here actually uses like ChatGPT or any of those AI systems with the prompts and whatnot? You guys, people, okay. So there is still a lot of prompt design involved in a lot of this, right? Someone calls and asking for something. You have to tell the agent what kind of personality it should have. You know, am I, you know, am I trying to be helpful? Am I trying to guide someone? Do I want to be, you know, do I want to be grumpy? I'm not sure why you would tell it that, but you can tell whatever you want. And then you have to figure out ways to actually guide people to the customer journey you're looking for. So this is all ancillary work to having to work with FreeSwitch and kind of stuff, but it ties together in the sense that FreeSwitch provides one of the few voice interfaces to these sorts of tools, right? If you're using voice and you're trying to do real-time audio with AI, you're going to need some sort of media engine and transcoding center point that also has a lot of web and functionality hooked into it, and that is FreeSwitch effectively. Let's go here. Yeah, so again, but to build a very complicated system like this, FreeSwitch is one component amongst many that you might need, right? The LLMs, you can use OpenAI, Anthropic, Mistral if you want. You might need a gateway. What if one of them's down and your system is actually critical? Right, you're going to need a gateway to kind of load balance across them, but then you're going to need maybe different prompts for each one, so there's work involved in that. Vector databases, the TTS engines that can do real high quality voice that operate very quickly. Bunch of options there. Whether you want to host it yourself or whether you don't, you know, it all kind of depends. So that's the way FreeSwitch kind of operates in kind of the AI world. And a lot of what we're thinking about right now is how to make that core work with the future of how the world is changing and make it relevant to business opportunities and to the technologists of the future and people who aren't necessarily coming from a VoIP world. How do we get them interested in this particular part of real-time communications? And SignalWire, you know, the point of SignalWire really is that we begin where the kind of FreeSwitch edge of things stops. So like we did all of the work to deploy this stuff around the world, right? So we have 48 kind of global POPs around the world That's kind of what we did because we realized people wanted a place to come play with this stuff and then use it. And one of the big things really that we do now is that we wanted to make sure that we were working with the FreeSwitch community in the sense that we're not here to try to remove or take away business or anything like that. What we wanted to do was really find a way to make it so people who were using FreeSwitch and the associated tools, Kamailio, anyone who's using SIP, to get access to things like these AI playgrounds without having to do too much work themselves, so they can validate if it's a good business use case for them, they can help their customers out. One of the big things that we also provide is like all the SOC 2 and HIPAA and GDPR compliance. So all the big companies that are like, I really need legal paper behind it. We went through all the audit processes and all those kind of great things. And we can take the entire SignalArt API set and deploy it sort of anywhere in the world because it's all containerized and that kind of stuff. So if you need it data residency in places like Switzerland or anywhere, Germany, if you need it somewhere very unique, a customer's like, I want it all internal only. That's all possible while using the same API sets. They can build things on the web and then they can translate it inside. So very flexible in that regard. And we're here also, again, like I said, to really support FreeSwitch. We have community office hours. If you haven't seen them, come jump on sometime. You can ask the guys whatever you want. If you have any problems at all, come say hi. They would love to talk to anybody. It's there, I think, monthly. We have these, and we'll do more if people want them. There is a forum that you can go kind of post stuff in. This is kind of replacing the mailing list a little bit, only because, in fact, I think it has fully replaced it at this point, only because the mailing list was not accessible to people who haven't used Usenet and things like that in the past. They're not super comfortable with mailing lists. So the forum is there. There's also a Slack community if you want to join that. That you can come ask questions. Again, any FreeSwitch questions you have, we're always thrilled to answer them, whatever else. We wanted to make sure, I love that diagram of the person, this one of being supported. We have made sure the modules were all in there. We've actually created a different, if you have your own modules of FreeSwitch and you want to put them over in different repos now, those can be built into Tree so people can actually do their own updates and commits without having to come wait for us. I know it's going to be a pain in the ass sometimes to submit PRs or something else and have to wait for our process to go through and everything else, but if you want to do your own modules and go nuts, that's why Tony built it this way. He built it to be extensible. So don't try to modify the core, just put it into a module, submit it, and we'll put it in the build tree, and you can have anything you want. And we love supporting OSS and all of its glory in all of the different projects. Again, the UI stuff we're kind of building for programmatic building of all this stuff. And very finally, I want to plug ClueCon as well. That's coming up. These conferences are so amazing. We get to meet awesome people. I hope everyone has an amazing time. If you happen or want to come to Chicago in August, we would love to see you there. That's a very developer-focused conference as well, really about how are these things being built, like what are the tools, how to get it done, exactly like, the kind of thing I think that would appeal to a lot of the more technically minded people in the crowd. And then you'll also have guys like me walking around who you can just shake your head at and walk right by. But thank you all so much. I really appreciate it. That's it. Take care.
Thank you. Even questions now from the audience? It's just there.
Yeah, hello, thanks. I have let's say, a bit philosophical question because all the presentations were more or less philosophical.
Yep.
Now you mentioned that the most problem with the AI responders and the voice is actually time of response.
Correct.
So, and I know some of the companies, they're already using this.
Yeah.
And don't you think that this, let's say, quick pushing of this technology will create a sort of first negative view on this technology and it will kill it at the end?
I do think that there's a challenge there where depending on the scenarios deployed in, people can get a negative first impression. The question was, can people get a negative impression if the experience is not good? I think that the experience for most people and most IVR systems is so poor already that anything that's not worse is fine. So we have a lot of room to play. It's like when I was in wireless, if you had, we were doing a lot of containerized cloud work in wireless at the time, and occasionally the servers would crash and calls would drop. And if you were on a landline, people would freak out, like, why did my call drop? People on mobile were totally cool with calls dropping. So we could have all kinds of leeway to play around and restart calls in the middle of them, and nobody cared. Like, oh, my call dropped, I'll just redial. So it's very similar, where people are looking for a better experience. The good time is when you finally get to an IVR system that actually is doing this well, and it is very useful. I called, I think, a healthcare company in the US recently, and it was fast and quick and got me right to the person I wanted. within 30 seconds, and that was a great. I was like, I'll call you back anytime. Made me very happy.
Okay, one more question eventually before switching developer presentation. Okay, thank you. Even
thank you.
We'll be around for further discussion.
No, it's mine. Damn, I almost got away with it.
Yes. Do you find it?
Okay, so Mack, it's at least second times by us here in Kamailio World conference. Of course,
it's third time, I think, Daniel.
Third time. Sorry, I said at least two, so I was not wrong.
Okay.
For me, the pandemic kind of erased part of the memory, so I'm not sure what was before.
Not next to your mobile.
That much.
Your mobile phone.
And,
that's the best decision.
Thank you.
He's part of our community for a long time and tries to make other people use Kamailio in an easier way with some web interface. You might know this SIP router, and he's going to present today about managing SIP credentials, especially when you have like moving accounts, like new and old accounts and so on. But he has now the floor to present more about himself and the technologies.
Yeah, for sure. Thank you, Daniel. Glad to be here today. It's been a while since I've been here at Kamailio World. So I live in the U.S. In particular, I'm from Detroit. That's, if you guys probably know, right? That's the automotive capital, I guess, of the world. I guess still, I guess. And just real quickly, a little bit about me. Been in VoIP for about 15 years now. Normal stuff, computer science, undergrad, grad. My dad got me a computer when I was like 8 years old, I think, and it was a Commodore 64, well, it was a VIC-20 first, and then a Commodore 64. A lot of you probably know what that is, I think. You guys have some gray hair. So I ran a BBS, which is kind of before public internet, and it was kind of cool. My family is not that large, but large enough, as you can tell from the dependency graph here. My wife depends on me, and then everybody else actually depends on my wife. And that's a picture of our two younger kids there at Christmas time. So a little bit of the agenda today. So I'm going to talk a little bit about DSIP router, just give you an overview. I'm not going to bore you about it because we've kind of implemented this dynamic SIP credentials inside of DSIP router, but you will be able to build your own inside of whatever project that you're working on in regards to Kamailio. And the link to the kind of the code to do that will be at the end of this prezo. I'll talk about the problem space, talk about the solution at a high level, and then talk through the architecture. And then I'll do a quick demo, and then I'll take questions. So I have about 24 minutes worth of material. This gives me a room of error if I start getting on a tangent. So let's go ahead and get into it. So DSIP router itself was just a project that kind of came about from basically me trying to understand Kamailio. It took me a long time to kind of figure things out. I mean, maybe for y'all it didn't take that long. For me it did. Wanted to create something that was like FreePBX, but wasn't FreePBX, that allows you to kind of have a UI that will build things for you, and then you can kind of learn by looking at the underlying configuration. So kind of the core components here of DSIP is obviously Kamailio is at the core. Then we have a Python-based UI and uses Flask, obviously for doing RESTful endpoints. RTP engine, some bash scripts for doing the install, good old bash. Nginx to receive, obviously, HTTP requests and then optionally Docker. The reason why it's optional is because at first we were shipping, the whole goal was to ship modules as Docker components. We kind of moved away from that a little bit. Project's been around since 2017, so we've been having a lot of fun with the project. Why should you care? I think people aren't, I always use this as a story, like when I'm recruiting people to work at my company, especially younger folks, nobody's jumping out of school saying, hey, I want to be a VoIP engineer. You are probably, yeah, but you know, we're older now. I'll be 50 this year. So looking at just the landscape, we needed to be able to support younger folks coming out, and this is one of the reasons why this project's important to me. The other thing is that some of the design principles that we wanted to do, you know, obviously we're installing all of this stuff. So at the worst case, if you're like, you know, hey, I'm a Kamailio expert, you can use our installers. Our installers, you can actually just say, you know, dsib router install cam, and it'll install the latest version of Kamailio, and RTP engine as well, right? So we just sometimes, in some cases, I just use it just to install for me, right? But the big thing was that we wanted to stay true to the trunk, right? We didn't want to actually have some type of fork of Kamailio and kind of put that into our own fork and then have dsib router use that. We are actually pulling everything from trunk. And we really wanted people to be able to route traffic quickly. So we also ship with a configuration for carriers already out of the box. And then also we wanted to minimize database interactions during runtime using HTABLE, right? To hash those things, right? So, and then we wanted to also push back on feature overload. So people ask us all the time to add stuff. It is made to be simple. Because if it's too complicated, then it becomes the same problem we had initially, is that it's just difficult to start using. And then at the end of the day, we want to provide a path to people being able to move to the point where they can actually have more of a customized version of Kamailio, and that's where y'all will come into play, and where they may start with dsib router, but at the end of the day, they may end up being just running core vanilla Kamailio with your help. So the problem space that I'm dealing with is one that's very selfish for me. I actually have a number of folks, and even myself, that still support and deal with brand new customers. And typically this is, again, the younger folks that are joining the organization, and they don't have the same level of understanding what the impact is of having SIP credentials that are left on the box or leaving things open. Still trying to, they're not used to that, right? They're used to doing a RESTful call, right? Call and response and getting a response back and things are done. So the biggest issue we had was that when we were setting up a new system for somebody, and you guys probably always been there as well, is that maybe the carrier config or the carrier hasn't been provisioned yet. So, but however, we want to finish our work before we can sign off on the statement of work, right? Get paid, all that kind of stuff. So a lot of times we end up doing is giving people SIP credentials just to test out their system, right? To do some load testing, do some functional testing, things of that nature. The problem is that these young folks sometimes, and even myself, I've done it as well, you forget about it. You forget about those SIP credentials. And then all of a sudden, overnight or within a month, we either get a bill or we get some type of fraud alert saying that this account is now canceled or put on hold. So it's just really a way for being able to deal with long-lived credentials that got forgotten about somewhere. So the other thing that we start using it for is really doing testing, because we spin up, for our testing, we spin up dsib router quite a few times, especially during release cycles, And we need to be able to do load testing and things of that nature. And just to automate this, we needed a way to be able to create credentials quickly and then throw it into our load testing kind of platform. And then the other thing was, and the reason why this kind of came about originally was that we had some folks that just wanted to, remember our typical person who's using DSIP router is somebody who wants to do something in the SIP space, SIP trunking, something of that nature, but don't understand all the things that needs to go into it. So this one user wanted to create trial SIP accounts so that people could test their service out. So this is also a good way you can generate SIP credentials that only live for a small period of time. So it has the time to live on the SIP credentials. So let's talk about the solution overview here, just really quickly. So you got DSIP router in the middle. You may set up some carriers there, and you need to be able to get some credentials to be able to authenticate the DSIP router to send traffic out to those carriers. And the way it works is that, number one, there's a lease endpoint. You call that endpoint, and you're also authenticated, right? So DSIP has the whole concept of an API token. But you can call that endpoint. It will return to you some SIP credentials that has a time to live. By default, it just does username and password credentials, but it could be modified to support IP authentication as well. So basically, it will take whatever IP address that you're currently residing at, or you give it an IP address as a parameter, and it will return it will basically provision that IP for a time to live. So same thing, but out of the box, it does username, password, credentials. And then from there, you can take those credentials and put it into your UA, and then you can place calls, right? Pretty simple, and I know you're probably like, this is not rocket science, but it saves a lot of time and reduces our risk when we're dealing with new support engineers that's on our team. So let's break out the solution architecture a little bit. So really, I separated out DSIP router and Kamailio, so you kind of understand who's doing what. So all the things I just talked about, all those API endpoints for number 1 and number 2 goes to DSIP router. DSIP router then updates to Kamailio DB. And then Kamailio is obviously leveraging that Kamailio DB so that when a user agent makes a SIP invite, it's able to authenticate that call and allow them to call out to the carriers. Really, the two modules or the two tables that we're actually using here is the subscriber table, and then we have a table we created called DSIP_endpoint lease. And really what that does is this keeps track of the leases. And then we have a cron job that just simply cleans up those leases. By default, that cron job runs every 5 minutes, but for this demo, I just changed it to 1 minute, right? So didn't need to wait for 5 minutes for that to happen. So this is kind of the high-level kind of architecture of how this kind of works. So I'm just going to drop into a little demo, and let's see how this works. I'm going to make my screen a little bit bigger for you. That look good? I'll take that as a yes. Thank you. So I am just using curl here just to generate this. This curl statement is just calling our demo system here. There's an endpoint here called API v1 lease and endpoint. And what I'm actually giving it is the time to live is, in this case, 1 minute. And I'm just getting the email address so we can kind of track who's actually doing this. Again, this is kind of the default config, but you could do whatever you want. You can track more information. You can actually have it, maybe they won't be able to place any calls out until they validate their email address. I mean, you can do all kind of stuff here. So what this gives you here is this some credentials. Really, I'm just going to drop these credentials into a phone here, and it gives you, it generates a password and a username here. So I'm just going to grab my Zapier here, And I only got 1 minute, so I gotta hurry up. So lease 34, drop the password in, and I'm just going to just register really quickly. So now I can place calls, I can do whatever I need to. In a minute or so, these will become unvalidated. I'll just dismiss this, so we'll be able to tell when it becomes invalidated. But while that's doing it, I'm just going to quickly jump back here and just kind of show you. I already kind of told you how the API kind of works, at least on the generating a new credential. But we also have a revoke, and so this is very important. In some cases, let's say if you make obviously I made the TTL 1 minute, right? So it will be good in 1 minute. But let's imagine if you make that TTL maybe 2 days. And let's say for some reason that system gets hacked or there's something that happens, you want to be able to do a revoke. So you can simply use the revoke command or API to actually revoke that particular credential. You give it basically the lease ID in order to do that. The other thing I'm going to say here is that we also have a Postman collection as well. So that has all our APIs on it. So if you wanted to go see the other APIs or just see examples of how it actually works, you can go there as well. So let's go back to our phone. And so you can see now this is invalidated and goes from there. So this is a very powerful thing for us because remember, we're setting up systems, a lot of systems typically throughout the year, and for them to be able to quickly generate some credentials and throw it into a system and start testing makes things very, it makes the workflow very, this makes it very simple for us. So a couple more things I want to talk through here is just some use cases for this. I'm actually doing pretty good on time. So really, at the end of the day, what I kind of phrase this as is a SIP vending machine. So really, I can just call this thing to get SIP credentials. And in particular, we use it in our CI/CD pipeline as I talked about before. So basically, when we spin up new systems, we will actually call. So we just have a DSIP router instance that does some other things, but primarily is a SIP vending machine. So you call it, you get credentials, and then we inject those credentials into other systems for doing testing or things of that nature. I did it pretty quickly. I am awesome. I did this pretty quickly. So if you want to learn more or you want to see the logic for this, it's located at this link here. You'll have access to the slide deck. I'll be around, and I'll just open it up for questions.
Here he is.
I must have did a great job. No questions.
It's really fast.
Yes.
Okay, so I always watch this SIP router project, and I like it. Like you make it easier in the way, but or from my perspective, always was a hassle. All these web interfaces. Do you get this stress from community? Like I would like it now to be pink. Can I make it easy? Change to suit my company color line or so?
All the time. All the time. Colors and stuff, that's fine, but we try and push back on adding all this stuff to it, particularly for unique use cases. So I really just try and focus on just staying up to date with the latest releases and just making sure the stuff we're putting in it is going to really help newbies and people who are trying to make their life simple, because in some cases, some of the commercial stacks are just complicated. So we just try and make it super simple for them.
Yeah, and more on the topic of the presentation, which I had to miss a bit because of admin task outside. With these credentials, now it's like you allow how you found it easier over the years. So still people allowed to generate their password or introduce their password? Because I have seen many, they generate it internally and they will display to the user like temporary, take it, copy it, and put it to your device. If you forget it, generate another one from the admin because they feel it's safer. But how you feel is this with user password to what would be a good solution to make it easier for non-tech guys, to think I have 2 uppercase, 2 lowercase, I have special character.
Yeah, I mean, it's a good question. So really, we just use this in just to make it easier, just to generate credentials for test situations. So this is not necessarily something that people would use every day. But I would like to extend it, though, to, because as we all know, whenever you provision a SIP endpoint, it's typically that password is there for the life of that endpoint. There is no rotating it. I would love to see more, because I think that's a big attack vector. So I would love to see people do more of those dynamic credentials for that. And then, obviously you'll need to have something that would, update the credential, then send a notify to the phone in order for the phone to actually get rebooted in order for it to use it. But yes, I would love to see more of that. But we're trying to make it super simple for people to do it.
Okay. Anyone having questions from the audience? It's one here.
Yes.
Thanks. Were you thinking about making the TTL starting the moment the client logs in, meaning like you're going to make it like for 1 minute from the first usage of the credentials?
I'm sorry, repeat the question again?
The question is were you thinking about, because right now you make an API and you go to credentials and the 1 minute has started from the time you make this API.
Yeah.
Were you thinking about making it in a way like if the endpoint uses the password, then the TTL starts from that moment?
I never thought about it that way. But I guess you could. I guess my thing is I guess so. I never thought about it that way. So basically, the first time they make a request, so I guess here goes the deal is that I guess it would be a SIP request. So as soon as they make a SIP request, then we would actually activate the timer at that point. See, that's why I like coming to Kamailio World. I never thought about it that way. But that's a good one. So honestly, this actually came from, and we're working to build one now. Does anybody use HashiCorp Vault? Okay. So the concept of dynamic credentials and secret engine. So we're building a secret engine to do this. So basically, if you're using Vault, and for those who don't know what Vault is, but it allows you to do secret management and it has a whole concept of dynamic secrets. So basically, if you want to be able to, let's just say you're provisioning a set of servers. Let's just say you're provisioning a set of servers that have a database backend. Instead of giving every instance of the system the same username and password, it will automatically generate a unique username and password. And then it can also revoke those after a period of time. So that's really the concept that we were thinking of, that we would dynamically create these, and then after a period of time, it would die. But you bring up a good point. I will have to look into doing that. I love it. Thank you.
Okay, thank you, Mack. Thank you for taking time and resources to come here again to.
No problem. Super simple. Thank you.
Now we move to
sorry.
Thank you. The next
it's just a night mic.
Presentation from Kirill is going to tell us a bit more about Ring Central's geo-distributed deployment scaling across the world. First time presenting to our event, but the topic is somehow very interesting for everyone. As we know, Kamailio is targeting always scalability, geo-redundancy, so I'm sure we'll learn some tricks from this. I'm sure many, at least from US, know the Ring Central. It's one of the major telephony providers there.
We should do it again.
Again. If you turn it off and on.
And we know it's going to be a good presentation because with Linux always we have problems.
Okay. No. Okay, not a problem. Unified. Oh.
We do this again.
Perfect. That doesn't work. We can do this. I have.
Maybe your HDMI port is a little bit destroyed.
I suppose no. It works. It works.
It works on my machine.
My monitor, yes.
Yeah. Let's see.
Oh my god. And nothing changes. Nothing changes. Yep.
We'll do it again, this share feature. Re-invoke. Yay!
Wow. Okay.
Great.
Actually, it's... Yep.
The mic? Yes.
Yep. How should I do this?
Just talk.
Yep.
And then put
Does it work? Yeah?
No,
Yeah,
sure.
it's working.
Yeah, great.
All good.
Perfect. Perfect.
Okay, Kirill, thank you for coming. Really appreciating. Again, always a good topic for Kamailio and our audience.
Thank you. Thank you, everyone. My name is Kirill. I'm from Ring Central. Yes, I will tell you about the Kamailio in high distributed, high load, reliable systems. When I firstly created this idea about this presentation, I thought like, okay, let's go and create the maximum unified the name. But when I tried to read it every time, it's really hard to read the name, so you can read it by yourself. My English is not so good to read these high complex sentences. Okay, as you know, I'm Kirill Tikhonov, the guy who jokes. You have 4 lines there, but what you need to know, it's one line that I have been working in Ring Central and creating the routing system for Ring Central, the SIP routing system for Ring Central, about the 6 years. 6.5 years right now. So that's me. Small disclaimer, we will talk about the UDP, just because it's much more simpler to describe the UDP, not about SIP over TLS and so on. We have rewritten some modules of Kamailio, registrar, dispatcher, and some examples from the code can be executed on the vanilla Kamailio. But I suppose that's not a problem. You can adjust it. It's not a problem, I suppose. And I will mostly talk about the proxies. Not about the SBCs, not about the media, about just proxy part of Kamailio. And the last but not least, that's not how Ring Central works. Ring Central works like it's more complex, it's more difficult, it has a lot of legacy, the good legacy, yes. So it's not how it works, it's like generic things, how create things better. And the main disclaimer, that's not rocket science. If you search for the rocket science, go to the rocket science. But my friend who works really in the rocket science, he says that even rocket science, it's not a rocket science. Okay, problem statement. We have a lot of UAS servers, telephony servers. A lot of them are distributed all around the world. And we have a lot of data centers. They all distributed all around the world, and we have clients all around the world. How to handle it? The distribution all around the world have great latency, have replication problems. The people write book about these problems and how we handle all this data and how we handle all this data with Kamailio. That's the problem, and that's the plan. I will show you the standard scheme. It's SBC, client, session border controller, yes, then the Kamailio proxy, when the server. We will get the distribution of server, we will get the distribution of proxies, and we will get the distribution of clients. We will handle all this data, and that's all. Standard scheme. What do we have there? We have client, we have session border controller, we have Kamailio proxy, we have UAS server. Proxy and register handled by this proxy. It has like own database, it has something like this. What can we do in this system? It's like a quite solid, we can't distribute it somewhere. What we can do? First of all, set and adjust timeouts. I know everyone set timeouts, like from the TM module T1, T2 FR, everyone adjusted, but we need to adjust it in every step, and we need to review them once in a while. Why review them once in a while? I have a bug once upon a time, a lot of retransmits to the US side. What's going on? What's going on? The Russian submarine cut the internet cable in the Atlantic Ocean, so we have like these problems. So you need to review it every several months. We will make US distributed servers because many servers can handle many requests. It's the simple mathematics. And we will make the proxy stateless because if the proxy is stateless, it can be distributed more easily. Yes? First of all, timeout. Easy, as I said. T1, T2, FR timers in TM model, you just set it if you are familiar with these timers. But if not, T1, it retransmits packets every blah blah every time. T2 is stop retransmitting after. FR, the final response timer, if you are final response, go to the next hop, try dispatch every next destination. So you need to set them, validate them, and review them. We will make US distributed, server distributed. First of all, we would like just deploy another server. That's okay. Everybody does this, I suppose. If not, it's a pity shame. So we just set another, but we can do this. It's the distribution already. We have two pools of servers. One is primary pool, one is backup pool. And dispatcher can just handle it easily. We have several timeouts. Why we have first timeouts and several timeouts? Because these pools need to be and have to be, I suppose, and better, not have to be, better to be geographically distributed. Because if you have backup pool and the primary pool in same data center, and the data center goes down because like it has no power, you have primary and backup pool goes down because of this lack of electricity. So you need to distribute them all around the world. So you need different timeouts. How it's done? It's the example of code. It's pretty simple, I suppose, but you can use DS select domain, you can use DS select destination, DST. So you use dispatcher. From the dispatcher, you use the primary pool. There is an example, it's a round robin, free routes, and if it's no, go to the failover route. Failover route uses same dispatcher with the another pool. From another country, another region, available destination, availability zone, you can call it everywhere. As you want it, you can call it. So another pool. But with the dispatcher, you can handle timeouts automatically. How it works? Dispatcher have attributes, additional attributes for the destination. You know, the key value. In the dispatcher list file, you just can set key value, key value, key value, key value. And if you use the database, it's called like DB's extra attributes. You can have these extra attributes to store timeouts for the current destination, for each destination. And when you go to the real sending of packets, relay, you can use them. That's an example from the dispatcher list. You can get the attributes from the dispatcher part, from the destination, and apply. What's the best from this point? I suppose when you go back, it works generically and on the first initial dispatcher part and in the failover also. It's just before the relay. So it automatically applies every time when you decide to get every destination. So it's like generic decision for every destination. If you want, I can share you the presentation after or just give you a link. It's not a problem for me. Okay, the third part made proxy stateless. I suppose everybody knows how to do this, just need to mention it. You need to move register somewhere in the database. It can be shared store, shared database. It can be third-party service. It can be another service. It can be self-written service. That's not a problem. You just have register storage to make proxy stateless, to make proxy shared, not to get like a lot of proxies to handle all this. So you have proxies, a lot of proxies, and you have register storages. Register storages have to be synced, because if you go to the one pool and another pool is not synced with this, you register in one, you send invite to another, that's all. 401, yes, re-register. How it looks like? We can add SBCs there. I have the question marks. How it looks like? It's backup pool, primary pool, but in fact, it looks like two absolutely functional data centers. So, yep, with make everything shared, we should make data centers fully functional and fully work. What we can add there, the GeoDNS, the scheme is not fully right because like UART doesn't go to the GeoDNS, and through this, the client, the phone asks for sip.kirill.tikhonov.com. Yes, and where is this? If DNS server answers with the closest data center to the client. If I will go to Australia and we have data center in Australia, we get the DNS, the IP address through the DNS server of data center in Australia. We get the SBC Australian one. So we have two pools. It's not a primary pool and backup pool. We have two fully functional data centers. Let's summarize what we should do from the first part, from the standard scheme to get two data centers. We should make everything stateless if it's possible. If it's not possible, we should synchronize as the registers. We should synchronize it because we have to synchronize registers. Because as I said before, register there, invite there, you can't. But all databases have sharding, have synchronizing, so you can do it out of the box. Mostly you can do it out of the box, but okay. If it's not possible, you can use stickiness. Dispatcher can handle stickiness. It can handle round robin, a lot of distribution algorithms, and you can choose the stickiness based on something. I don't know, maybe on a call from header, yes? If you have stickiness on the from header, you will go to the particular server every time. So register, invite every time. So also, every service should have failover location. When you go there, proxies have failover to another pool. SBC can failover to another pool from the up to down, from down to up. So everyone should have failover location. Okay, and review timeouts, as I said before about the submarine. Review timeouts every several months. Because new cables are laying there, so like latency is constantly going down in our world, so you need to renew this. Okay, several availability zones, we will call it several availability zones. Several data centers are distributed geographically. It's not a big deal. It's like 2 data centers, it's not a big deal. How about 20? It's a problem. It's a problem, why? Because you can choose what is primary when you have 2 data centers. You have one primary, one backup. Primary, it's your own, backup is the second. What you should do? You should group these data centers into primary and backup groups. And primary usually, it's like my data center, it's one destination, because it's have less latency for the data. And the backup is the several closest data centers. Why I say closest? Because of this. That's the ICMP packet statistics, like ping, based from the Sydney to the Europe, all around the Europe. So you have this 200 milliseconds, like 300 milliseconds for the one ICMP packet. Like, it's a problem. So you have to choose these closest data centers. Also, you can actually adjust timeouts via the matrix of destination. Example, you have all these 20 data centers all around the world. And you have call from, I don't know, from US to Australian data center. It have a lot of ping. It have a lot of delay, the propagation delay from the packet, and we should calculate it. How we should do this? We have matrix. What is matrix? Matrix is this. It's easy one. You have destination. You have tags of destination. All these names like New York, Sydney, yes, Berlin, Amsterdam, Lisbon, all these cities or landmarks can be headers or logic in your system. Okay, you have New York to New York 30 milliseconds delay. Why 30? Because when I played around 20 years ago in Counter-Strike, the minimum ping was 30 milliseconds. Like it was like this. So in this destination, it's also like this. So you have this table. It's mirrored also, because the values are really mirrored. So you have this matrix of destinations and timeouts. You can adjust it. Yes, also one disclaimer. Here is really the propagation delays, the timeouts. But you should to store there the real timers. T1, T2, FR in white, so you should store there the timers. When you store these timers there, you can adjust them, because what you have proxy. Proxy knows its geotag. It's like, I am proxy from New York. You have the dispatcher list there. And in dispatcher list, when you inject something into the dispatcher list, you know what you inject. And you know the geotag of this injected value. So you can calculate based on this. And this, you can calculate the timeouts of this like route, the current route. And use them automatically, as I said before. So when you use the road branch, you can use, because they are lying near the dispatcher part in the attributes, additional attributes of the dispatcher list. Okay, that's about a lot of data centers. Big data centers, it's also a problem, but it's fun. I call it fun, because like I have a really, really fun bug, and I'll show you to you. Okay, big data centers, 200 of servers there, 200 of servers at the bottom. What possibly could do wrong? Kamailio can handle a lot of dispatcher list, can handle a lot of servers, and that's not a problem, really, of course. But sometimes the network goes down. If network goes down there, from the top location proxy to the server of second pool, what can be possibly go wrong? We have dispatcher, and we have probing state of the dispatcher, like server, or the dispatcher destination. And if you have these two configurations, dispatcher server ping interval and ping method. Method can be option, can be message, it doesn't matter. I use option, but you can use anything. If you have this, you blacklisting these servers from the proxy and generates every ping interval 200 requests to the somewhere to the network. So if you have DS ping interval 1 second, you have additional 200 requests per second. But in fact, none, because it's the initial requests. There are initial requests. It's not including in this count the retransmits. So in fact, you can just add in 200 servers and do nothing. Just drop down the link between the proxy and US. If this top trying to fail over, it's continuously start to blacklisting servers and generate the crucial amount of options or messages like ping requests, health check requests to the server. It can be like 1,000 of requests per second out of the box, just out of the box. Okay, the last but not least, about the clients all around the world. So what we have? We have servers all around the world. We have data centers all around the world. We have proxies all around the world. We have clients all around the world, UAC. What we should do there? Everybody in the HTTP, in the web, everybody uses the CDN, content delivery network. So yes, we can like mimic this CDN with the primary CDN. I can show you how. We have client from Australia, and client from Australia calls to the US. Invites goes there. It's a yellow invite to the session border controller on the US side. But in fact, it goes for something like this. It goes through the public network between the Australia and US. It's not quite good. I know it's like SIP over TLS should be there in UAC and SBC, so, but it's like a seconds there. So what can you do? You can not generate, you can build, buy, adjust, I don't know, SBC in Australia. So only SBC. What can be done there? The public network path will go from Australia to Australia. It's like a little determination between this. But from the SBC in Australia to our United States data center, it goes through our private network. And our private network should be better, of course, because we are paying for it. So we have selective channel. We have good like ping statistics. And we have better things. We not rely on providers from the Australia, yes, which goes to the traffic abroad. So we can do this. Also, what we can do, we can pass the meta information about the client's destination. It's not about the client's destination itself, it's about the session border controller destination. I will show you how it works. We like use timeouts. It's the invite. We use the same transactional from TM module, transactional timeouts, T1, T2, FR, everywhere. From the proxy to US, from the proxy back to UAC, it's SBC and UAC, but I used the UAC there. We use the same timeouts there. But in the previous part, we store timeouts in the distribution list, this in the distribution list file, and we apply them. We don't count the distribution between the proxy and the client. How we can handle it? We can add at the SBC side some header, geotag also, the same geotag. And if the client goes to the SBC in Australia, it can inject the header to the register, to any like request, to the subscribe. So it can add header, extra header, information, region, I'm from Sydney. What can do proxy from this information? Proxy have the source of packet, I'm from Sydney. The destination of packet to the server, server from US side, like New York, and the proxy is in New York. What can we do? We can use this, the same matrix of destination, matrix of timeouts. We have 30 milliseconds between New York and New York, and we have 200 milliseconds between the Sydney and New York. And we should use the maximum one, because it's a transactional timers, it's a bidirectional transactional timers. We should get the most big out of this too. Or we can just adjust it on the fly. It's like a little bit complex, but I should get it. We have the same thing. When the proxy proxies the invite to the server, it sets the timeouts, the initial timeouts, as I said before, from the dispatcher list. We can do anything with 100 trying because it's self-generated. Proxy self-generates 100, US self-generate 100, we can do anything. But when we pass ringing from the server to the client, we can change these timers right on the fly, because transactional model supports this right on the fly. How it can done? I can't send you a quote via the dispatcher, but I show you the whole idea. What we can do. As I said before, session border controllers sends region tag to the proxy. Proxy gets this region tag and gets itself's region tag. From these two regions, we have the matrix. It can calculate the timeouts and save it for the future. After that, the proxy pass goes there to the SBC with initial timeouts. And when you go to the answer, you have this on-reply branch. And on-reply branch, from the US to the client, you can adjust the previously saved timeouts. So you have, right now, what do you have? You have transactional timers. They are transactional, but they optimal on the behavior of your proxy. From the proxy to US, it uses 1. From the proxy to UAC, it uses the second one. And they can be adjusted out of the Kamailio, out of the box. How it's like work in another way, because it's like a little bit complex, and I'm trying to describe different ways. UAC invites to the proxy, and you save the information with the timeout of the initial request. When answer goes and you proxy it back, you apply them. You just apply them because you saved them before in the on-reply branch. And I suppose that's all. It's summary, the distribution. It's all about the timeouts and the failovers. And if it's no the failures, it's about the scalability. Make everything stateless and scale everything. So thank you. I suppose that's all. How about the time? 26 minutes.
Thank you. We have Tori already.
I actually have 2 questions. One is you are doing different retransmission times per dispatcher group. Have you found a way to set those times for the actual option pings as well?
The problem that it's not adjustable with the options. Yes, yes, that's the problem.
And the second is, what is your? Do you have advice in terms of taking the latency metrics and converting that to values for the T1 and T2 timers?
I have, but I'm not sure that it's applicable for you because, as I said, it's heavily rely on the transmission layer. It can be UDP, it can be TLS, it can be TCP, it can be TCP over SIP over TLS. So it depends really. I suppose it's a practice, and you should ask the network operations if you have some. If you don't, you have to figure out the reliability of your network. How many retries do you can you support? So from my point of view, it's like mostly empiric part. So we had some examinations based on the bad cases. So we constantly describe the bad cases and adjust timers. We work with that way. I suppose that's all. From my point of view, 1 or 2 retransmits for the destination, it's okay because you have a plenty failover for dispatcher. Failover destinations for dispatcher. Oh my God. I'm sorry, yes. From my point of view, 1 or 2, it's okay for the, for retransmit for the one destination. And if not, you can go to another destination from the dispatcher.
Basically, you're trying to get it as short as possible without getting a
Yeah. And we have final response timer.
Before you hurt yourself, I will help you.
Thank you very much. Yeah, and we have the final response timer, the generic final response timer. When you call, you have like 3 seconds. If you don't get the answer for the 3 seconds, like ringing, something goes wrong. So we have these 3 seconds. For these 3 seconds, we have to get all destination in the primary data center, like 2 or 3 of them with 2 or 3 retransmits and go to the backup.
Okay.
It's compromised, yeah.
For the options retransmission timeout you asked, right? Generated by the dispatcher. I saw the developer of the dispatcher module. Okay, it's me. Doesn't work with the event route local request to set it. So you have this event route from TM module, which is executed for local generated request, and then you should be able to set the to use this tsetfr function there. I haven't needed that one, but I expect to work. So it's not actually dispatcher. Dispatcher push the option, but it's via TM. So TM should execute that event route if you need it. And then you can adjust the timeout from the event route. Just try it, just an idea. So I haven't done it myself, but
I remember
from
it
the
used
architecture it should.
Setting. It used global timeout settings
But that's,
from the TM.
But if you set it with the function, TFFR should work also for the local transaction, no?
Yeah, my interest is because I don't want to wait a full 32 seconds before realizing and declaring a node is dead, for example. But I do want to still keep that for normal calls a long timeout.
Yeah, but you can do it per transaction with the tsetfr. It's an old function. Maybe Jiri developed it, so just to point to some other guy in the room. Okay, other questions?
Yes, I have a question. You mentioned that the proxy is stateless, and what will be with the call if this proxy goes down during the transaction or during the dialogue?
What would, with the Kirk's invite, yes, during the transaction. In fact, we have another layer of routing layer which in fact retries this. Also SBC can retry this. So we have the failovers all around the scalability, all around this part. So if the proxy goes down, we blacklist proxy and go there. In fact, we have another set of routing layers, and all this stuff, all these layers can fail over. So yes, and SBC also.
Okay, so if no other question,
then no. And one we have if it goes in the middle of transactions, we may have collision on the server. Yes, but we we can detect these collisions. So it goes to the server. Yes, and we handle this collision of there won't be 2 invites. There, we can set them.
Okay, then time for the coffee break. Thank you, Kirill. Really interesting to get these numbers out.
My name is Dmytro Bogovych. I'm
Wait a second, I'm
okay.
not sure if you're on. You're on? Okay.
Does it work?
Okay, sorry, don't touch.
Everything is good. Maybe a little bit more like so.
Okay, Dmytro, thanks for coming, and the floor is yours. Looking forward to your presentation.
Daniel, thank you for invitation. My name is Dmytro Bogovych. It's my first time on Kamailio World. Last 18 years I work as VoIP engineer, mostly in creation of end-user SIP stacks and media stacks. Plus, I also work in the domain of voice quality estimation software. And I would prefer to start with very basic things. On this, I think its diagram is terrible, but the basic things are already here. We know the SIP or Kamailio as its representation manages or directs RTP streams to end-user devices and between them. After audio is decoded, it comes to ears of end user. And it's top of VoIP as stressed in my humble opinion. And the quality of voice coming to ears of our customers, of our end users is, well, it's why VoIP exists at all, I think. Here I represent Savannah. It's a company that specializes on voice quality estimations. We work with such things as mean opinion score, audio impairments. We work with both types of voice quality analyzer softwares. And I would divide them on two types. It's active audio quality analyzer and passive. Again, I continue with basic things. Sorry, I think many of you know what is active, what is a passive voice quality analyzer, but I will prefer to repeat. Well, voice quality analysis, well, it's type of analyzing when you have a reference audio. So we can just send reference audio via audio chain, via IP network, record on another end, and compare with reference audio. It's good when reference audio is already present, because it very easy task of voice quality analysis. We can get a good accuracy, good results. But reference audio itself can be a problem, because we must have it to run this type of analysis. I think most of you know such voice quality analysis as VSCO. It comes in latest year. It's good quality analyzer. It's free. Our company provides our own quality analyzer, active quality analyzer, Aqua, which is just active quality analyzer. And Polka quality analyzer, it's maybe most expensive, most mystical quality, active voice quality analyzer, as in my humble opinion. Now I would like to talk about passive voice quality analysis. It's for cases where we have no access to reference audio. There is no ground, there is no hard ground under my feet when I talk about this, because how to estimate quality of recorded audio when we have no reference, when we have no good audio to compare. This type of passive voice quality analysis gives us interest abilities. And for me, the main ability is chance to run in real time. We can just stream recorded audio, captured audio to analyzer and get results immediately. Of course, audio analyzer, passive voice quality audio analyzer should support this functionality. not every audio quality analyzer can work in this way. Many of them are not stream-based. Examples of passive voice quality analyzer, well, it's pretty strange, but I think Homer is one of examples. Yes, it does not work with audio as far as I know, but it works with RTP streams which represent audio. And it allows to make some judgments about RTP streams, its quality, so in some kind it can be treated as passive voice quality analyzer. We provide our voice quality analyzer. It's PVQA, which just means passive voice quality analyzer. And there are standards exists P564 from Telchemy and P563 from Opticom. And I go to the next slide. Most of voice quality analyzer work with plain audio. It's understandable because they work with the media, they try to make quality estimation. However, in modern world, in many cases, we have no access to audio, but we can have access to network dumps, for example, or we can capture RTP streams and SIP data in real time, for example. To make a bridge between audio and network dumps, we built some kind of server solution, server monitoring software. It's pretty obvious scheme, I think. This software can capture network data, SIP, RTP. RTP, of course, should be plain RTP, non-encrypted. SIP can be TLS because we support HEP protocol. After it comes to the codec chain, we support many codecs. And produced audio comes to quality analyzer. It's usually it's our voice quality analyzer. It's PVQA. I would say we don't decode all the audio. We decode only sub-second chunk of audio. So in our audio buffer, we have only 600 milliseconds, yes. And on the output of this chain, we get quality estimation. We get information about audio impairments that were detected for last 2-3 seconds. It's a depth of analyzer, depth of voice quality analyzer buffers. Some technical information. We support SIP, RTP, RTCP, of course, and IUAP embedded in RTP. Mobile operators like this. Audio codecs are usual suite. G711, AMR-based codecs, IOBC, Opus. We can extend our server solution with another codecs. Of course, it's based on plugin architecture. Okay, what we can find with our software? Of course, we calculate mean opinion score. It's, from my opinion, it's some kind of, again, mystical estimation because we know the true MOS is taken from mass tests where real people estimate audio fragments and give us mean value. So we did next thing. Our software looks for audio impairments in decoded audio. It gives information about found audio impairments, about their probabilities, about their volume, level, about their length, duration, sorry, Sorry for my poor English. And basing on found audio impairments, basing on some heuristics that we collected for last years, we calculate a MOS. It's good MOS usually. It reflects the quality of call. Of course, for example, MOS for 5-minute call, how to calculate this? It's very hard because in a 5-minute call you can find any audio chunk with good quality or bad quality, and human decision is very subjective in this case. So together with MOS, we always provide list of found audio impairments and their metrics. It's more reliable and robust way. Of course, our solution also provides MOS based on network statistics. It's close to Homer way, as far as I know. It's based on RTT, jitter, delay, packet loss values, and plus various statistical information. I think everybody does it, do it. Some results. The story behind of this use case is the next. In one far country from Germany, government requires from transit or maybe even mobile operators to run quality assessment software on their network. They must provide reports every month to government that their network runs good, and the quality of calls transmitted via their networks must meet, I think, 80% of satisfaction. So 80% of calls must be good. So they installed our software and runs on their network. And some results. These guys have a really good network. They have a really good load on their network. It's, I think, it's about 10,000 of calls per day. They have no problem with network itself. The packet loss was really rare and almost doesn't impact call quality. Of course, some percentage of affected calls was, but it was not very much. I never have seen problems on this network with packet loss. 1, 2 packet of loss, it's every time can happen, but no problem. It's interested their end user, and now we talk about mobile calls, mobile GSM calls. They always have problems with echo. It's a significant percent. Every time when I come to dashboard, I could see 1 or 2 calls that currently have problems with echo, and one page in dashboard, it's 25 calls. So it's really problem addressed for them. The same is about noise. They always have a noise. Of course, the question is level of noise. It's duration of noise, its type of noise. But again, noise from outer world, it was always problem in their calls. It determined the voice quality in this network in their case. Finally, they good percentage, and they had no problems with their government. Performance of our software, well, these tasks to analyze audio in depth, to analyze RTP streams with decoding in depth, is CPU intensive. We work on transition these calculations to GPU instances, but it's not ready, but something we can do already. Talking about CPU-only solution, our ratio is 60:1, so we can decode, we can analyze 60 audio streams fully with all audio impairment detectors in real time. I tested this a few years ago on the cheapest, I think, 8-core AVS instance. So maybe for now it's even better. To overcome problem of performance, our solution can analyze a certain percentage of the calls, of course. Other calls, just checking for network statistics, we calculate the most from RTCP statistics. And another option to again overcome this problem is analyze, for example, only end of the call, because most probably if end user observes problems with call quality, he just hangs up the call. So check the last 20, maybe even 10 seconds of call is a good technique. Architecture of solution is, I think, is very obvious. It's capture of traffic. It's async architecture inside. There you call for service things like handling of HTTP requests, but it takes 100% from available hardware. Horizontal scan is available too. The dashboard can handle data from many capture agents. It's another example of our analyzer, which can analyze RTP and SIP. We had a task to automate the testing of media stack of one of RTC software, one of VoIP software stacks. In this case, we built a test scheme where we captured network dumps. When call comes, we captured also audio output. We captured also audio input. In this case, we also had a reference. And we combined all of this. And we could get information where our VoIP software stack loses the quality of voice on every stage. Plus, we could run TC utility to make these tests extremal. We added packet loss, we added packet corruption, we added big delays, so it's really helped. It made further production really stress-free. And another, I think, obvious use case, it's usage of our software with mobile operator support. It's one of our partners uses this technology to monitor and analyze calls in their networks. It's different mobile networks. They work with them. I think it was a Turaya satellite network and one of networks in Poland. Sorry, I forgot the name. They wanted to really early react on silent calls, on echo, which comes react to short calls. They don't use real-time capture. They just capture pickup files and provides to server, and it sends them report back, just usual JSON report. Okay, I finished. Thanks a lot for your attention. Any questions? Maybe in the future. Very good. Thank you very much.
Thank you for having me. It's been too long that I have come to Kamailio World, and it's like the best community, I think, so I'm really glad to be here. And yeah, I've been around, so I've been working with voice over IP and real-time communication like for 24 years. And recently, like in the past 2 years, I also work with eBPF and XDP eBPF to do softwares related to real-time communication like Turn, and so it was fascinating. I'm mentioning it because it's also something I like with computers softwares. It's when they give you low-level access. So with eBPF, for example, and XDP, you have network interface card access, and you can, or you have more control over the kernel, which I think is great. But with Kamailio, also, why did I end up loving Kamailio so much? I think it's because it was also low level. You have like complete access to the SIP protocol. So I love that approach, and I think that's why I'm such a big fan. And yeah, in Quebec, I found some nature also, and I was able to go get lost and play with voice over IP, work remotely. So yeah, recently I decided to try to do messaging with Kamailio. While we were facing the question, should we migrate the XMPP stack when we build this new app? And then we decided to go ahead with Kamailio, in fact. And for me, of course, I was not pushing it hard. I wanted everyone to agree because I'm such a huge fan. For me, it's more my something natural, let's say. But yeah, I think part of the reason why maybe we would do something like that, it's Kamailio is very good with connectivity, right? With SIP making calls, you're always, there's very good, it's very rare that Kamailio is failing to deliver a call because there was a strong focus on connecting with SIP, right? Initiating sessions. So I think it's doing a great job at that, it's obvious. And it's also, as time passed, there was module that gave you access to, let's say, sockets, so a granular level on connectivity. And yes, it was, I think it was in the best interest of the project because I've seen in the past like a messaging team, and so of course it depends on what is messaging for the project and the company, but I don't see a lot of limitations with Kamailio, but I'm probably missing some. But yeah, we'll look at what I have to say about that. But yeah, I will be sharing a lot of Kamailio codes in this presentation and the other Lua code, and there will be a lot of code on screen. So I decided to share the presentation in case someone is like, there's too many small characters, and I will share it in the next slide or two if anyone wants to have a copy. And yeah, in the past, I also did a lot of pastries when I came back to Quebec, and that's why I'm not trying to compete with Fred because it's but I could try maybe. But anyway, this is why I think I was trying to make some little recipes of using Kamailio to do something that not standard, like that not everybody does. So the way I will approach that is separating the presentation in two. In the first half, I'm speaking about how to use Kamailio to do these things that we may not do when we route normal calls, like store and forward and things that I have faced, like large messages. And so in part two, I think we'll have, for someone who knows Kamailio well enough to do like T-relay, failure route and things. That's the extra stuff maybe that you may consider using if you want to do that. And in the second part, will be how I like the value of being able to have this new channel to exchange data between the backend and the application. In my case, I worked a lot with an iOS application, but to exchange data from the backend so that the application developer, we can share things to him easily. So stuff from FreeSwitch because I use FreeSwitch a lot, or on the other side, get some stats from WebRTC over if you're using SIP over WebSocket to Kamailio. Yeah, so in the end, as the owner of the backend, how can you also use that? It's a new way to exchange data with the front-end developer. Yeah, so this is like the store and forward. It's kind of what is missing, because if there was no need for it, we would just do tier relay. So here I'm taking the example where we have ITSPs like Twilio or others, bandwidth, and they flow route, and each of them, I think they have HTTP now APIs, and some of them they have SIP APIs, but I'm just picking up. I think HTTP is the most common. So then, yeah, the message comes in, and then Kamailio has to answer the question: is this user connected? How many devices is this user using with the application? And can I send him the message now? Do I have to store it? And then when he finally registers back, so connect using a SIP register, then we will finally send him all the messages that were stored. So Kamailio has, for push, I'm sharing a little push server in Golang. I'm sure there is libraries in every languages, but in Golang there is a good APNS, Apple Push Notification library. So it was quite easy to write something. And for push in Kamailio, there's the T-Silo module, and there was great presentation from Federico, the author. And so you'll find, if you have question about that, I'm not speaking in depth about these things. So yeah, when the call comes in, I was saying Kamailio has a lot of connectivity features. He can answer a lot of questions using the registrar module. So how does the registrar module is, we learn connectivity information from applications, in this case, when they register. And using the save command, we save a lot of information inside Kamailio. In this case, I'm just adding one information, the device token, which is like the Apple Push ID you need. So I'm doing this so that the registrar now has almost everything he needs to know. I don't have to do anything else. And here, normally, you would have to save that device outside of the registrar as well, because the device is not always registered anyway. But I'm focusing on how to deliver messages quickly. So if the user is connected, the socket is there, I can send him the message immediately. There's no need to push, even if you could push on every message. So there's different strategies, but so yeah, we saved. Here we saved the message using the save registrar command, and then when a message comes in from the ITSP, we can use the reg fetch contacts command, which will return a data structure with multiple elements. And inside we will have all the precious information that we need to tell, is this device connected? Like we have the TCP socket mainly. That was used when the register message comes in, we took note of we saved the socket, and we can find it in the received parameter of that data structure. And then we can use another Kamailio module. When I was speaking about the TCP ops, that will just do some, I don't know which function it will just call the kernel function to say, is this TCP connection active? So the kernel thinks it's active. Maybe it's in fact idle and it will die, but chances are it can work, so we can use it immediately. I mean, in this case, we can send a message straight away to the socket. There's no need to push. And so if both users are texting, most likely everything is working and the message will just go immediately. And then if the user is not registered, like I've said, we still have to send pushes to all the devices that we consider are active for that user. So I'm not covering that here, but and then, yeah, to do the message storage, I'm proposing a solution here with the SQLOps module with in SQLite, so it's kind of fast enough for Kamailio. With database operation, you have to be careful, they have to be fast. SQLite is usually very good to be in memory, and there's no latency. So anyway, I'm proposing here a simple solution to store it. And then when the users finally register, then we need to recover all these messages. So I'm storing it per device here. And then for each, when the user registers, when a device registers, in fact, we will send all the messages that that device did not get. And we will use another Kamailio module that we will look in the next slide. But here we can see the route like UAC send message. So yeah, we are in this context, the forward part of store and forward, let's say. The user is registering, and we want to send him all the messages that we have stored for him. With Kamailio, we are always in the context of a transaction. So here we are in the context of the register transaction in my example. So we're just saying yes, and we're just saying you are authenticated, and now we can send you the messages that we think belongs to you. And for each of them, so yeah, we can see the UAC send message. So mainly it's using UAC request send, and that will generate a new transaction from the context of the Kamailio routing script, which is in, even if it's a new transaction, we can still have a reply route to verify, was this message really delivered or not, and take the decision accordingly to delete it or take the risk of transmitting it twice. And one other thing here is that, yeah, we configured a UAC module with all of these parameters in UAC_request. And one of the most important one is probably the RURI, where you can specify the exact socket that Kamailio will use. So in this case, I'm just sharing when did I save that socket that I'm going to use, because so it is the socket that was used for the register to come in. So I did save it I have it ND, but sometimes you need to you take it from the registrar module, or it depends on if you want to reuse that code to send messages in other contexts, then you may need to find the socket somewhere else than in the request coming in. But okay, so now we know how to store and forward with Kamailio. So maybe one of the next questions is, can we send large messages? And Kamailio is optimized, right? It was made initially to consume, to be super fast, even embeddable. And so no, I don't think it's a good idea to send large messages with Kamailio, but I mean, there may be different opinion on it. So you can increase the size of buffers and try to send larger messages. But even if you think about the MMS, they also do it like that. I think, if I'm well informed, the large messages are downloaded from a link. So you receive the link and you download it. So that's the approach I'm proposing here, with where you have somewhere else where you upload your large files, and then inside the SIP message you just have an envelope with metadata on what is that. Is there a media to download, and what will be the size, so that the application can act accordingly. Maybe if it's too large, whatever the front end guy decides to do. Yes, so I think with these tricks we can already send and do store and forward. So normally we have a few recipes to do it. So now I can go switch to the second part, where as the owner of the backend, I really like to be able to receive the data that will help me to troubleshoot, let's say, audio quality from the application. Or in the third example, FreeSwitch conference, I think I find them incredibly easy to use, but sometimes maybe we need a UI on the application to display who's in this conference and things like that. So it's an easy way to share and exchange backend and front-end information. So yeah, FreeSwitch call reports, that's the one I prefer, because something else I did last year was to use FreeSwitch for its jitter buffer in this scenario, with a scenario where you have an ITSP on the upper right side. You have the diagram. The scenario where you have an ITSP, RTP endpoint, but it is probably not expecting high jitter, the kind of jitter that you can find on a mobile device. The kind of jitter that WebRTC is dealing with. If you look at the report sometimes, So I used the jitter buffer. It was great. The jitter buffer FreeSwitch by default. I think it's a good piece, a great piece of engineering. It works, and it will reset and deal with all the possible error conditions that can happen when you assume things with RTP. But anyway, the long story short, I'm going too far. I made modifications to the jitter buffer to be more elastic, and there was some part of it was contributed. There was more testing was needed. So now I tested that with hundreds of millions of minutes with A/B testing campaign and different things. But because I'm the primary owner, I want to know exactly what's going on with that. I'm the primary tester, let's say. So I created in FreeSwitch reports, call reports that is telling us, so someone could say, that was one of the problems I had before I made that was some users were saying there's a one-way delay. And then we need to answer, where is this, you know? But when we introduce a jitter buffer, then we may introduce one-way delay, so we need to measure it, I think. I mean, it's best to know so that you can answer no, it's not that endpoint. So here we can see there's that report, right, that I'm transferring to the application. And you have, I cut the report in two because it was too large, but you can include various things. And you can extract them from FreeSwitch. In the next slide, I will show you how you can extract for those who don't know. But yeah, in the end, we can see 30 milliseconds, 0.52. That's the average amount of time the packets are spending inside FreeSwitch in this call. And then we can see this call was facing 31 milliseconds of jitter. And the jitter buffer is kind of coherent. So nothing was wrong or unexpected in the delay that was spent in the FreeSwitch. So these contributions, they are not yet merged. Maybe they will. I think there may be. We'll discuss it. But how do I transfer now back to the main topic of this presentation? How can I now transfer that report so that my power user can tell me immediately that call was one way, and here is why. You know, I'm already confirming that it was us. So here is the recipe. You have some FreeSwitch XML dial plan to set the session in hang-up hook, so that when you will call the Lua script at the end of the call, the session will be present. And then I passed an arbitrary variable, the user socket, that user socket that sometimes we need to have to send a message to. So we don't have to, because there's here I have a trick to pass it to FreeSwitch in the invite and get it back from FreeSwitch at the end of the session, so that Kamailio, during a call, at the end of the call, FreeSwitch can tell him, here is the report, send it to that socket and that user. So the little Lua script here is doing an HTTP post to XHTTP, like an HTTP server that you can host inside Kamailio. I think there's a new one, great news, because there is some limitation with this one. There is some, of course, it's not a fully featured HTTP server, but so in this recipe, now the second one, on the other side, maybe I want to know, was there a delay introduced by the WebRTC jitter buffer, or was there, someone is saying there was a one-way audio? Can I confirm that WebRTC was receiving the packets and the energy, there was some energy in it? So that's a little recipe to get from JScript, get the getstat, call the getstat API and send it over a SIP message. So pretty simple. Yeah, in SIP.js, I don't know why they try to hide the peer connection sometimes, like in TypeScript. I don't know why they feel like it's not something users want to access, but in JavaScript, you just access it like this. And then you can send the message to Kamailio so that Kamailio knows everything. So it's an example here of inbound RTP report from WebRTC getstat. So here, let's say we were trying to deal with that case where someone says one-way audio. So here is an example where Kamailio can produce the report itself. So he's receiving when the message comes in, we call that Kamailio route called WebRTC stats. And then it will parse the JSON, and it will have to compute the total amount of energy and and use the total amount of energy, the total sample duration, and then compute the average energy in that direction. So here I'm focusing on one direction, playback to the WebRTC. So what was played on the speaker of the device. So I'm including some Lua. Everything can be done with Kamailio Lua, apparently. I mean, you can do the maths, right? There is a Lua script, because in Kamailio you can do floating operation, and but Lua will help you there to do that kind of thing. So here we have two examples that at the bottom left, playback 0.05 on one. So that was not silence. Because it's an average, in this case, it's kind of hard to say, at least we can say it was definitely not total silence. But because you can call these reports at various intervals to get a better picture of was there one-way audio at one point or another. And .77, I made the test to really shout very loudly inside the microphone, and we can see we are close to maximum energy. But you need to, so it's on a scale of 0 to 1, where 1 is the maximum energy that can be sampled at that. And then you can convert if you want to sound pressure, but that becomes something else. You have to interpret things a bit differently. But I think, so yeah, that's an example where we reuse messaging to be a better, stronger owner of the audio quality, because you can easily speak with the developer of the app and say, please send me that, and I'll send you something else. And then one last example, it's the FreeSwitch conference, but just because it's the other way around. Kamailio is pooling from FreeSwitch. And then you can, so in this case, Kamailio is calling, it's using a timer process. Yeah? In Kamailio, let's say you want to run a task on a timely manner, so it's running every 5 seconds, in this case, interval, and you can use the R timer, and you can spin up processes, and they will run Kamailio script. Like in this case, they are running getConf status, and then they will call, using Lua again, they will call the event socket library in FreeSwitch, so they can run command to FreeSwitch. Like in this case, conference JSON list is being run, and so FreeSwitch will simply return all the information about the conference in JSON. And Kamailio, now we can use a message to send it to the application. And we will transfer, that's an example of how rich it is, the conference information in FreeSwitch. So who's talking, who is present, how much energy, again, who is an active talker. Someone writing the UI can use this information. So yeah, that's what I wanted to address. I think that's a lot. I hope it was not too much into detail in different direction. But yeah, thank you for listening.
Thank you. Yeah, so here we could notice the power of Kamailio scripting language combined with the power of Lua JavaScript, and I don't know if it was like an example here, but for example, for an alternative to using this JSON module for getting the fields, sometimes I use our app.jsdt, the JavaScript interpreter, which is embedded, because there you have like serializer, how it's called this in JavaScript. It's like native JavaScript function that from a string, which is a JSON, you get a structure. And then you can access it in the JavaScript. I need it once, and I think I had the example. I'll have it tomorrow again, where I needed to randomize the items inside an RT-JSON document. RT-JSON is another module in Kamailio. And randomizing this routing for serial parallel forking. So this just to give a hint, but I'm really happy to see people really using the power of this combination, Lua, our native scripting,
Sorry, I'm not using Chemi yet, but
but it's the same export.
same
it's inline execution, but it's unified. You get the same object, the same function in the inline execution with Lua run as you get in a native Chemi block or function. So it's the same API exposed. It's just a different way of writing the entire route block in Lua, or just executing snippets of Lua with Lua run or Lua exec. But it's the same API exposed. And you can combine it also with JavaScript or with Python, so you can have like all these languages together working to build your needs. And yeah, interesting approach with also with the reg fetch contacts. It's quite powerful, not that commonly used because it's easier to do lookup location, but as you said, you have a good view of the all attributes related to the location. So questions from the audience. We have Thomas.
Hi, thank you. You switched basically your protocols from SIP message to the client to, let's say, HTTP to your backend server. But sometimes, depending on your backend, it might make sense to also use a SIP message. Especially if your backend is asterisk, you can easily route messages into a dial-plan function. So that could be simpler for some situations. Did you try that?
Yes, like some ITSPs, they support SIP. So sometimes it's like SIP really end-to-end. Sometimes I find their support for SIP is removing some features, to be honest. But yes, you're right. I am using it with some ITSPs. Some of them, they just have a very good support, with the same level of support as HTTP. So you get, yeah. Thank you.
I have also a question. When you talk about this store and forward, right? For which purpose did you use the push server then, finally?
To do the Apple push notification? Yeah, I use that Golang library called APNS, but I'm sharing, you know, on my GitHub, I'm sharing an implementation of that library, but it's pretty straightforward. But it's an HTTP server that will send push requests so that Kamailio can use HTTP requests to...
Okay. Thank you.
But yeah, it's really, libraries are available.
Yeah. Hi. I have a question. So I assume you're using, you have an assumption that you will have only one device per registration, means in this delivery of the message, or no?
No, definitely
because you
not.
have delete message and...
Yeah, but because messages are stored per device, because I need to know, so maybe it's not efficient because I'm keeping one copy of the message for every device. So I'm not doing early optimization, right? But in the end, I took the simpler approach where I have one copy of each message for each device I need to deliver the...
Yeah, actually, I learned it as I played with this 5G SMS. In the mobile world, it's quite strange sending these messages because first, when I saw one on the wire or on the air, I was like, where is the two others? It was like a short number there, which is actually, then I discovered is the SMS center number, which is specific for provider. And then they use the same store and forward when the other device is known to be online. And we have this msilo as well, the module where you can store, but the classical SIP and
Which
sending
module?
out msilo.
Oh, msilo. Okay, I don't know that one, msilo.
But that's for user when they register to push what was stored for them. Here you have more flexibility because you store what you need for the device and so on. That is more generic per SIP user. And not here, but to add it for everyone, we have a custom instant messaging conferencing module, IMC. I have seen some companies building on top of it because in SIP is no like control protocol for like inviting a user to your chat room and so on. It's using kind of IRC, if someone remembers the IRC style of command /join that you can define via mod params. But I wanted to add, because I really like this proposal from Julien. I would have accepted other one from Julien as a developer anyhow, but this shows that we have a lot more capabilities than just routing calls.
I think we are able to move fast in this project thanks to these features. And if it's not, even if we change our mind later, I don't think it will handicap anything. It's letting us move super fast when you have a Kamailio expert to say, oh, no, we can do a lot of stuff so that the other teams are more free.
And actually, I think I made a proposal with what Kamailio can do beyond this voice kind of services to a conference. I wait to see if it's accepted. But if yes, you might see one in August, a presentation related about this, for who can guess what conference is that. It's not yet public, the schedule. Okay, so maybe last question, we're a little bit ahead, but if not, Julien, really appreciate first your contribution over the years.
Thank you, Daniel.
Thank you.
Pleasure.
And then for this presentation and showing. So we are preparing now for Tim, which has the honor to close the usual session, and after that we'll have a panel, and after the panel they should be pretty much ready for the cocktail party. And yeah, Tim, it's kind of last in the day, but I knew why I put it, because he usually has very entertaining presentation, which is suitable for keeping us awake and, you know, engage at the last part of our days, which I assume for some of you is tiring. You travel today in the morning, so I plan it to have it a bit more dynamic at the end.
No, well, maybe that, but it doesn't. Nothing moving, nothing exciting. No, I'm sorry. Apart from me, I'm the only thing that's going to move.
Some blinking lamp.
Maybe.
Okay, so I'm sure everyone knows Tim, or not everyone, but most of you from the past edition, but also from the web RTC and real-time communication world, especially with dangerous demos and interesting demos, not only Kamailio World, but Asticon, ClueCon, and ComCon, and all those events in our space. I let Tim to introduce more for himself and also looking to this interesting presentation. Thank you, Tim, for coming once again to us.
Yeah, so this is a kind of guide through what I've learned about 5G from the perspective of a somewhat confused and ex-VoIP engineer. So the background for this is that this is actually, by the way, this is me testing a baby monitor. And it's surprisingly hard to get relaxed enough to get that like heartbeat along the breathing rate along there as slow as that. But so we've been doing baby monitors for some years, and so we have a WebRTC stack that runs baby monitors, and that's the kind of context for this. But I got an email, I don't know, a couple of years ago, saying, would we be able to run the same code, put a camera into a race car? And the idea was that we could watch over, the users could watch over the driver's shoulder with a really low latency feed to the pit crew, who could see what the driver was doing, and maybe there'd be a driving instructor there and instruct the crew. And you know, they wanted high quality, low latency, and quite long range. So you're looking at, you know, typically the circuits is a couple of kilometers diameter. So you're just about, in theory, you're just about in Wi-Fi range. But the next problem is they move around at 250 kph. So tracking them with Wi-Fi is pretty much impossible. And we couldn't like just build our own network for these places. So I ended up thinking, well, we'll do it in 5G. By the way, this is it fitted in the car, so you can see the kind of feeling for the car. And so they've got a recording camera, and then that's an early prototype of our camera in there. So I thought, well, the obvious thing to do is you know, I've looked at the documentation for 5G. You know, we can do remote robotic surgery over it, so it must be possible to just like get video from a race car. You know, it's got low latency, high bandwidth, high security. It's everything we need. It's like not a problem, so we'll just do it. So, and you know, basically it's a question of replacing the Wi-Fi in that diagram, which is like, you know, on the left-hand side we've got an ARM SBC, a camera, H.264 encoder, some like Linux stuff, and our WebRTC stack, and a little bit of security in terms of the way that we do the auth with the patented auth mechanism. But like, there's nothing really exciting there that we're going to change. And we run peer-to-peer, which is kind of relevant for the latency. But you know, it's just replacing Wi-Fi with 5G, right? So a year later, we end up with this, which is actually quite good video coming out of a car doing, I don't know how fast that one's going, and you can see the driver, and there's no audio on this, but it doesn't matter because it's loud. But anyway, it doesn't, I mean, if it...
You don't want the video, now you get the audio.
Oh, okay, yes.
And race car sound is cool.
I do actually have a socket for that, which is like remarkable.
Yeah.
Right, let's see whether that... let's see how loud it turns out. There you go. So yeah, audio as well. And it actually disappears in my very regular basis. So anyway, that's 5G camera running over 5G in... I think that was in Portugal, but I don't know. These cars just turn up. But it's a fair question. Like, what took me a year? Like, why was that a year? It's just replacing Wi-Fi with 5G. How did it take me so long? And the answer is that it took me that long to realize that there is actually no such thing as 5G. Like, 5G doesn't exist, okay? In the same way, and it took me even longer until a friend pointed this out to me. There's actually a German word for it, right? Or a pair of words. And I'm not going to massacre the pronunciation, but the Germans have a phrase for the perfect, impossible perfect thing. And it's the perfect animal that would give you all the food you would need. And it's a mixture of a pig and a cow and a sheep and a hen. And so... yeah, that's pretty much what 5G is. It's this kind of impossible combination of all of these attributes that you really wanted from a networking protocol. And the answer is you never get all of them, right? So what this talk is about is a taxonomy of all the bits that you might get in 5G and what combinations you will get and won't get and under what circumstances. And I wanted to like have some kind of structure to it, which is surprisingly difficult. So I ended up basically taking the kind of mental image of the ISO 7-layer model. So we start out with the physical or the electrical, and I actually have two of these things. So I'm going to put them around, and if you could pass them around, I feel that in the physical layer you should actually see what we're talking about here. So that's a 5G modem. Like you'll get those, neither of them work, but when they work, they're like 200 euros each. So it's a substantial cost, these things, but even with something apparently as simple as that, it comes with a bunch of wacky choices, right? So that device can either act as a USB device or as PCIe device. And even within the USB device, you can talk to it over a serial port, a virtual serial port, but a serial port. And it comes up as a serial device in Linux. And you can send AT commands. You can like ATDT and all that. And even funnier, you can spring up a PPP channel over that serial port. But that's a mistake, because 5G can easily overrun that. Like it's not, you don't want your serial driver doing PPP over. And then the other thing you can do is you tell it, if you have the right drivers, it'll turn up as an NDIS device. So it kind of starts to look a bit Ethernet-ish. And in PCIe, it will come up as a different form of Ethernet device. So if you have the right drivers. So you've got a kind of bunch of crazy things there to start off with. And then wireless, like the next layer up, frequencies. Like, I'm old enough to remember 2G. And there was only one question you asked with 2G, which is which frequency? And it was either 900 or 1800 if you were in Europe, right? And that was it. We are now in, I don't know how many there are you could be on, right? And basically, it's anything from 600 megahertz to, on those chips, 6 gigahertz. And then there's a whole other separate band that goes up to, I think, 24 gigahertz or something more. Anyway, that chip doesn't support it. And anyway, those frequencies don't go through toughened glass or carbon fiber. So there's no use to me at all in a car. So the upshot of all this is that I end up needing multiple antenna. Like this device has 4 antennae on it simply because there are a ton of frequencies I need to be able to deal with. We're a hell of a long way from 2G. So even like once you've sorted out the frequencies, there are still a bunch of options about how those frequencies are allocated, or 2 options. Like they are either privately allocated, and as Ramona was saying, like the University TU in Berlin has a private 5G license, test license, but they have a private 5G license, which is geographically limited to the campus. So you can get those exist. And the interesting use case for those is things like farms, factories, and in my case, stadia and racetracks. So in theory, you could expect a racetrack to maybe have a private 5G license. And then the big case is public. So they tend to be national or regional and owned by telcos, and much more spectrum typically as well. You've got your spectrum now. What are you going to run over it? Well, in theory, you're running the pure 5G standalone. Turns out that I have only ever seen that in a lab. Like, standalone pure 5G pretty much doesn't exist. I mean, I'm sure somebody will tell me where it's running in like a corner of Dresden or something, but like in reality, I never see it. So what you actually see is NSA, which is non-standalone, which is LTE with 5G. So all of the signaling and all of the setup and everything is run over LTE. And then at the last minute, it says, oh, hey, by the way, I've got another chunk of frequencies that you can use for 5G new radio, and we'll do bandwidth aggregation over the 2 of them. What that means is that if you take one of those antenna off, you take the LTE antenna off, you get nothing. Right? So it's not, and you can see there, that's the modem reporting that it's being served by 2 separate cells, which may not even be physically on the same mast. One that's LTE and one that's 5G new radio, and it's doing bandwidth aggregation over the 2 of them. Right, so you've got like some connection here. Where's it going? Where's it going to end up? Like, where are your packets going to emerge? Well, you actually don't know, right? There's 2 broad options, one of which is that your video packet will arrive locally, a local breakout. Now, our users are typically only maximum 5 kilometers away from the race car, so it'd be really nice if the packets arrived in the same country. But that's actually not even quite often not the case. So in local breakout, they arrive in country, and if you're on a private network, they might arrive on the same Ethernet, but you don't know that. But that's what you'd like, lower latency. The home breakout thing is if you go with a tourist SIM, if I take my SIM, my English SIM here, and the chances are that the packets will emerge onto the internet in England, even though I'm here. And so that adds latency, and if you're really unlucky and and you're in, Macau, and you have an English SIM, then you might get quite a considerable round trip on that. There's jurisdictional benefits in the sense that Google thinks you're in England, which is useful in some respects, and so there are benefits to that. So it's provides somewhat more expected behavior, but on the other hand, from our point of view, it just adds latency. Right, so your packets have arrived, or emerging onto the internet. What's their from address? What's the IP address that I've got from this thing? Well, the answer is there's just astonishing variety. I mean, genuinely, I wasn't expecting. Well, I was expecting kind of one of these. I thought that we'd probably get NAP IPv4, but actually, realistically, I get a wide range. There's one carrier that gives me a routable IPv4, which is lovely. There's one carrier that gives me a /64 IPv6, so I can have more than one address. It was like, okay, excellent. But a lot of them give me CGNAT or proxied, so I'm a long way behind NAT in a lot of cases, which is unfortunate. And even within a given carrier, you get different behavior from different APNs. So just because you're on a particular carrier, you won't necessarily get the behavior you expect. And in theory, if you pay enough, they will give you what you want. But this is expensive. I mean, crazy expensive. Right, so you kind of wonder, how did this get like this? How did all this happen? And the answer is that the telcos have basically realized that the only use case for 5G is video. It's streaming video, well, not only, but the prime one is streaming Netflix and YouTube. And that's the kind of the mass use for 5G. It's the only thing that people notice for 5G performance for, and will pay a little extra for. So there's that. And then somewhat further down the line, and I think somebody was saying yesterday that this is very true in Poland, which is that there are communities where the 5G is a better internet access than it is for fiber to the fiber or DSL. So it's actually wireless routers are a business in some countries, but not in all. And then kind of somewhat down the line, there's people doing FaceTime and Google Meet and getting better video quality as a result, which is nice because it actually matches quite closely to our use case. It's quite closely related to what we're actually doing. We look very much like a one-way Google Meet call. So what I want on the left and what I get on the right is pretty much completely different, right? The only thing that I can actually control is that I want it to be PCIe and I can control that. The rest of it is just what I'm going to get from the telco. I've got no real, I have some control over it, but surprisingly little. So the practicalities, pricing. Well, this is just, and bear in mind the camera gets through 1 gigabyte an hour, right? So these things matter. And it turns out that the best bet is to buy a local SIM and buy an all-you-can-eat for the day. So for that, I get, I think I bought one today for €7, right? And that's as much bandwidth as I want to use for a day, which is a lot cheaper than buying an IoT SIM and paying like €1 a megabyte or whatever it is. This is crazy. Some of those prices are just insane. But the hassle there is you have to keep swapping SIMs as you arrive in different countries, which is inconvenient. So this is fun, but not as much fun as when you run out, which happens and has happened at inconvenient moments. And most of the networks throttle the traffic, right? So they give you once you run out, they give you 64 kilobits, which is just enough to browse to their website and buy some more, right? But just to make it painful, they'll send you an SMS, which is fine if it's on your iPhone, but it's not dead convenient if it's in a camera with no screen. So this is badly rendered at UTF-8, but basically it just says you're about to run out, and then it says you've run out, which is sad. So, and a few of them actually aggressively filter against the domain that you're allowed to access, but that's actually increasingly rare, which is good. So, the results of all this, like the big summary is, yeah, the performance is better than 4G. The latency is about 20 milliseconds lower, which is not enough as far as we're concerned, but it is better. And we're getting that particular camera, we're getting glass-to-glass latency of the order of 300 milliseconds. It would be nice if it was lower, but there are a few, the encoder has a few frames in a buffer that we should try and get rid of, but 300 milliseconds isn't far out for what we need. Weirdly, when testing this, and this is not really relevant to 5G, but it's surprising, Safari is 30 milliseconds faster rendering H.264 than Chrome. Like, it's a whole frame ahead. I have no idea why, but it's good. It's good to know. So typically we get about 4 times LTE bandwidth, which is actually, I mean, we get, this test I did the other day is 200 down, 40 up, which is almost exactly what I get from the VDSL at home, right? Which is kind of interesting. And we actually, realistically, for this camera, if we're careful about how we do the RTCP stuff and how smart we are about responding to that, we can get away with 2.5 megabit and still get decent quality out of it, which is actually quite kind of reassuring. So basically, 5G is fiber to the cabinet at 200 miles, 200 kph, which is like, it's quite an achievement actually. So don't get the impression I'm knocking, particularly the radio stuff in 5G is astonishing. So we have proof of concept out there being tested. We've got 3 cameras that pop up around the world and drive around racetracks. And we're learning a load of stuff from that. One particular track has 12 different cell IDs, and we hop like constantly around it. And it still works, actually. I was really surprised. We were getting kind of slightly worse than I was expecting results from this track, and then I looked at the fact that it was hopping cells every 30 seconds. And it works. And it's actually also switching between 4 and 5G, which is kind of interesting. So what you end up with that is very variable bitrate. I mean, really variable bitrate. So you have to be quite clever about your bandwidth management. So this is not a very good video, but it's interesting. So what you want to look at is the dial on the bottom left, which is labeled bandwidth. The top of the yellow is the target that it's trying to hit. The green is what the bandwidth estimator thinks you're allowed. And the pointer is what it's actually currently using at the moment. And what you'll see, so that you kind of interpret it, and there'll be a green blob that appears in the middle, and you can just ignore it. It's me messing around. What you'll see is that we leave a 5G area, enter 4G, and the bandwidth drops right back, and then you enter another 5G, and it comes back up again. So the display at the top is polled for the signal strength, and the 4 and 5G is polled. So it's about 3 or 4 seconds behind reality. So there you go. This is my wife driving near our house, and you can see the bit rate is decent. It's a megabit a second or so, and the quality is okay. It's not brilliant. And then now it's starting to go up because we're about to enter we're still in LTE, but we just entered a 5G cell, and there it goes. It comes up. And you can see the tree line sharpening, the images on the tree and the cloud getting less blocky. And then as we come to this roundabout, it gets worse again and then better. So there's this kind of weird, there we go, right now we're coming up close to the cell on this roundabout, and we're getting like 5 megabits a second available. So there's quite a range from like 1 to 5 megabits a second within, I don't know, whatever that is, a 15-second, 20-second movie. So, you know, even within a short period of time, we hop between cells and we change bitrate. And the idea is to try and retain the video at a quality that's still usable. So we're quite optimistic about that because it leads us to another use case, which is remote supervision of autonomous driving. So you have a remote supervisor who can look in on an autonomous vehicle and check, like if the autonomous vehicle reports that it's confused, doesn't know what to do next, then the remote supervisor can look in over its shoulder effectively and say, hey, yeah, there is a tree down and it is okay to cross the white line in the middle of the road because, you know, there's a policeman directing traffic or whatever it is. And so you can have these situations where the autonomous vehicles need a remote nudge to tell them what's safe to do. So we've got a grant from the EU to do that, to do suitability analysis on that, which I'm really pleased with. I want to thank the TargetX people for that. Really do appreciate that. So we're going to do some lab testing for that next week, and then we're going to do road tests, hopefully in the summer, in the Idiada test facility, which is a track with 5G masts that are somewhat controllable and tweakable. Unfortunately, we're in a kind of weird discussion with them about like what constitutes a camera and what we're allowed to take with us. So we may or may not end up going to that. Depends on whether they can cope with our idea about what cameras are and what they think cameras are. So yeah, I'm going to try and see whether we have a demo. That one. So this is connected. There we go. Wave at yourselves, and here it is. And what we can do now is I bring up the data. You can see we've not got, it's not got a huge amount of bit rate. We're like down at under a megabit. But well, the other thing you can see is that it's not just video. If I tip it, you can see that the kind of bullseye circle thing is actually a G sensor. So like, I shake it around, you can see the G sensor kind of spreads around. So we're doing kind of telemetry in both directions, and they can also do a bunch of fun stuff like changing the hue or the saturation, so that's probably a mistake. Makes you all look rather ill. And then the other thing that's fun here is we can set where we think is the region of interest. Where is it at the moment? So I can like set it to a dark place or a bright place, and that will change the autofocus a little bit now. Not significantly, but so there's a bunch of kind of camera controls you can do on that. And as you can see, the bitrate is still, we turn it up a bit and see, let's risk it. Let's turn it up to like, turn it up to it's 5 megabit and see what, you get a slightly, you see it's climbing now. Yeah, that's actually a better picture now. We're not getting the graininess when I'm tipping it as much. The lights aren't blurring in quite the same way. So that's a 5 megabit a second, and like it's not connected to the Wi-Fi. It's not connected to my computer. It is genuinely 5G. Deutsche Telekom, €7 for the whole day. So yeah, so that's that. And if anyone wants to come and play with that, I'm happy to do that later. And now let's get back to the thing. Yeah. So yes, that's pretty much all I wanted to say, except that what I didn't say at the beginning is kind of what I do. I mean, obviously I do pipe, we build these things, but I also do consulting for WebRTC and open source. Got a stack of WebRTC related protocol experience in those things, most recently with WIP, but back in the day, SRTP and ICE and SCTP. I work with those GitHub ones because obviously I know them really well, but also I'm happy to work with Pion and GStreamer and a little bit of Kamailio and a little bit of FreeSwitch, but those are somewhat distant past stuff. And obviously building stuff with pipe, I'm kind of delighted to do if people have got fun use cases like race cars or drones or, I don't know, whatever, baby monitors, anything. So yeah, final thing is, love to take some questions. I'm a little bit deaf, so you might have to shout.
Thank you, first. You know? Okay, so Tori and there was a Fred, okay.
So you said that with the 5G you have bandwidth aggregation between a 4G mast and a 5G mast that could be completely different towers. Given that, do you find as a result that you can have the media stream having radically out of order packets?
I don't believe so. I haven't seen it happen because it gets aggregated in the, what's it called, the LAC. So it gets aggregated quite close to the towers. So I don't think, I haven't seen it happen. But it's an interesting question. I've not seen it I've never noticed it in the packet logs, but it's not impossible.
Then it's Fred, and we have also.
On the demo that you did just now, which was awesome, the gauges and aspects, is that something that's done from the camera, from your browser, or from a server somewhere, and then as part of that is the demo? I wasn't 100% sure if you were connecting.
Good. Another really good question. So it's all rendered in the browser. None of it has gone through a server, but some of the data is stuff that's been extracted from WebRTC stats, like the bitrate graph, dial. I think everything from them comes from WebRTC stats. The G sensor is on the device, and it streams up through a data channel, constant stream of 8 bytes or something. And then likewise, there's another data channel that talks to the modem, and I poll the modem, like asking it what its signal strength is and where it's logged in. But so it's all peer-to-peer and encrypted over the same set of data, but some of it's gathered on the device and some of it's gathered in the browser.
Thank you.
Yeah, what's going to happen with the stream if the stadium would be full of people who are watching the cars? And everybody will have a mobile phone.
Yeah. Okay, so there's two answers to that. The first one is we're using 5G not because we want to hit 40 megabit uplink, but we only need 4. So we've got a lot of headroom. Like, we've got quite a lot of headroom. So if it works, and we have tested it at relatively busy race days, so we're kind of reasonably confident. But there's not a lot of uplink traffic at those events. There's a lot of downlink. There's not a lot of uplink, and we only want uplink. So we're kind of, well, not only, but largely want uplink. So we're kind of protected there. The other thing that's happening, which we may or may not be able to take use of, is there is a bunch of carrier standardization in the Camara APIs, which allow you to request prioritization. You pay for it, but you get an allocation of bit rate. I've never seen it work. Like, I've seen the documentation, but at least in theory, that's a route we could go down. But so far we haven't needed it. Now that's not to say we won't, but the worst place so far was Macau, because it's in a city, and because for safety concerns, they put steel shuttering around the whole track, and then they have tall buildings. And so actually the coverage on the track in Macau is terrible. Like we were down to like LTE only and really, really quite low bit rate. So I can't imagine what would happen if it then rained as well. We'd be like down into the noise probably. But yeah, so and those things aren't things that like the APIs can help you with. So yeah, interesting, again, good question.
Okay, maybe last one, Dragos.
Hi. I don't want to be rude or undiplomatic, but did you try to play with this for audio, right? The feedback loop for, the
Sorry,
bandwidth
you're going to have to shout.
Did you try the bandwidth estimator for audio with REMB, transport EC,
So this is, we're using, it's basically using the Chrome's REMB. So we tell it we want REMB. It sends us REMB, and then we kind of loosely interpret it because it's actually too vicious. So we put a bottom end on it. And the other thing is that there's a whole art, science, something, I don't know, to do with how you do probing, how you probe to go back up again. And to be honest, I'm still experimenting with that. I have looked at transport wide CC, but we're only sending one stream. One audio, one video. And so it's actually probably not worth the extra effort to implement.
For bundle, when multiple streams are, using the same port for source and destination.
Yeah, so the audio and video are in the same bundle. So I don't think, Transport CC is on my list of things to look at, but I don't think it's a huge win. Might be, but I don't think so. We should have a nerd out with bandwidth in a minute, over a cup of tea or a beer or something.
Yeah, there is social networking party with beer and wine and other non-alcoholic drinks.
Excellent.
But later. We are not yet finished here. So, okay, thanks, team, again.
Other one of these?
Okay, so now we get set up for a panel. So I'm gonna just pick up some of you to get.
But you want this
in exchange.
Some here in the front. I don't know. We have chairs, but maybe we stand up.
Brilliant.
So let's add AI from FreeSwitch, right? It's past and future of communication. Dragos, come here. The one here that did IMS, core, and stuff like that in the past. Nick, you came from Australia, so you need to come together. I haven't asked Lorenzo, but we need WebRTC, so before, so it's part of our, so let's not get so.
Where would you like the chairs?
Chairs, yeah. You can put put it there. Okay, who else are
Yeah, I know,
here?
right? I keep saying grazie, scusi, and like,
Lucas, sorry, it was really good experience that you have with such large deployment, and for sure we'll evaluate your feedback. 2, 4, 2. We have enough chairs, I guess. 1, 2, 3, 4.
Yes.
Okay, take the seat just to be sure. We'll have everyone. Okay. we do a little bit of emergency services. You want? I haven't asked you, Wolfgang. You want to come for the future of the emergency? Only if you feel in the mood. And I was standing up, so trying to moderate. I'm trying to bring variety here, so I'll put this somewhere in the middle, would be easier, or I'll take the one. Can I take this one and I'll give the...
Yes, yes, you can take this one.
Oops.
You have one? Okay, we have.
Is it okay? Can you hear me? Okay. So it's nothing prepared, but the idea is that soon we'll switch to you asking any kind of question. And as we have to look to the future, I want to start with a question related to the past. What was the most annoying or what you hated to our real-time communication so far? I don't know, technology, specification, documentation, whatever. Just to know what was wrong in the past and how to do it in the future, or how the things can be improved. You have the microphone and you can say what you hated so much and sometimes you wanted to just quit real-time communication.
I mean, the obvious one is too many options, right? Sort of loosely defined standards like SIP can be transported on UDP or TCP or SCTP or TLS. You know, these sorts of things where we're given perhaps too many options and every vendor does things differently. That's been the cause of, you know, my receding hairline for, you know, a number of years now.
Okay, so you don't like that the user can type its own two-header and put the display name with quotes or without quotes, so it can put the...
Yeah.
Okay, I understand. Maybe, Dragos, if you hate it or if you love everything, it's fine.
Well, you know that you mentioned that I worked on IMS, you know, and it's a little bit, I don't know, ironic, funny, whatever you want to put, however you want to put it. You know, that I worked on it almost 20 years ago as a research project, and we put so much energy into it. It didn't happen until the technology that it was supposed to replace really died. So, you know, until 2G, 3G died, or it's still a little bit alive, it's not happening. But now it's interesting that it's happening. So, yeah, I really hate sort of the technological cycles of the telco world.
Okay. Let's finish on this side, Wolfgang, and then we'll start from Lucas.
Well, as an engineer, I don't hate technology, so I like it very much. But actually, what you said is also happening in another domain. It's emergency communication. And I actually started looking into the standardization 15 years ago. So it's quite a long time, and I hope to get things, because there are a lot of cool stuff with technology and with real-time communication. I hope to get those things into this domain as well, and hope I don't have to wait another 15 years.
Okay. Lucas, from the other side.
Yeah, so I think we were talking about how too many options is a bad thing. I also feel like one thing being a little bit maybe newer in the space. I mean, I started basically messing around with VoIP in 2016.
Can you keep it closer?
So I started basically messing around with VoIP in 2016 when I was still in college. And I think a big thing that stood out to me at the time was just sort of unrealized standards. Like, we have a lot of interesting specs out there where there's a lot of interesting academic ideas. I think of like enum, for example, where maybe there's a future where everyone's phone just connected over the internet via DNS. And we've never seen that implemented. You know, it was interesting in an academic layer, but in terms of actual practice, you know, we still rely a lot on these sort of legacy telecom companies and their infrastructure, and we haven't really been able to fully realize, I think, the potential of voice over IP.
Okay, nice. And WebRTC, everything is lovely, gonna kill telecom.
Real sunshine, no, in general, yeah, I guess Lucas already touched, for instance, on the topic of the partial lack of standardization on some things that is in part something that frustrated me in the past. But more in general, and this is sometimes still a problem right now, for me, it's mostly a matter of when you start working with codecs that are not really that open, and so you end up in situations where you cannot really use some specific features because they are part of a proprietary codec, or maybe they hid behind pricing or something like this. And coming from a standardization perspective and an academic background, I tend to prefer stuff that is much more open instead. So typically video codecs most of the times.
Okay.
Yeah, I would say that I love it all. My frustration has generally been centered around just the idea that things are not being adopted as quickly as I had hoped or wanted them to be. WebRTC talking about that a decade ago, saying it's just around the corner. It's just around, the IMS, same thing. Just things move at a glacial pace, and when you talk to telcos at a high level, they are fine with that. And so trying to marry the idea of web speed development with the telecommunications layer that is most decidedly not has always been a constant source of friction for me.
Okay, then to go a bit closer to the future and approach a little bit the AI, because it is the time of AI. Where do you think, okay, it's gonna impact us maybe as engineers a little bit, because we saw like with FreeSwitch as a service provider, IVR making it, but will it somehow help us, the engineers, I don't know, with automatization or, detecting at the network layer, where you see that AI impacting in a good way the engineering, not the end user, because there are some obvious benefits, but here we are mostly engineers, we want to work 4 days a week, right? So if someone can do the work for us, 2 days when we have to be at the office, because the other 2 days we are at home and we'll cook anyhow. Okay, so do you see that AI could actually improve the behind scenes technologies in a way or another? Nick, you want to?
So one of our guys, and shout out to Dave if he's watching, took all the 3GPP specs that is the Bible for how IMS works, and he fed that into a large language model so that we could sort of ask it, how the hell does this work? And it's not as good as someone who's actually read the specs and understands it, but it's sort of good at searching. But the catch we found playing with it, and tools like Copilot and stuff, I've forgotten how to write Python for loops, because Copilot does it for me. And I feel like I'm getting dumber as time goes by the more I use these sorts of tools. So I'm not sure if it's a good thing or a bad thing yet.
Anyone that want to take it?
I have a lot of opinions on this, so I let other people talk. I think that there's a number of, I think your example is great, right? You can feed it things like the 3GPP spec or the IMS spec, and then bringing new people up to speed on the topic, it does help find information they need to get a lot quicker. So for people who are worried about it taking entry-level jobs, I actually think you can use it as a way to make what is a very dense, acronym-heavy industry a lot more accessible to people who are just brand new showing up. And on the flip side, for advanced developers, you can do things like, well, if you feed it a lot of your code bases and things like that, it can help. I use it to help generate tests. So I know it's a lot of the test infrastructure that I use, so I'm just like, generate a mock for this thing. And it just does it, right? Again, Copilot might be making me dumber, but it's saving me a lot of time where I would much rather be thinking about more interesting stuff. So I really do appreciate the fact that those tools are there to help from an engineering standpoint. Or if you're diving into some code that you don't really know, that's particularly an open source project like FreeSwitch, or you can literally ask it questions about FreeSwitch that have been answered somewhere on the internet at some point, and it will spit out a dial plan for you. And it might not be perfect, but it'll get you 85% of the way. You figure out the rest of it, and then you're good to go. And then you'll write yourself into a corner that you have to get smart again for.
Okay.
I must admit I have not used it much so far, but my experience is that I've asked ChatGPT who I was, and it said I created Janus with a guy that I have no idea who he is. And ChatGPT doesn't think the professor that I learned everything from even exists. So basically, for now, I'm I'm just waiting to see when it can actually help me, but...
I taught it that.
Wolfgang?
Yeah, we as Frequentis, we are in the control room business, and we are actually looking into AI as assistive technology in the control room, for instance, to enhance audio quality. So in some situations, in some domains, we have a lot of background noise, so in air traffic communication, for instance, and there were some clever solutions around that use AI to just remove the background noise and enhance the audio quality, which is quite interesting for us. And the other thing I have in mind is to use AI in the control room as kind of assisted service to the dispatcher or to people in the control room, just for non-emergency purposes. So if you have, for instance, a chatbot that is very intelligent, it may answer some calls to emergency services that are non-emergent calls.
Yeah, so I think one thing that excites me when we talk about AI is most people look at kind of the big flashy object right now, which is generative AI. And I will admit I'm generally an AI skeptic, but it is quite amazing how much that technology has matured. But I think another thing for us in the communication space is if we look at kind of older uses of AI, for example, think like doing voice transcriptions, sort of these ML type applications, maybe even just making things like codecs better, or making something like answering machine detection. I think that creates a lot of potential opportunities for us to innovate in the industry and see that make the voice channel more exciting again for users.
Okay, Dragos, you want to add?
Yeah, I think there is one obvious use case here for this conference, I guess.
Which one? Take my place? Okay.
No, I hope I'm not going to kill your business, but I think it would be, you know, if somebody has the time and they want to go down the rabbit hole of LLMs and so on, there is a great resource, olama.org. Gets you started, at least for me. It's heating up my office right now with all the power that it's using locally. But I think one maybe direct application could be if we could have Kamailio routing script copilot plugin for Visual Studio Code or something like that.
Replace me.
Yeah, that's exactly what I was going after that.
I was thinking to replace me as here at the organizer because... Okay, so maybe if there are questions from the audience, not to monopolize, anyone that wants to plug something right now before I continue? No? Let's go to the next one in the spectrum of kind of, you come from different fields, so here would be probably different kind of approaches. But somehow, again, in the relation also with open source and the other tools, what was kind of still missing to get it smoother? Like we see IMS, we have hard time to integrate it with other open source projects. Maybe at the voice layer it's working, but also with integrating AI. So how this kind of integration should go? Now everyone seems like APIs should be standardized now, when in the past they said, protocol is too rigid, but now my feeling is that with the APIs they end up in the same kind of, we need to standardize it, like we do it like this, but then others doing like that, and still when we want to build something larger, we have a problem. So as I know also with standardization, so standardization it's actually blocking, or it's good for like evolution and innovation in your particular fields, like emergency, like WebRTC? Do you feel the need for it? Or?
Oh, good question. Actually, I think it's more enabling because if you look at emergency communication, for instance, you have different stakeholders. You have the UE, you have the originating service provider, you have a kind of emergency services network, and then you have the control room. And this needs to work together, otherwise you would not be able to dial call 112, for instance. So this is a very important part, so we need standardization. But I do not see this at an API level. It's more at the interface level. So it's actually IMS, SIP, and that stuff. Yeah. We do have other interfaces which are HTTP based or JSON things, but this is more a closed user group or a very specific domain.
Okay. So did IMS standardization stop roll-up of IMS or speed up? I'm joking. Just
yeah.
So you.
I think when I started with it, what was it, release 4 or something like that? The spec was small and sweet.
How small?
When it got to,
only 150 pages.
When it got to release 8, we were like, this is too much. Let's not do it. And now it's release 17. So but of course, things stopped along the way, so it's not that bad. They didn't go on linearly. But I think, talking about APIs, and just before there was the Camara was mentioned. Yeah. I think, that's one direction where I would say, no, we don't need those kinds of APIs. Okay. We need APIs which are working, for which we can sign up today, and don't need to be a big operator to sign up, kind of. Or maybe we need better interconnects with the current operators, not new ideas of how they could take our money, but never kind of figure out how can you start if you're small, with that API.
Okay, Nick.
I mean, to sort of build on what Dragos just said, I think when it comes to, at least from the big carriers' perspectives for APIs, in a lot of cases, Camara Open Gateway is a prime example of trying to tell customers what they want rather than asking them what they want. And that's something that Twilio has done really well, of giving customers the tools they need. And, what you guys are doing is the same thing, of giving developers what they want rather than telling them, you need this feature, get it from us, Yeah,
and I think there's the idea of that there should be a common way to address all of them is an excellent idea. I do think there is the idea that, if there were some wildly successful version of this, everyone could just kind of coalesce around it if it made sense, sort of like the S3 API that's now sort of the default for file storage, right? It was not the best, but it was there, and it got enough traction that developers they now expect it. And then everyone's like, great, well, we'll support that because it's important. And I think also one thing that's missing really, just even from the low level, is the idea that all the tooling, all the open source projects that we all use to build a lot of these systems still sort of stand on their own a little bit. There are interop guides and things like that, but there's not really a sort of holistic way that someone can approach and be like, okay, I need this and this and this to do X, Y, Z. And that all the projects are becoming more and more specialized and more good at the things that they do. It used to be that you choose one FreeSwitch or an asterisk or something else, and you could pretty much get all the same functionality. And things are really starting to get more and more refined in certain avenues, whether it's Janice going certain directions or, whether it's Sean Dubois and the guys over at Pion doing stuff. Everything is having a really, really great time focusing on what their core competency is. And I think what that means is there's a good answer to a lot of questions, and that's hard to find right now. And you might stumble down the wrong path for quite a while before realizing that there's a better, easier way. And I wish that there was more about that people could dig into.
Yeah, but that's actually a good point, because it touches to, for instance, your question about is standardization limiting research and stuff like this, or is actually helpful? And the answer is it's pretty much in between, because I'm a firm believer in standardization. But for instance, when you look at WebRTC, you see that WebRTC standardized, they mandated the usage of SDP, they mandated the use of RTP and stuff like this, but signaling, there is no rule for that. And I think that was what actually made WebRTC so successful, because it gave people leeway to start experimenting and do a lot of things that you couldn't do before. So you can now use it for SIP, for conferencing, or to watch a race car drive around, as Tim showed. And I don't think that WebRTC would have been so successful if there had been also a standard on signaling itself, had it been SIP or anything else, because that would have limited the ability to experiment and and try and do different things and so on and so forth. And of course, I think there is a limit to that and I'm afraid that we are going in that direction instead with where media over quick is going, for instance, because in that case, we are going towards a much more silos-oriented kind of media communication where you only have the very lowest level. You have a standard at the very lowest level, but then you can build everything on top of that pretty much for however you want, which means that Cisco will do its own thing, Microsoft will do its own thing, and nobody will be able to talk to each other anymore, which is something that, even though we don't have a standardized signaling, is something that we can still do right now. Janus can talk to FreeSwitch and to Kamailio and other components because we all talk the same language over there, and that's helpful, I think.
Okay, Lucas?
Yeah. I guess one thing I'll say is when we look at something like WebRTC, so that standardizes a media stack. And I think when we consider like which API should be standardized and which one should allow flexibility, it really comes down to we should standardize the core infrastructure as much as possible. Like I think the fact that WebRTC doesn't mandate a signaling protocol is not a huge negative because building a signaling protocol is a lot easier than building a media stack. And so WebRTC gives you this primitive of we have the browser, we need to do real-time audio and video through the network, but you can still build your own application topology on top of that. And it's both good and bad. I mean, I think the good is it means people can build signaling protocols that fit the shape of their application. I think the bad is we're kind of going away from, there's never going to be like, for example, WhatsApp talking to some other over-the-top messaging app here. There's not a standard protocol like you might have seen of XMPP or something back in the days where everyone like envisioned all of these services being federated together. Of course, you see people talking about that with things like Mastodon and social media, but I think we're a long way from that in communications. And if anything, we've retreated back from the days of instant messaging.
I do think that the Europe has the right answer here by forcing regulatorily that interop must be a factor. I think that some of this has to come from the top down. In the U.S., the SMS industry in particular is completely unregulated, and that has led to a huge amount of the issues that we're dealing with. And I'm not saying, for the record on camera, it's not saying that necessarily needs to be regulated, but it has simply been part of the problem is that these things can't talk and they can't be open like that. So there is absolutely a place here where that needs to be part of the conversation is how to make that enforced.
Okay. Now, anyone with questions from the audience? Come on. You have here some. Thomas, you want to ask or not? You are okay. Just okay. Then let's. I'm coming with a microphone if someone wants to ask a question. Then let's move a bit to the future. So, what do you expect to happen in our field, like real-time communication in the next decade? What will be something from any kind of perspective, technology or user interfacing services, where everyone wants to move and lead the way of evolution for the real-time communication? Probably hard, just your idea. It's probably still AI related, right?
Or work from home related. I think that changed since the pandemic quite widely, and
Is it good or bad, working from home in terms of evolution, like innovation? Does it help or?
I think it does, but it also moves us to be more couch potatoes. But saving 2 hours of commute, you cannot. Going through subways and so on, the connectivity was always bad, so I'm happy we don't have to solve that anymore, maybe. I don't know, if we all stay home, if we can.
I'm excited for the future of RTC when it is applied to things like, the Apple Vision goggles, things like that. When we have, XR and AR and those things that really demand advances in both, bitrate, codecs, everything related to having to stream the holographic environments, anything like that. I think there's so much there that will have to be unpacked and a lot of work, and it will tax infrastructure, it'll tax the way things are built, it's going to create a lot of work for you, Lorenzo. I am so sorry. Yeah, hopefully. So I am pumped for that in the next little while. And I think that people like Apple who are releasing these things, even though they might not be fully baked yet, are kickstarting that ecosystem. We have only to see great things. So the next decade, I think, will certainly be AI-based, but beyond that, absolutely all of that XR. And I think that's going to really put a pressure on real-time systems and wireless systems. And I'm excited to see how they respond.
And driving, like self-driving cars, is gonna happen because it was quite big activity at some point. Now some setback, in my opinion, not much noise, or maybe it gets settled on the market.
And maybe, I don't know, self-driving should be safe even if wireless fails. So.
You see them in LA a lot. I point them out to my kids, and I'm like, "There's nobody in that car." And they're like, "What?" And they press their faces on the window. So they're doing it, and they're out there. I just think it will certainly be part of it. I think that that's more of a, in my mind, like the 5G sort of the wireless system with IoT. It's less necessarily what we in this room are focused on because there's telemetry aspects, but there's very little RTC involved in that necessarily from what we're talking about. A lot of message passing, but they're coming. I just think they just need I wish it were here now. Where's my flying car, Daniel? You promised me.
Yeah, last year.
Yeah, that's Kamailio 7. So
yeah, but we saw like a couple of technology being kind of good to adopt, not so fancy, but like it was Lucas mentioning before, Enam, it's simple, not hard to deploy, but didn't actually happen. So it's why I'm asking. There are a couple of other technologies in the past that looked promising and nothing happened. Now with also like in Germany recently, I heard that it's kind of a huge setback from buying electric cars because some people are not as happy as expected, which like 2 years ago, everyone was like just electric. And there are some cycles, like it's enthusiasm there, and then
the hype cycle.
Yeah, the hype cycle graph, right?
Yeah. There's a trough of the trough of realization or something.
Yeah. The hype cycle, the trough of disappointment, and then it's like the reality, and it finally got. And I think we're somewhere down there in some of these things right now.
Okay, so the same question, all these kind of like AI-based, I don't know, AVR or other services, and maybe after a while, because now everyone complains that like ChatGPT is not as accurate as it used to be in the first releases because it's a lot of more information and more noise that it's, and maybe also with this, I want to command like order a pizza and then instead of, I don't know, mozzarella, I get Hawaii.
I do think some of the companies do a little bit of a disservice to the public that is not as into it as everybody here is by releasing those videos that Google will do of like calling a place and placing a hairdresser like 3 years ago for Duo or whatever. They'll release basically videos that are not real, and the public eats those up, and they're like, why can't that be real now? And we all know like those videos were marketing efforts, and that is frustrating. Because it really impacts our ability to get them like hooked on what's real. They're thinking too Star Trek-y, too far in the future, and it's like, nope, we got to get there first. And
speaking of that, because actually from FreeSwitch SignalWire, he posted recently on some channel, if I remember, that he made an example with the FreeSwitch SignalWire API, like restaurant ordering, right?
Bobby's Tables.
Yeah. And then she got like stats from like whatever Google or so on that there were so many customers happy there or something like that. I don't get it. So that's for sure AI generated. So it got like probably some discussion on the online channels, and then AI can feed you back some, let's say, misleading at least report. So maybe it's still some time till we trust these bots behind. And okay, Lucas.
Yeah, trusting the bots aside, I'll push us in a different direction, which is what would everyone expect will be the popularity of different channels in the next 10 years? So think voice, video calls, and text messaging, or just any form of text-based messaging, not necessarily SMS. We often hear that, for example, voice might be a dying medium because a new generation prefers to send text messages or they prefer to tap on an app. I don't necessarily think that's true myself. But then again, I'm a millennial, I'm not a Gen Z, so what does everyone think about that?
Yeah, that's a good question. I mean, eventually it really depends on the scenarios that we'll encounter. So for instance, there was the discussion before about how the pandemic really accelerated the RTC development. So WebRTC evolved a lot during the past few years just because basically there was a huge demand for it in the first place. And that basically pushed video ahead in terms of what's required and what not. I'm Gen X, so I'm even older than you, so I don't have an exact answer on that, but I think that video will still maintain a very important role in here. Maybe not strictly conversational video, but in terms of just video delivery, possibly in real time and so on, I still think that video will will still be quite important within that context, and even AI-generated video on the fly. So you're talking with somebody that doesn't really exist or something like this. That's like an avatar or some sort. Yeah.
Yeah, I think it's really context dependent and dependent on the consumer, the person who's using it. I know people who, like my wife, who really just hate, even though she's a journalist, she has to call people all day. She hates getting on the phone. She will only text places or look it up. Conversely, I don't mind calling. It's not a big deal. I like hearing it gets stuff across faster. So I think that voice is not dying. I think that people are just being driven and are allowed to choose the method of communication that is the most convenient for them. But I think the important thing is being able to keep context across them. So if I do switch from voice to texting and texting to voice or into video, I want the history of mine, and I brought it up during the talk, like that to me is the most critical part that we could, as businesses, get fixed, would be just knowing who I am and knowing my interaction with that entity and keeping that in memory. That is, I think, going to be potentially something that will be baked in everywhere and people will come to expect it.
Yeah, I also think it's a matter of the right medium for the right communication, right? Like, we're not sitting up here on stage typing out our answers with text bubbles that pop above our head. That wouldn't work, And conversely, there's other times where if you might be hearing impaired, where that might be a more practical option. So I think as long as we've got a gamut of different options that suit the different needs, the different capabilities of the people who want to communicate, I think there's still going to be a large number of different options, and that means that we'll all keep our jobs.
Yeah, actually, you're right. So the European Accessibility Act requires to have audio, video, and real-time text available in 2027. So, as you said, accessibility to emergency services means that you would have something in addition to voice, because not everyone is able to speak, or you might be in a situation where you can't speak but need emergency services.
And how about being able to tell if the other side is just an LLM or a real person? And I don't know, how do we bake that into SMS? Because I think that's easy to fool. Right?
But also the voice now is...
Voice, and also video. I think I went for something like 6 months until I met some of my coworkers. And, we were joking, it's good that you're not just a bot or something.
Yeah, that's actually hard to get the proper feeling of the identity, like it's real or not. The person you start to, have a conversation over the years, and then maybe you have a surprise that you're discussing with just a bot. But actually, I saw some stories that when these bots could help like elderly people, that they can just need someone to talk with and getting some feedback or like a near like a human conversation could be also helpful for some in our society.
I think one of the highest grossing the iPhone apps initially were virtual girlfriends and virtual boyfriends, because I think it is very much understated how desperate people are for interaction, and they'll take it anywhere they can get it. A lot of people are not, with billions of people around, there are certainly a large number who will happily talk to anything that gives them emotional support. It's how all of the SMS scams work, right? I have a friend that I know that was recently going through some relationship trouble, and he, this person got on SMS, and he knew it wasn't real, but like it made him feel good, and he's just texting back and forth. And only when they finally were like, download my crypto app, and like, let me show you how much money you can make tomorrow. He was like, I gotta stop talking to you now. But it gave him what he wanted, and I was like, yeah, man, I get it. And if you could talk to somebody like that, and maybe, I could see how that would be impressive. And we've done some studies also on how people respond to hearing voices of people they know, like a virtual Daniel. And if it's you, Daniel, your virtual voice talking about Kamailio, let's say it's but people know it's not you, but it's still recorded you, they actually don't particularly care. They're happy to hear you talking about your subject. Just having the idea of being like, almost like it's a recorded concert versus being live. They're like, oh, well, I know it's not him, but he authorized this and he wrote this and it's his voice and I'm now associating him with this and it sounds right. There's a lot there to sort of unpack, and doing a lot of research into that.
Okay, last chance for a question. We have one there. Finally, some courage from Nicholas.
So Daniel mentioned looking at the future that he had a question about AI, but I also think in the future a big topic is going to be satellites, the LEO satellite networks, and what they mean for ubiquitous connectivity, because we see now they want to have these satellites act like base stations so that the phone can directly talk to it. And then also in the future, you might be able to even deploy applications into space so that they run in these satellites as a new kind of edge computing. So I was wondering what the panel thinks generally on this whole topic. I think there's also additional challenges because the links are less reliable. You have more jitter and packet loss sometimes and latency. So yeah, just like an open-ended question for the panel to discuss what they think the increasing availability of these LEO satellite backhaul links will mean for real-time communication and more.
So the main one I know about is AST Science, right, are deploying these. And it's an amazing technology, particularly for outdoors access and backwoods access or rural access in underdeveloped countries. I think that there is a lot of work still to be done. If you notice, they were a SPAC company and their stock price has gone down quite a bit. I think that they are running into more problems than they expected, getting this technology to work reliably. It also does, large battery drain on the phone to talk into space. It is quite far away. So they have some stuff to overcome there. The opportunities are amazing. Having coverage all over the world from space would be game-changing. Again, there's a lot of problems with, I'm sure Tim could talk about the roaming stuff, the 5G. From space, being able to penetrate into any kind of dense urban environment is negligible, so you still have to have, unless they get some sort of spectrum on the low end, but then having to do that. So there are a lot of trade-offs to the space towers, and I think that it remains to be seen if, as a business model, it will be incredibly successful. I think that it certainly has a lot of opportunity, and companies like AST will be the ones to figure out whether or not that is worth the capital to launch. And again, that comes back to launch costs, and LEO satellites decay faster, and so how cheap can they make these things? And there's a lot of stuff there has to go into it, and I think we're a little ways away.
Yeah, we did, earlier this year, we did a demo of non-terrestrial networks, so the 3GPP, NB-IoT stuff for SMS, and we did the first SMS over non-terrestrial networks, so essentially SMS from space. And I don't think it's necessarily going to be it's not going to be a mass market product, at least in its current form, because it's still, when you expand the size of these cells, you share that capacity across all the subscribers on those cells. And so with LEOs, obviously, the beams are a lot smaller, but they're still pretty damn large compared to a cell tower that might cover a 5-kilometer radius. Now you're covering hundreds of kilometers, or in the case of some of the GEOs that are also doing this, that are in orbit today, thousands of kilometers. And when that resource is shared between such a big number, even a voice call is a struggle to get through. It's also not super new. We've had at least two-way messaging and voice and internet through space with Iridium in, 1990? So as to how much of a game changer it will be, I'm not sure, to be honest, but I think we'll wait and see. But I don't think it's going to be a mass market product.
Okay. Thank you for the answer. Anyone else? willing to address concerns of current communication or future communication. If not, probably we can have the last round of your opinion about the future, what you think is going to happen, or I don't know, what you want from the others to happen, or what you want to do in the future of communication from your perspective, your project, your company, your service. Like anything new that you think it's going to impact somehow in a smaller or larger scale our world in a better or worse manner. Okay, Dragos?
I don't know if I want to start a lengthy discussion, but how about open source licenses and license models? But at least on that topic, I have to say that I think it's a great time right now to have so many open source projects that we've seen the demo, that you can actually put everything together on one laptop and run all, a complete mobile network from end to end with all the services. And I think that is empowering for a lot of people to try to just make things differently. The industry, sometimes they have efforts like Open RAN, which might sound in that direction, but I think the open source community is going to react probably differently and just make things simpler, just make it work, make it cheaper, more affordable, and then put it in the hands of everyone.
Okay, so open source is something for the future still, okay? Anyone
Well,
else?
it depends on the license, but yeah,
Okay.
I don't know, let's have a few beers.
Anyone else?
I mean, there's still a lot of people in the world to connect. I mean, we're here, I guess, in Germany, which is quite a high socioeconomic country, but I think there's still a whole lot of countries that are still coming online for the first time, who we've got to offer some form of communications to, and that's going to look very different to the phone company that's existed for 150 years. They're going to build something greenfields from scratch, and they already are. And these networks, I guess, look a bit different. I'm excited to see sort of the innovation that comes out of those markets.
Anything?
Yeah, no, from a technological perspective, I mean, the one thing that I'm looking forward to both eagerly and a bit with potential low is basically quick in general. So, and anything that can go above it, because basically we are getting towards a world where quick becomes the new internet hourglass, basically. So you start shoving everything over quick just because it exists and it's nice. And one of the things that you see there is, of course, HTTP3 and web transport and stuff like this, but within the context of real-time communications, media over quick is the new sexy thing that people are working on, basically. That could have an impact, not in the very short term, because I think that SIP and WebRTC are going to stay for quite some time and so on and so forth, but it's starting to add also some new use cases, and it may have an impact on how we do things currently in general. And it's definitely a technology to have a look at and to start figuring out also how to interact with it possibly and things like this, and how it may have an impact on telephony or any generic WebRTC application out there, because it's trying to tackle basically any kind of communication approach.
So do you mean we have to implement another option for transport layer for SIP, right? We have
Maybe, I don't know. We'll see.
TCP, TLS, and let's make one to unify all, right?
Over IPv6.
Yeah, over IPv6.
Over IPv6.
Yeah, I think that there's, I'm excited about the idea that of a couple things. One is to get people new to the industry. I see some pretty young new faces here, people who have not been in VoIP for a long time, and it's exciting to try to get new folks in and provide them tools, both open source and the SDKs, and anything to get people moving with communications faster, get them building interesting things in new markets, people who might not have as formal of an education or who don't have as much access to this sort of knowledge base and talent that's in this room, getting everybody able to get to these resources. And then on the academic side, I'm also very excited to see more papers coming out. Things like, the Transformers paper was so transformative for all of the AI stuff that's happened. That research continues, and it just bubbles away in the background, and something happens. I know someone was asking earlier about codecs and AI in them. There was a machine learning in the VP9 codec, I think, that was part of their superblock analysis that sped up encoding by like 16 or 19%, something like that. So these little things, the little tweaks that kind of keep going along, and I really am excited for folks to just keep digging at the hard problems, and then folks like us can go out there and use that to create things that the average person can then take advantage of and benefit from. Yeah, OpenSSL, exactly.
Okay, so I guess from Wolfgang, it expects that NG111 will be rolled out in the entire Europe in the future.
Actually, it will be rolled out in the whole world.
Okay. That's NG911. It's compatible with NG112?
Just to be honest, in the future you won't have this kind of numbers. You have service URNs, and they are global. I think in the future we should have those capabilities for emergency services. So as I said before, accessibility requires actually to have real-time text, to have video, and to have audio. And the more open source we have, I think the more it supports standards being deployed. And I think from a company's point of view, it's also a good drive for innovation. So because you get access to a big source, and then you can use it for prototyping. You can use it for first implementations, like we do a lot of interoperability testing as well in this domain of emergency communication. And not everything needs to be a product first, so it can be based on some open source, and even if it's a product, there will be open source in it for sure. As you said, the future, I think, should have those capabilities available for emergency communication.
Okay, thank you. Anyone that wants to add last remark?
So I have one more point, which we were talking about connecting all people in the world to communications. And I think just to sort of channel an old sort of 2008 Twilio vision was connecting all businesses in the world. And I think this is one thing we've seen with, again, the advent of open source. As well as these providers that make this easier for people to access that don't necessarily have a communications background. And that's that every business, whether they're small or the biggest businesses in the world like the Amazons and Googles and Microsofts, will be able to communicate with their customers the same way. Really democratizing that technology and making it accessible so that if you're small, for example, mom and pop doctor's practice wants to make automated appointment reminder calls, they can do that just the same as like a major hospital chain could, for example.
Okay. Then I think we are almost, 6:30. We are ready to wrap up the day. Thank you, everyone, for being courageous to come and come. For the rest of the day, I think they are preparing, if he's not already prepared outside, but if he's not prepared, probably in half an hour, everything will be settled up outside for a cocktail party, some food, some drinks. So beer and wine included, non-alcoholic, it's included. And probably if someone wants something like spirits and so, there is a bar in front of the registration, but you are on your own. Should be enough. One question, because I had a discussion because everyone leaving. So who has been at all edition of Kamailio World besides Ramona and myself and another person? Has anyone, that person should not stand up yet. Has anyone been at all Kamailio edition in person?
Except the COVID ones.
Okay, so it's only Federico then, right? You still here or he left? Okay, so we don't count it, but yeah, I was curious because we've been discussing in the break, and Federico is the one that was at all the editions so far, and I was curious if anyone else besides, of course, me and Ramona attended all of them. I would love to skip some of them, so don't take it like it's something bad that you had to skip it. It's just I was curious. Okay, thank you for everyone staying so late as well. I know it's a long day. Many of you started in the morning, but hopefully with some beer and some refreshment out there, the day can continue. So it's cocktail party, so everyone can move around and discuss. Thank you.